Hello, everyone. We're live. This is the DevOps Global Summit 23.
Yes, and as one of our members on our platform, Muhammad Tayyab, said finally, and I say finally too. Yeah, thank you, Nick. I had some technical troubles with getting myself to the scene, but thank you for helping me. Hello, everyone. I'm so happy to welcome you people here on our DevOps Global Summit 2023, which is our third event from Geekle about DevOps problems, DevOps solutions, DevOps ideas. And I will quickly remind you our mission here at Geekle. 6 months, we work hard together. The most interesting ideas, the most influential ideas, new paradigms, I don't know, tools, and new tech. We combine everything in this stream, in this conference, to let everyone can touch this stuff. So you don't have to go to very far conferences or expansive. You just can turn your internet on, log into our platform, and consume the most fresh insights from the tech world. That's our mission, and I'm happy to see everyone here. By the way, I always love when you people write in what city, what country you are right now. Just share about this. It really excites the team that we are working, with global audience. For right now, we have more than 250,000 developers in our community, and almost all community are watching recordings, not a live stream. But for those who are here with us today, we have some perks and gifts and everything. But now I want to invite our team, and so please, Lilia and Paul, come join us. Say hello. Yeah, here's our team. Hey, people.
Hi, everyone.
Hi, everyone.
How are you there?
Thank you. I'm still excited about our third summit. So it's always like a first time.
Always like a first time, yeah.
And I'm excited about some partnerships that we have. So we have I would say probably a publishing and educational partner, Manning. So we will post them in the chat a little bit later, and you have cool discounts for the books. They have books on DevOps. They have books on many different technologies. So yeah, we will have some cool discounts for you. So stay tuned. Also.
Cool, thank you. And a little more numbers about this event. We have more than 2,000 registrations by now. And we expect for 28 speakers with 27 topics. I believe 2 people will talk about like the same topic or something. And our conference divided as always by 2 days, like first day 4 blocks, 9 hours together, and second day is 4 blocks too, and 9 hours more. That's how it works. So please feel free to pick topics you like from our agenda. Come join here live stream, ask questions on Q&A sessions, comment in chat, win some stuff here. But the rest, I understand, 18 hours, it's crazy. But sometimes people even see it and watch for from start to the end. But it's kamikaze or ninjas can do that. So just watch all this content later. It's all accessible for you if you have access, of course, on our platform.
Yeah, and of course, everything will be recorded, so don't worry. But we expect you to be active through the Q&A session. And of course, we recommend you watch this on our platform. If you're watching this already on the Geekle.us dashboard platform, welcome here. And if you're watching this on YouTube, consider joining there. We have, for every session, we'll be showing a banner that you can use to leave a like if you like the session, which helps us to collect feedback easily. And yeah, like I said, please participate in the Q&A session, and you'll have chance to win one of the 2 tickets that we'll have for tomorrow for the senior track.
Well, so join us on our platform and win tickets. Okay, but now I see in our chat. So hello from Nigeria, Germany, Lagos, Nigeria, Turin, Italy, Akil from India, France, Belgium, Mozambique, Germany, Pakistan, Italy, India, France. I think I read in just a list of all countries of the world, because Turkey, Serbia, Tunisia, and Serbia again. Where is it? Haiti. Okay, so like people from all Pittsburgh, USA. Like, people, are you crazy? 5 a.m. Yes, that's what I wonder always when people watch us from the opposite side of the world. Like 5 a.m. Thank you for joining us. India, Lithuania, yeah, it's enough. So I'm really excited. We work for international tech community. Well, one more thing, and I feel it's really important. All this event, all this conference was gathered by another girl. Her name is Miroslava. But it is a war in Ukraine, and she is a volunteer at the military services of Ukraine. So she was called, and she now in the fields. We don't know where. So yeah, and Lilia like catched up this event and helped us to finish it. So yeah, during this war, we don't stop, and we're trying to deliver our best. Lilia, tell us more how it was like catch this event after someone and finish up. Give us some words about our speakers.
So yeah, it was a bit exciting, because we with Nick created agenda 1 month before event, and I connect with all speakers from Mira's emails, and it was a secret for everyone that I'm continuing a project, and I hope that every speaker, every moderator don't feel this inconvenience. Yes, so
seamless transition, right?
Yeah, like that. So trying to collect the best topics on our event here today, and we will have DevOps professional guide and team management tools to boost the DevOps performance, Kubernetes topics, automation at scale. So I hope everyone will enjoy this event, and feel free to ask your question to all the speakers. Feel free to write your minds, write your impressions about our event, and don't forget to put your likes on our main page. Which topic you like the most.
Yeah, because we move. Thank you, Lydia. We move to crowdsourced content. So we really need your opinion. We really need your fingers up. We really need your comments and your ideas, or I would love to hear more about this, not about this, and I love that part. So please give us more information. Well, it's a GPT chat era now, but we still need to understand like what's in your minds, people. Okay, no more words anymore. I mean, if we mention everything, people, why don't?
Well, I have only the last remark to add. Of course, lots of people are watching this only this junior track that were registered for today, but we still have a special offer. If you'd like to join the senior track tomorrow, you can check the agenda. We have awesome topics for tomorrow. So we have special offer. We have 5 tickets. The first 5 tickets you can buy for only $99. We'll post the direct link with the promo code, but the promo code in general is DevOps99. So if you go to our website, the first 5 people will get a special discount for the ticket.
Yeah, so it doesn't matter what the price on the website, just for for people who's here, just grab at the lowest price. Yeah. So last time I say Sri Lanka, India, Lithuania, Mexico, Bangladesh, South Korea, Luxembourg, Tunisia. Again, people, welcome here. And I'd like to welcome our first moderator here, and I struggle to see.
Yeah. Welcome, Hugo,
hey.
to the stage.
Hey, team.
How are you?
I'm super happy to be here with you guys again. You know that I'm more than a fan of Geekle and all the speakers that we have, so I'm really happy to be here. And yeah, whenever you want, we can start. But yeah, thank you for everything, guys. You are doing you know that you are doing an excellent job with preparing all these events, and there's a lot of knowledge, and I love knowledge and sharing it, and yeah, it's great to be here.
Thanks for these kind words. It's really supportive. Thank you. The stage is yours. Do whatever you think it makes sense.
And please introduce the first speaker, of course. Yeah.
Yeah, and thank you for contributing here. Yeah, now I'm leaving.
Okay, team. Well, I'm Hugo Loza, system engineer with around 25 years professional experience. And as I said, I'm super happy to be here. We are ready to kick off this amazing summit. As you know, DevOps is a set of different practices that are intended to continuously improve the delivery of incremental value and in a fast-paced, automated, secure, and well, we are going to figure out all the other things that are DevOps during this summit. So before we start housekeeping, I think the team already mentioned that, but it's good to start with that. We have a Q&A session after the three talks that we are going to have now, so after the three speakers. So please write all your questions in the chat, so we can, in the end, in the Q&A session, we can ask everything to our speakers. So let me start. I'm going to introduce our first speaker. This is Sven Peters. Sven is a DevOps advocate at Atlassian. So let me add him to the stream. So hello, Sven.
Hey, how's it going?
All good. I'm here also at 5 a.m. So I'm in the other
side
of the world, but it's nice to be here. So Sven, I think you're ready. Probably you can present yourself and then let me know when you need me to add your presentation.
All right. I mean, you can add my presentation now, and I can just do it full run here. Great. Thank you very much. Oh, wow. Perfect. So developer joy, right? So you might think why is this person from this developer advocate or DevOps advocate from Atlassian talk about developer joy? I mean, everyone knows that we have the best job in the world, right? We just enjoy what we're doing. We're just so creative. So what is this talk all about? So this talk is more about just what happened actually also in the last 10 years, because there's a lot of stuff putting on the shoulders of developers all of a sudden, right? It's not just writing code, it's much more these days. So there's this cloud coming up, right? Everyone is now working in the cloud and working for the cloud. We need to learn new toolings, new ways of working. The cloud is different than working for on-premise. Containerization, everything runs now in small little containers. Containers got spinned up, spinned down. We have the observability. We need to orchestrate all those containers. Then microservices changed a lot, right? We now just have our services that have a defined API. We change this API. Is it still compatible? What is if the other microservice on the other side is not there? What should we do? Or just security and governance, right? This is also putting on the shoulders of developers now, because we didn't have that before. And now with the cloud, obviously, we need to think about those things too. And then the whole you build it, you run it, ops side of things, that we are now responsible for our services, also in production and running those and doing support for the services 24/7, all putting on the shoulders of developers. So with other words, from a developer point of view, our developer cognitive load has increased a lot, right? So no wonder that actually now everyone is talking about this topic here, developer productivity. make our developers more productive, right? Yeah, if you put more things on our shoulders, maybe you see like productivity is going down in one direction. Don't get me wrong, I think all those changes are great and necessary. But let's look a little bit about productivity, where it comes from, and how we deal with productivity in development these days. So, and with that, I want you to take you on a time travel. So what we do is now we travel actually 125 years back in time. So please bear with me, stare at the screen, and I count to 3, and then we travel in time. Are you ready? Okay, let's go. 1, 2, 3. Here we go. 125 years back in time at the Bethlehem Steel Factory. And the Bethlehem Steel Factory had some productivity issues. So what they did is they couldn't call McKinsey or the Boston Consulting Group, which we do at these times if we have problems, right? The business has problems, we call those consultant companies. No, they actually hired a person called Frederick Winslow Taylor. And Frederick Winslow Taylor, maybe you know him. What he first did is he looked at the factory workers, observing what they are doing, right? And then he took out his stopwatch and measured things, right? And he measured like how fast they could shuffle and how much they could shuffle. And then he thought like, the shuffles don't look really like they're very effective. So let's give them custom-made shuffles. And boom, productivity increased. Great. The next thing that he did is just like looking at how much people could carry, right? And obviously they could carry more in the beginning of the day than at the end of the day. So what did he introduce? Yeah, make more pauses, right? So make more breaks in between so we can carry more actually. And by just like a couple of these changes, Frederick Winslow Taylor increased the productivity of the factory by 400%. Boom, right? But that's just like one side of the coin. The other side is like that he also just like gave workers repetitive tasks. Everything was just like stopwatch, very repetitive tasks. And the managers, they were supposed to do the thinking and telling the workers what to do. Sounds familiar? But this is 125 years ago and we're not running factories, right? Okay, I tell you, I'm just like bringing you back in the year 2023, right? Developer productivity. How do we measure this? When I started at my job, my boss told me just like, okay, tell me how many lines of code you added this year. This is not a good measure of productivity. We all know that, right? We can write a lot of lines of code, but doesn't mean that we are super productive. And then we came with like, how many tasks can we do, right? And then we were measuring that. But we all know like tasks are smaller, tasks are bigger. So yeah, so let's estimate the size of the task, right? And measure everything in story points and see how many story points we can do in a sprint. And then we just like estimate that and the Fibonacci numbers, right? And then it's a 2 or a 3, or we don't know really. And then it turns out it should have been some other number. The story was way more complex than we thought. So also this is not a good measuring of productivity. We make it easier with t-shirt sizes, didn't help either, right? Or cycle time these days, or development frequency. So with that, also just like if you measure that and say, oh, we need to increase the deployment frequency, right? We put more pressure on the developers. Thank you very much, Frederick Winslow Taylor, for this. And we still have this, right? So no matter what we talk about, like we can game the metrics as developers. We're smart, right? We're super smart people. So nowadays, everyone is talking about this here, developer experience, right? Improve the developer experience. And don't get me wrong, I think great. It's a better conversation to have than developer productivity. But then smart consultancy companies come up and just like give us frameworks about just like how to increase the developer experience, right? And also that, don't get me wrong, maybe good, but it's just like not feel the right way anymore. So what we think about Atlassian is this here. We think like if people enjoy what they are doing, they are productive. If we just like became developers for a reason. Like this is a craft. This is a very creative process, right? And what does it mean? Like enjoying what you're doing. Like of course the team should be great, the product should be great, cool. But how do we do that on a daily work? Like enjoying what we're doing. I think like if I work on great quality code, high quality code, I'm enjoying it, right? Working on shitty code, probably not. But working on high quality code, yeah, sure, right? Or if the work just like progresses fast through the development pipelines, right? Yeah, if I can have an idea on Monday morning and get it in production on Thursday afternoon, wow, work is flowing, right? Flow is very important for us. Then we think like we enjoy what we're doing. And then also, if we create value for our customers, if we take pride in our work, we are proud of what we build. I'm enjoying what I'm doing. So just like, let's dive into those topics and see like how great teams actually improve their developer joy. And let's start with developer quality. Let's assume you have a great product, looking shiny, looking cool, looking great, looks like this maybe. And then your customer comes and says, Sven, can you please change the small little thing at the window there? And I said, yeah, sure. Yeah. Let me just like open the IDE, open my code. And then I see all those duct tape code around, and it takes ages to make the small change, right? And we all struggle with that. We all have that. Every team in the world has that, every software team. It's called technical debt, right? And here's some statistics about technical debt. We did a short survey with a lot of developers. 42% of development time is actually used for dealing with technical debt. But just like 10% of developer teams actually manage technical debt. You can do the math pretty easily, and it's like a downturn. We just like go deeper and deeper and deeper into technical debt, and the 42% will be just like more. But why is it? Why does it happen, right? Because, well, everything starts out nicely, assuming you have a nice class written just like great, it looks cool, it looks good. And then I go on vacation, right? I just like take some vacation, check the class in, I think it's great. It's very, very short and very concise. And then I come back and look at the class again. And oh my God, what has happened to my class? What has my coworkers been doing? Also here, right? My coworkers didn't just like consciously want to mess up my code. They just like did it, right? They're just like, okay, I have to add this feature. Maybe they were under time pressure. But if you have coding guidelines in place, they should have caught this, right? You have coding guidelines in place, right? Okay, they catch this, right? So here's what the Bitbucket team did. So they have the Python coding guidelines, and you can see like things like line lengths or no tabs or things like that. Pretty much easily can be caught by static analytic tools, but things that I just showed, like single responsibility principle, maybe ChatGPT can catch that in a year from now or so, right? But now we just like have to catch that with what? How do we do that, right? If we just like we have the single responsibility principle, and this what I showed you just like violated the single responsibility principle. Yeah, right. Through code reviews, we can really do that. So you're doing code reviews, right? You're doing code reviews, right? So yeah, good. We have a common understanding here. Every line of code that I can edit to the code base should be reviewed by one or two coworkers, or even more if you want to do that. But let's look at some code reviews and what the problem is with code reviews and why not all the teams are actually doing this, right? So let's assume I have added this code here, and then I get the comment from a reviewer that says, "What the Sven?" Right? I say, oh God, I'm already just like, my heart keeps pumping, my pulse goes, right? And just like, okay, what did I do wrong here? Or just like, oh, this code is ugly. I said, okay. Just like, I'm super just like down on code reviews right now. I don't want to do them anymore. I feel like I'm done with code reviews, or even just like comments like, oh, it would have been nicer if you would use a for loop, right? And then, what does nicer mean? And what does the ugly code mean? Just tell me more. Don't be a jerk, right? Don't be a jerk. So if you have jerks on the team, just like tell them, don't be a jerk, right? Because jerks are actually the reason why people hate code reviews, or why people not doing them for every code change, right? So just like work on that. And just like be consciously, write down your rules for code review. And if someone violates that rules, then just like go for it, right? And think about it. You as an author and this reviewer, you're in this protected bubble. Yeah? You just like can throw things at the author. But the author is actually opening up their work and say, oh, give me feedback for my work, right? And we should appreciate that more, right? So assume competence from the author when you do things. Be constructive in your feedback, right? So people can act on it, and explain the reasoning also so people can learn from it, right? Not just like saying a for loop would be nicer than a while loop. Just like explain your reasoning. So, but now Sven, you might ask, what is great developer quality? So if I have one thing to say, it is this, like, how do we measure developer quality? And we are at DevOps Summit, right? DevOps Global Summit here. Of course, we need to talk about this here. Start with the DORA metrics, right? So change failure rate or time to restore are great ways to start with measuring your developer quality for the first thing. Then you maybe get nice charts. But what is also very important is that you create non-negotiable baselines. So say you want to just like have a change failure rate, and you just like miss that, just like stop and look at it. Why does it fail, right? Don't just like, don't keep it running. And that's also what I call like the wallboard problem here, because there is a problem with wallboards. And you know, back in the days when we were all in the office, they were hanging in the office. Nowadays, you just like open a browser tab and you can see like, but if everything is red, you just like keep ignoring that, right? And no one is actually looking at the wallboard all the time. So what we do actually at Atlassian, we have established this CheckOps. Our teams are doing this weekly ritual where we just like come together as a team, look at the quality metrics, see if we just like have just like crossed the baseline, or just like we talk also about just like lowering the baseline, because we're getting better all the time. We need to improve our developer quality. And then we just like write down actionable takeaways. The second thing I think what I want to talk about is the progress. And if I talk about progress for software developers, is probably developer flow is just like a thing, right? And we can have nicest keyboards, turn down our notifications, cancel all our meetings, and get into the flow and code. This is when we are most productive. Great. Then it's when things flow. But it's not only that. So we're doing just like more than that. So development is just like also building and testing and deploying things and actually making service support for things. And even if we cut down the coding phase, like, or just like the build and test phase, like hours to minutes, we could parallelize tests and all those things, optimize the hell out of it. Just like also the deploy phase, we can just like make it faster, look at what's problem with deployment and just like improve it. But there's one important step in the middle of those that just like takes a lot of time, like the review phase. And we just talked about code reviews for a second ago, like can take days. Actually, one team at Atlassian measured it once, and they said just like, oh, we need 3 days averaged from opening to merge a pull request. 3 days means working on something else. And then after 3 days, you go back and look at the comments and just like say, okay, I will change it. But just like your mind is already somewhere else. So we need to cut down that time, right? Also to just like deliver value faster to our customers. So one team here said, okay, all the open pull requests here on the left, and then the reviewers just next to it. And one team lead, actually, Puneet Arora, came in and said, okay, I'm going to do it. I'm going to ping everyone in the morning and said, you might have missed the notification yesterday, but you are on this pull request, you're a review on this pull request, so please review and just like close the pull request so we can merge it. Of course, this is a job like not probably for a team lead, but for a bot. So actually they replaced Anud, then not replaced, but replaced this task with Puneet, and then just like called it the Puneet bot, right? So they have created this bot that's now pinging everyone in the morning. And guess what? They cut down their time from 3 days to 1.2 days. That means better flow. So when we talk about flow and when we look at flow, like I'm obsessed with that, and I looked at traffic junctions. So this is a traffic junctions with just like super chaotic, no rules at all, and the simulation says the traffic flow is 191. So 109 cars could pass. So this is this. So chaotic things like we don't want to work like this. Maybe in the startup mode, but probably not just like if we grow bigger, right? So we add some processes to it. That's called traffic lights with traffic, right? So let's add some traffic lights and make the simulation again, right? Can we pass more cars when we have traffic lights? Yes, we can actually. It's 235 cars can pass in a specific time here, right? And then it's like, this is not how we want to work. Actually, we don't want to just like have red light and stop working. And then just like if green light, we start working again, right? This is not how we work. We work more like this, like in a roundabout, right? And then every time there's a slot, we can slot work into this, right? We can just like slot it in. If we need a design task and the designer have a slot, we just like slot it in whenever there's a free slot available, right? And the traffic here is around 360. So it doubles actually from chaotic to just like this roundabout, which is more like an agile way of working. But stop, we're not stopping there. Actually, if we look at the stack interchange, right? We can pass a lot of more cars in that. And if you see like the simulation here, the cars are just like flowing, like no one is like stopping down. It naturally merges into each other. And the traffic flow is 1,099 cars. Boom, right? What does that mean for software development? You might ask. Good question. So it means like we need to build more autonomous teams, right? And autonomous teams work on different features. And of course, yeah, we don't want to go chaotic with autonomous teams. So they need to be highly aligned, right? They need to be highly aligned. So we need, of course, then designers on the team, developers on the team, testers, and ops people on the team. So we own the feature end to end. But we don't have enough designers to put it on every team. We don't have enough testers. So what we do is actually we replace them with developers. They are now using a design system or they're testing their software themselves, right? And they're running the software. Yeah, the Trello team had this too. Like the exploratory tests were done by the QA and the automated tests were done by the developers. So let's go more for autonomous teams. So actually also developers are doing the exploratory tests so they don't have to wait for the QA to do that. And the QA can now sit on an island somewhere in Bali and drink pina colada, right? It's not like that. So QA is called at the Trello team quality assistants. So they assist, they help developers to do automated tests and to do exploratory tests. How do they do that? So before a developer starts with a feature, the tester comes in and said, okay, how would you test it? And then they write down a test plan. And at the end, without having the QA engineer involved anymore, the developer can test the feature, right? With a test plan they have put together before actually the feature got developed. So the developer understands better how to test things, and the tester is helping the developer to become a better tester. Or automated test platforms. This is what the test team also, the QA team also owns, right? They own this platform. They help developers to set up a test database and all those things. And the developers just using this. Also this way, the developers are just like, can move fast and they just get helped by the QA team. Which means like more developer flow and less developer cognitive load. So they don't own the whole thing. They just like get assistance from the quality team. All right, so what does great developer progress look like? Well, we already talked about the DORA metrics. Also here, DORA metrics, deployment frequency, lead time for changes is a good start where you want to start. So look at those and start from there. And the last thing that I think needs to be improved is the developer value. So we want to be proud of our work, right? Where's the disconnect here? So here's a car, right? And this is what users imagine that you would build, right? And then you just like build it and think like, oh, I built a car, but I need to add more a little bit. Like I think the users can have just like this car here. Has a big cup holder, it has this antenna with a tennis ball on top so you can find it in the parking lot. All great ideas, right? All great ideas, don't worry. But this is not what actually the customer really imagined to have, right? Or if you have just like very extrovert boss, right, that demands the design of a car, the car will look like this, right? Anyway, so from product people are probably taking care of all those customer demands, right? They're doing the research, they're doing the measurements, they're doing the interviews, experiments, prototypes, you name it. And then they just like have the knowledge what to build. And then they put everything into small little user stories and hand it over to the developers that build the running software, really. And if we don't know about all the research and measurements, we probably build not the right thing. Even though the user stories are just like very good, it's better to know all those things on the left side. So at Atlassian, we have these phases. We put the development into different phases. So if we just like develop something totally new, we call it the wonder phase, right? And not only that, there's a phase in between, like called the explore phase. And then also we have the impact phase. And of course, we want to involve developers in all those phases. They need to be involved in all those phases. Well, maybe not 100% of the time. So we are just like concentrating more on the create phase, but we want to also know what is the problem and are there actually special holdbacks from a technology point of view that we can't really build, but what the product managers imagine? So product is also involved in all things, of course, yeah, but less involved in the make phase, right? And then we set milestones where we involve everyone. Everyone means the designers, the ops people, the developers, you name it, analysts, whatever. So we're doing a project kickoff where the product people mostly talk about what we want to build. Then the prototypes, probably more teams are involved. The product people are building paper prototypes or just like very easy Figma prototypes, and we just like see if we can build that with technology. Then in the make phase, the developers are doing demos. And in the impact phase, we do goals, measures, and signals. So we actually know how the software is used, also as developers, to improve the software, right? So there's a lot of things. There's probably a talk on its own, but I want to dive a little bit more into the demos. So demos are run at the end of the sprint. You probably know that, but we just invite everyone in the demos. So first, our demo sessions are open, so everyone can join. They are, of course, streamed everywhere now these days, and the recording is available. And you can watch the demo session. Then it's very outcome orientated. So we want to show customer value, not implementation details. We want to show like what value we created. And we talk about this. It's a group thinking exercise, and we challenge the solution to build the best solution for the customers. That sounds all very, very business oriented and very heavy and pressure, but we need also to celebrate, right? This is also developer joy. Right? Celebrate our great work and our wins. But we also need to measure things, and we talked about it. What can we do? If we can't measure it, we can't improve it. Actually, that doesn't come from me, coming from Peter Drucker, famous quote, right? So I told you about it, that we also measure things like the door metrics, start with that, but we measure much more than that. And we use our own tool for that, Compass, and we have put baselines here in place. And also what we do in Compass is the CheckOps ritual, but you can do that with every other tool too. So the CheckOps ritual is actually built into, so we can take actions, how to improve things, right? But measurements are great, right? They show us the way. Well, GitHub did this project called the Good Day Project. And they actually looked at developers and asked them, how good was your day? And well, some days are better in productivity and some days are not so good. And then they overlaid it with the data, right? And say activities per day. And what they saw is not a correlation between how developers felt, how productive they are, and what the data showed. Poor AutoCAD. It is because the data shows us just like one thing. And I know that some people like to treat software development as a production line, right? So improve the review phase, improve the deploy phase and the planning phase, but it's a creative process. Software development is not a production line. Some things take longer and some things take shorter time, right? It is not a production line. We don't produce the same software like cars all over again. So measure what is important. Don't make important what you can measure. Also, great quote here. What I want to say is like also ask your developers. Ask your developers. They probably know actually what bothers them and where you should improve things, right? So we developed this survey, the Developer Joy survey, and we ask questions like, how satisfied are you with shipping code quality, with high quality sustainable, right? And then also, how satisfied are you with waiting time? Are you waiting a lot, right? Or how happy are you with the execution independence? Can you execute things independently? How satisfied are you with that? Or your access to tools and processes and practices, effort of managing external standards like security, right? And then can you manage your code pipeline and infrastructure? Are you happy with that? And also for new developers, how is the ramp-up time? Are you happy with are you satisfied with the ramp-up time? And then how is your developer satisfaction overall, right? So we're asking all those questions and ask them, how satisfied are you? But not every team is the same. And not everything is important to every team. So we also asked, like, how important is that area for your team? And then we just like put it on XY scale. We generate an impact opportunity here, and then just like calculate it out. And you see, like, when you're in the white corridor, things are fine. But when you're outside of it, we should improve it. We should look at it, right? So we just like making the surveys and giving those information to the teams so they can actually work on those things. But how is your developer joy, right? So this survey, I put it on Typeform, put it out there. You can try it out yourself, right? The bit.ly/developerjoy, or scan the QR code and try out what your own developer joy is. And it's all about, and I hope that comes through the talk, improving things, right? Try to fix things, carve out time for that. This is so important, right? That you just like, we are creative people, and why not use our creativity and our knowledge for improving our own processes, right? To enjoy more what we're doing. And also spread the news, right? Spread the learnings with the rest, so the rest of the organization can benefit from your learning. Not every team needs to just like do the same thing, right? So for example, with the Punit bot, the team just like did a blog post, and we are blogging heavily at Atlassian. We're using Confluence, obviously. And then they wrote this blog post here about the Punit bot and just like how they build it, what it's all about, and then how you can use it in your team, right? So very, very, very popular blog post, and other teams could just like adopt the same thing. So summarize here. Take your measurements, important, right? That show you signals of how good you are. But then also take the survey results from the developer joy survey or from whatever survey you're doing to ask your developers, right? Give those results to the autonomous teams. They look at it, they can take action on it, and then they try to fix things. They try to fix their developer quality, the developer progress, and the value they create for their customers. And I always want to do a Venn diagram in the talk. And right in the middle, actually, that's where developer joy is happening. If we just like improve all those things and have a good team, great team, and a great culture, we love what we're doing, right? This is back to why we became actually developer. But also, don't forget to have fun at work, right? This is also important. And this drives also productivity forward. Thank you very much. Thanks for your attention. And I will be there in, I think, 1 hour from now and answer your questions. Thank you.
Awesome, Sven. Thank you. Thank you for this amazing talk. I think a lot of, not only joy, but energy. Thank you for that. Yeah, let me introduce our next speaker. I think Daniel is already around. Hey, Daniel Jasnik, Principal Culture and Cloud Transformation Architect at Microsoft. So welcome, Daniel.
Oh, hello everyone. Do you hear me well?
Yes, sounds like we have a bit of delay, but everything is okay. I think you can share your screen. I can add it to the screen.
Yeah, I have to apologize because today my computer is very much lagging. I don't know what happened, but if there is a lag, please inform me, and I will try to do a reboot or somehow resolve it. However, I did reboot just before this call. It seems to not resolve the issue.
Yeah, no worries. I think we hear you well, so no worries with the delay. So it's just that. Okay, Daniel, I think you're starting to share.
Okay. Green.
Okay, there you go. So you can start whenever you want, Daniel. Thank you.
All right. Everyone, welcome into my session. I'm so happy to be invited again to DevOps Global Summit 2023. I was presenting last year about modern organization design. So this session is very much connected to it. My name is Daniel Jasnik. I'm the cloud transformation architect in Microsoft, and basically my daily job is to work with the customers primarily in EMEA, Europe, Middle East, and Africa to support them on their cloud transformation, primarily in the people process area. Yeah? So that means we have a lot of architects which are focusing on the technology area, like how to from the technology GitHub, how to use Azure DevOps, how to use our cloud Azure or other clouds, what to do, how to figure it, how to work with it. But that's not what I do. I do primarily work with customers on the people and process stuff. So how they should transform from that perspective. And that's also why I am like someone who can say something about the non-technical challenges, which is my primary focus area. And unfortunately, during our Microsoft transformation, we understood that 90% of actually all transformation challenges which DevOps has, those major ones, are non-technical. And this is what this session is going to be about. So here you see the session content. As you see, I will speak shortly about Microsoft transformation story. I will talk about METSE principle, the mutual exclusive collectively exhaustive. I'll speak about DevOps and why this people transformation. I will tell you a little bit about Microsoft DevOps Dojo and what it is. I will tell you something about DevOps mindsets and culture. Also, why the DevOps is process change. And then a little bit about management of change. What is the tool to actually achieve success with process and people change? So let's move on to session content. So as you know, Microsoft was in 80s, 90s, it was a boxed software company. Maybe some of you remember those times, and you had the your Microsoft Office or Microsoft Windows box at your shell in your office. This means that the software was released once a year, later once a 6 months. And these were times where every engineer was waiting for this big bang release. Then it was released in production, and then customers were buying it, or it was later published on internet, and customers were downloading it. And you know, those times are really away a lot. Right now, Microsoft is doing thousands releases every day, and they're basically changing our software continuously, and we use DevOps to be able to make this velocity, to increase that velocity so much. And during the transformation we had to go through, we learned a lot. Because we failed a lot in many things, internally, we were failing to do things well. We were learning how to do them well, and during that time, we basically had a lot of lessons learned. And this whole transformation started when Satya Nadella, our actual CEO, joined Microsoft, and he said that it should be for us smarter to focus internally on our own productivity first before we focus elsewhere. Since if we improve on our productivity, we will be able then to serve customers better, because we will be better organized internally. We will be better and faster able to serve our customers. So we started to transform, and the first team which transformed in Microsoft to DevOps was actually the team of Azure DevOps, actual Azure DevOps, previous Team Foundation server, you might know it. And the team actually built something we called in Microsoft the one engineering system, which is connection of Microsoft Teams, Visual Studio Code, and Visual Studio Team Services, or in another name, Azure DevOps. This one engineering system was used and is until now. And now, since last year, or maybe even 2021, Microsoft Teams internal product groups are actually moving their engineering teams to GitHub. Not all of them are there already, but this movement has been already started and it's moving to GitHub. Why I'm saying this is that we are eating own dog food. Yeah, basically what we develop for our customers, we use too. Therefore, we learn how to do it and how to work with those tools well. Which actually led us to understand that when we started to transform in Microsoft, we started to understand that actually, okay, every developer, every tester, every product manager, program manager, all people which are kind of working in that environment, operational people, security people, everyone understands DevOps differently. Some people say DevOps is agile. Other people say DevOps it's pipeline, CI/CD. Other people say DevOps infrastructure as a code. Other people say DevOps is Azure DevOps. Other people say DevOps it's agile, Scrum, machine learning, cloud migration, and everyone is saying something else. And we understood, okay, that's a problem. We need to somehow align all our organization, that all our organization speaks the same language, that all the taxonomy is the same. How are we gonna do that? And that was the time we started to understand that actually DevOps, it's not only about technical challenges, but it's a lot about people challenges and process challenges. And we did some kind of analysis and used mutual, exclusive, and collectively exhaustive principle. And with that, we actually understood that people are 50% challenge to be able to transform business people, to be able to transform customers, and to be able to transform partners, so they behave in a way, act in a way that in true DevOps company they should. We also understood that the other big challenges are in the process area, because if you want to transform to a true DevOps, that's a model. And majority of organizations right now are so they are operating in projects, not as in product teams. And if they transform to product teams, usually it's not always done well. And this actually hinders through DevOps organization. So we understood that this is the challenge too. 40% of those challenges are there. And of course, technology challenges are there, but technology challenges are not always hard to solve, because usually there is a manual. Usually there is from the manufacturer of the technology, there is a manual, there are documentation, and there is already experience with how to do it. But with people and process, it's much harder, because it's much more specific. Every organization is a little bit more different, every organization has its specifics, and therefore it's quite often hard to really right culture, right process to the organization. That's also what's supported by Patrick Dubois, which is the founder of DevOps Days and creator of DevOps movement. And basically, he said once that the word DevOps, the thing that word DevOps gets reduced to the technology is actually just manifestation of how badly we need a culture shift. And so this also kind of supports this idea. When we looked at it, we understood that really DevOps transformation is a people transformation. And if you want to transform people, you need to have vision, you need to have a consensus, incentive, resources, and action plan. And if you fail to achieve any of these, you will get into either confusion if you don't have a vision, because people will start to be confused where to go or which way to go. You get people to one team to sabotage another if you don't have consensus on how to do things. If one team is doing it one way, another team is doing it a different way. You get anxiety if people don't have enough skills to actually execute their jobs. You get to resistance if you don't pay them people enough, or you don't give them other incentive or other kind of recognition or any other type of motivation. Frustrated if you don't give them resources how they should actually which they should use to do their job, and you get to treadmill like a mouse if you don't give them action plan. And that's all which leads what you need to lead to really transform. And when we understood that, we actually understood also that to be able to actually practice it, and if we want to do and bring fundamental change in people's beliefs, behaviors, we will need build a community which will actually gather all the materials, all the best practices, all the lessons learned, which we have in Microsoft, and then practice these new beliefs and kind of help other teams to use it. And that's also supported by this quote from Malcolm Gladwell. And when we understood this, we said, all right, let's build something else that for maybe even in future external customers. And this was a time when actually one amazing person joined Microsoft. Her name was Ken Tank, and is Ken Tank, and she was actually helping and starting the community of the best DevOps practitioners in Microsoft with approximately 20 people. And since its creation in let's say 2017, and she led it until 2022. And right now it has almost 2,000 members, and these people together with Sam Geckenheimer and Aaron Bjork and other amazing people in Microsoft, they've created the baseline for something called Microsoft Dojo. The Microsoft DevOps Dojo is and this became the best kind of consulting material Microsoft has, and it's even more amazing because the majority of those people, those from 20 to which good until 2000, they did it as voluntary activity on top of their routine jobs. So amazing, right? And I'm also proud to contribute to this movement since 2018. And basically what we did is that we took all learnings and lessons learned from our product group, what Azure DevOps learned the most activities, also from others. We've took also and deeply analyzed what other companies are doing, what is doing Google, Spotify, Netflix, Amazon, Meta. And we also analyzed a lot of books, which written by a lot of renowned authors. And from all that information, we've created kind of holistic DevOps approach to people, process, and technology, and teaching material for Microsoft internal engineers, and also right now released for our customers, which we used to kind of summarize holistically what DevOps is about. And this is exactly what you are seeing right now on the screen, yeah? So we've built a material which we divided into 4 pillars: culture, lean product, architecture, and technology. Since we believe if you want to do DevOps well, you need to learn about culture. You need to transform your culture well. You need to become the lean product-oriented organization and have the product-centric model applied. You need to have right architecture using microservices and using all the architectural best practices. And you need to use the right technology. We of course propagate Azure DevOps and right now GitHub or something similar to that. And you need to have enough practices, such as which are continuously being done by all your DevOps teams, which means planning, continuous integration, continuous delivery, continuous quality, security, operations, collaboration, and improvement. To give you a little bit headlight, what is actually included in each of these practices, I've selected for you one of the slides which are part of the white belt. As you see these cats here, that's also a beautiful work of where these cats represent the belts we have for DevOps Dojo. We have 4 belts right now, and in green belt we have several belts, like several levels. Let's say. Use to actually explain internally or to customers how DevOps, what all DevOps practices are, and which all DevOps practices they should be aware of or they should be learning to apply. We use Orange Belt to teach them how to scale this knowledge from one team which is already doing the best DevOps to move forward. And we use then Green Belt to teach them how to do one of the practices very deeply, such as site reliability engineering, or how to do accessibility well, or how to do this or that. And we teach Black Belt how to do it using machine learning and AI. I'll show you one slide later on. Show you all these practices and what is behind. But before that, very shortly on one slide, I just try to say what the DevOps Dojo is. It's basically a holistic training transformation framework harvested from those years of Microsoft experience and other experiences from other partners, and delivered in 2 weeks for one belt, where all the team joins the call, joins the meeting, joins the session, joins the learning, and this team to apply the massive zinc Shuhari approach, and where we use for each of those pillars and each of those capabilities at least 2 hours of theory, 1 hour of design and discussion, and 1 hour of tailored labs for each topic. Basically, we do it for different types of roles. Depends. Sometimes we teach CIOs and VPs and lines of business managers so they can better understand how to transform to DevOps, because business needs to transform as well as the developers. But sometimes we teach enterprise architects, product managers, agile architects, data architects, and other types of architects. But primarily and usually we teach think of DevOps, dev people, QA people, operational people, security people, and product owners. And this basically is supposed to lead them to be able to understand holistically DevOps, and also to understand and to have some prioritized roadmap how to go step by step in their transformational journey. Because the transformation, it's not an easy way, and we all know it, and you all know it. And therefore, having a help hand how to actually do the transformation, understand what leadership should do, to what all these leaders to support the transformation well, and what all these developers and development teams should do of processes and mindsets to be doing DevOps well. That's essential to transform to DevOps, and it's much easier to have it. And we know already as Microsoft that it's much easier to learn it from other group which already knows it than to do the same failures again and again. So here is a couple items of each of the pillars and capabilities. So as you can see, when we speak about continuous planning, speak about how to release advertise, how to estimate, what's the user story, how to do sprint planning, how to do daily stand-ups, how to do retrospectives. We speak of continuous integration. We speak about, should we use monorepo or multi-repo? Which feature branching should we use? Should we do trunk-based development? What is get pull request? Which branching policy we can set up? what automated build, how to do automated builds. Should we use some static code analysis tools such as and when we get to continue how we automate deployments, should we use feature flags or maybe canary deployments, or maybe we should use trunk? We should make sure trunk is always production ready. Maybe we should for different environments in our pipelines. That's all what we need to speak about, and what all the developers and development teams needs to understand that they should think of. Because if you only give them the tool, like such as Azure DevOps, GitHub, or any other tool, they have a tool, but they might not understand all these like principles and good best practices, how to actually think and use these tools. Because as maybe you know, fool is the tool is just a fool. Maybe you already heard this quote, right? Tool is one thing, best practices is the other thing. And it's often better to learn best practices theory then and then apply it in the tool. So that's was just an example of different other things, and you can read the other rest of the slide later. But here is also things as culture and lean product, and these are things which needs to change from the process perspective, together with the collaboration, together with the security, together with continuous improvement practices, and together with test and operational practices. Yeah, so when you do operations, when you do testing, security, how you collaborate, that you should maybe use the Kanban collaboration, that you should think of objectives and key results to implement objectives and key results in your organization instead of KPIs. How to align and how to do well autonomy, which GitOps collaboration tool you should have, and how to set up automated workflows with Azure DevOps or GitHub and Microsoft Teams, for example, and maybe some logic apps which will be doing automated posts into the Teams channels, so people can collaborate around those posts. And all of these methods, all of these collaboration methods and other methods, other best practices, it's something what it's not usually part of DevOps transformation, when because it's always often forgotten. Because we focus a lot on technology, but not that much on this people and process. So, and that's why these challenges are so often said. It's so often said that these challenges are really the major DevOps transformation challenges. When you look at the mindsets and culture, there is like a lot of different mindsets and culture we might go through, such as mindset of leadership, to be customer focused, lean thinking, remove based, theory of constraints, system testing, security mindset, system development, lifestyle mindset, measure outcomes and not activity, alignment and autonomy. And each of these have like 2 or 3 slides behind to explain actually what is it about. Unfortunately, today we don't have time to do it. But I just want to say that. The reason why I'm showing this slide, I just want to say that there are a lot of mindsets to adopt, and the culture it determines what is acceptable or non-acceptable in your organization, what is important and non-important, what is right or wrong, and what works, what doesn't, who you hire, who you fire, who you promote, and all these mindsets should be determining your culture, including mindsets on these slides, which are even more deeply basically talking about different mindsets that I will go only over the part on the right, that we should have culture of experimentation, culture of accountability, flexibility, to be customer savvy, culture of commitment, and culture of teams. And maybe all that, it's not easy to achieve, right? Because you work with people. When you work with tool, it's usually easy. It's a configuration, but you work with people. People are different. every person have different learning curve. Every person has different background. Every person have different motivations, and that's why it's so hard. Yeah. So this is the people part. So we discussed briefly the people part. Right now, let's discuss briefly the process part. When you look at process part, there needs to be really a lot of things to change from the process perspective to organization to be successful in DevOps. Here are just some people to say this is not excessive. Need change because business become from the provider just kind of partner. From intermediation, they need to disintermediate and become the partner and broker and be supportive department for business, not the provider of services to business. And that's a really hard change for the business. Also, the delivery model needs to change from the waterfall one and product-based to the agile, product-based and CI/CD based, right? Because delivery needs to be fully automated by CI/CD pipelines, and not to be project-based but product-based. Architecture needs to change from success for design to be designed for success using high availability clusters and being redundant to be designed for failure, where you can very fast redeploy some very small module of infrastructure as a code instead of going and as admin fixing somewhere on some server something. Just fix and replace approach. From financial, it's very hard to change too, because change from capital expenses to OPEX, operational expenses. And it was difficult to assign cost to services. Right now, it's easy to assign cost to services. And that's also something what financial CFO and financial department needs to work with. And financial model, cost model in organization needs to change. And that's also not an easy thing to do. Lifecycle also is changing, right? Because we were used to be working with old application, at least like one version or more versions of applications. And right now we are working with applications which are always up to date, because cloud is always up to date. And you can even have N+ version, so you can have even version which is not yet released. Some targeted, if you are on targeted release, or if you are on some insider release, then you can use these kind of features even earlier. And this mindset needs to change too. Processes, we used to be able to do documented processes and having manual processes and having a lot of bureaucracy there and a lot of waste. And right now we everything as a code, very intuitive, very value stream. And for process people and from organizations, again, hard change to make. And all these changes takes time and takes some energy. If you look at automation, we were used to do some isolated automation in just one part of organization, usually manually initiated, and usually it was limited. Right now, we are trying to do systemic automation holistically, and usually it's triggered automatically by some trigger, and it's pervasive. We were doing the monitoring on component level, but right now we are rather trying to monitor all the service on the service level. We try to understand if the service is working, if the email is sending email, not if the Exchange server is up and running, because this doesn't mean that email is being sent or received. Also, our support centers are changing from like more contact center, more self-service, or like customer focus, empathy, and organization focus. So we want to have really best customer satisfaction. That's what is in the focus now, because the satisfaction is the metric which is moving the world. If you have satisfied customers, they are going to you and they are staying with you, and they are leaving the concurrence customers and concurrence applications if they are not satisfied there. So satisfaction is almost #1 metric, I would say, right now. And you're also using chatbot and AI. It's something what considered to be in. The performance management was siloed, was done by SLAs, and was done by a role-based KPIs, but right, we are more focusing on value streams, on XLAs, experience level agreements, if I can say something related to satisfaction, NPS score, or basically customer-related, value-related metrics. And also, we, instead of KPIs, we usually set up OKRs, and on the of did it, and other big companies did it. Organizational culture was previously full of confusion and was siloed. Right now, we have collaborative organizational culture. We want everyone to collaborate with each other. And the previous speaker from Atlassian was just speaking about it, that he said that that the collaboration is one of the keys. That's why too many companies, including Microsoft, are inner sourcing. We are inner sourcing with our teams, and our teams see each other codes and can contribute to each other code. So teams team can contribute to Exchange team code, and Exchange team code can contribute to the SharePoint team code. And that's all which needs to change in terms of processes. And here we have some other couple more which are related to culture. Such as IT culture, which was previously centralized and based on technology decisions, where user decided, and the decisions were based by IT management, let's say, or by IT. But right now, user basically should decide or decides what's right and what's wrong, and IT based on that train the users. So for users, it's better to do in this way. Usually IT is not deciding the other way. They are deciding in the best way for the user. The change management was not usually something which was used. Usually change management, I mean, not the IT change management, but organizational people change management. That's what I'm talking about here. And this was usually done maybe a little bit by project manager. And usually it was done only by some communication and some provisioning of some training. Yeah, and it was an event, so like one-time event during the project where there was a communication and training, and okay, we are done. That's not sufficient in today's IT, because in DevOps, if you want to transform, you need to have dedicated change management team, people which really focus to change management, and which are going through those 3 phases, preparing, managing of the change, and reinforcing the change, which are preparing for you those 8 plans: sponsorship plan, resistance management plan, coaching plan, communication plan, training plan, reward and recognition plan, and community championship plan, and measurement plan. And all these plans, executing it as a process continuously during every day for every year of our DevOps transformation, and even going forwards, because there is always changing something. And this is something what it's not always again in part of our transformations. And this requires sponsorship, good sponsorship from our CIOs, from our CEOs, CFOs, and all the management, all the board of directors, because previously the sponsorship was assumed. It was assumed there is some sponsorship, there was passive sponsorship, or maybe sometimes even it was ignored. But right now we are coaching our managers, we are coaching our leaders to be good sponsors. We are letting them to be active sponsors, and we are empowering them via Clark, which is the activity which shows them how to be good communicator, good liaison, good advocate, good resistance manager, and good coach. So all of these are very, very, very important for management. And of course, when we get back to user experience, the user experience in previous IT was actually, usually there was no user research, like what users want. We maybe did web mobile understanding, and we thought that one size fits all. But right now, we know that users are first. That's what we focus on. We use natural language processing. We use IoT, Internet of Things. We use MR, mixed reality. And we try to make all this personalized and inclusive, this user and employee experience. And as you can see, these are a lot of, and this is not exhaustive list. This is just a list of what I understood to be the major things when I was creating this together with amazing people as John Clark and others in Microsoft when we were creating this slide. This is and Fuad Rakiri, I can't forget. And this is just something what it's, as I said, not exhaustive list, but showing process stuff need to change, and obviously it's not moving forward. You probably wonder how to change people, how to change processes. It's so hard, right? It is, but we have something what I already mentioned, management of change. Because if you want to process change, and even technology change, you need management of change. And management of change is a tool which helps you to do organizational changes. And you need to, yes, sir?
Yeah, sorry to interrupt. We're running out of time. Probably you should start wrapping up, please.
Okay, I will wrap up. So basically, management of change, it's something what is supporting or maybe even enabling the DevOps transformation from people and process level. And you need to do it on macro level, and you need to do it on level. So means macro level by leadership, micro level in every team and in every division. And you can use different tools to do it. There are a bunch of tools you can just ProSci, East framework, the culture change framework, including changing of behavioral systems, symbols, and using these, and 8 levels of change management, which I've already mentioned, where I mentioned those 8 levels of plans. And these tactics, these tools are helping the management practitioners to enable and the transformation. So with that being said, I would like to think DevOps challenges are 90% people and process. So please do not forget to focus on them first, since they take much longer to resolve the challenges. Number 2, please understand well what is your mindset and what practices are applied in your teams. That's first thing to or some basically the form or a survey. Once you understand that, also learn somewhere what is the best culture, what are all the mindsets, processes, and best practices to apply for successful DevOps. You can learn it, for example, from DevOps Dojo or from some other books or materials which are available on internet or with some other consulting companies. And then based on that, define your roadmap to your actual priorities. And don't forget to do management of change, because without management of change, you will never succeed with DevOps transformation or with any larger transformation or tool implementation or even technology change. So thank you. So what to say? If you would like to learn more about DevOps Dojo, about all what I've said here, you can do 3 things. First, you can contact me directly. You can add me on LinkedIn with my name and contact me directly. I'm happy to reply all your messages. Second, you can go to this link where you can, on these dev blogs, you can find DevOps Dojo, which is directly on this link. And there is a blog which speaks about DevOps Dojo at least some particular level. Of course, not the level we deliver as a consultant to our customers, but to the level you will understand a lot. And if you are a Microsoft customer to Microsoft Cloud to use and talk basically directly to your unified support, Microsoft Consulting, or us, my team, which I'm part of, Culture and Cloud Experience Team, CCX or MSM. With that, Microsoft's mission is to empower every person and every organization on the planet to achieve more. And this is what we try to do also with DevOps Dojo. And this is also what I try to do for you here for free with this presentation. I hope you enjoyed it. Thank you very much. And as said, feel free to contact me. And I hope you will enjoy the rest of the DevOps days here.
Thank you, Daniel. Thank you very much for the talk and all the information that you just shared with us. Let me we are going to see you again in the QA session. So I believe that we have a lot of questions for you already. Let me introduce our next speaker. That is Stuart Clark. Let me add you to the stage. Hello, Stuart. He's senior software engineer at Amazon. So Stuart, I think if you can share your screen so I can add it to the stage, and just remind you that you're in mute. There you go. Okay, Stuart, everything's ready, I think. You can start.
Cool. Hello, everybody. My name is Stuart Clark. I'm a senior developer advocate here with AWS. Thank you for having me here for this this session today. I hope you enjoy this. So, so I've been a developer advocate for 6 years, and I've worked on a lot of great projects. But this wasn't my first choice of career. Before I was a developer advocate, I spent 10 years doing network engineering and network automation. So I had a big background in building global data centers and things all to do with TCP, IP, and global services for SaaS products and cloud. But previously, before that, I did something completely different. I spent 15 years in hairdressing, which is, surprises a lot of people, because making a career change in your sort of, mid-30s can be very, very scary. But it's something that if you're thinking about doing this, you're thinking about making a change. It doesn't have to be such a dramatic change where you're changing industry. But if you're looking at changing, your careers or focusing on a different area, the time is right now. And so what I want to share with you in this presentation is some of the things that I've learned along the way from being an engineer, a developer, and a hairdresser, and how all of those things tie in together. So you may have heard the term like developer evangelist or developer relations. Technically, there's very sort of subtle differences between all three. But to avoid squinting really hard, I consider these, relatively interchangeable terms. And I'm a big believer in the pop culture of Occam's razor. If you're not familiar with that, that's the law of simplicity, where the simplest explanation is usually the right one. And as a developer advocate, what this implies is, for me as a developer advocate, is that I'm an advocate for developers. And as a developer advocate, what I do is I consider my job like a storyteller, kind of like a minstrel, but without the lute. And by this, what I mean is I need to give an understanding of a given landscape and technologies that we have within this, so that when I talk to people like yourselves in the community and partners to see what their pain points are, or see even what they're interested in, I can then provide credible insight. And if our offerings aren't sufficient, I can give them alternatives. And if people like developers and engineers are having problems, I can take this back internally to see if there's some way that we can resolve these pain points for developers. But I don't just advocate externally. I also advocate internally, as well as providing things like opportunities for developers within inside organizations to highlight the awesome work that they're doing. And all of this success can be measured in 3 axes, which is leadership, brand, and then also community. So that's where it all basically starts here. And if you are curious, that is actually a picture of me when I was born. So every developer, every lead engineer, you've all been there. You're on a phone call with a client, customer who's experiencing outage or chaos. That person, they are stressed out, and what they're doing is they're balancing feedback from their stakeholders, from their partners across organizations, and they're weighing the potential impacts of their issues which they're dealing with. And what they're then doing is they're relying on you for their advice and solutions. But it's in these pivotal moments, and I've been there on the end of that phone, I'm often hit with this sudden sense of deja vu back from when I was 16 years old, working as a hairdresser in my first full-time job. My client, who was facing an issue with her hair, the color was basically left on. And what happens when you leave color on too long? It oxidizes, causing microscopic outer layers of their hair follicles basically to peel back and release green color pigments on the hair. So you go from helping the customer turn their worst day ever to look more than just transforming, the hair from, a shamrock green color back to its normal brown. But within that point, it's also remaining calm, being the presence behind the chair and talking through your client through the process and giving them the confidence to believe that you can fix their issue for them. Within those 15 years behind the hairdressing chair, this taught me that success, which I have as an engineer and as a developer advocate when dealing with customers, is 50% technical skill, but also 50% communication skills. And so here is going to be really 3 soft skill lessons, which from my salon days, I have used to shape my career within both engineering and developer advocacy. The first one is listening to learn and learning to relate across all of these levels. It's very critical to listen to your client's needs, and sometimes that's really, really easy to say, but can be very, very hard to do, especially within a heat of the moment. For one thing, people don't always need something fixed. Well, not almost immediately anyway. Sometimes they just need someone who has been there and done that to look with them at something and even share ideas, potential brainstorming, if you will. For another thing, what customers and clients don't want is not always what they need. And that is not to always say that something they want to hear. Active listening and discussion really yields visibility across a client's stack to translate something like, I want to look like the latest, magazine cover model in my hairdressing days, to we need to be more agile and I want to feel more confident when I, do my job. Or we need to move all of our infrastructure to the cloud, for example. Not very long ago, developers were primarily seen through the geek lens as the smart people that were too idiosyncratic, too unsociable to be taken even seriously, or wielding much influence within a business. But as we know, all of that is changed, and it's why our customers and our partners have really started to lean into us, and developers have developed a new status, because the game changers who hold all of the power and influence that is known in tech are developers. In these high-class circles, this has opened an ongoing conversation about how we have the shifting role which is developers today, and how that is affecting different enterprise organizations, plus the relationships that we have with our customers. Today, developers are unquestionably the biggest asset to any business, regardless of what the industry is. And this gives us this great, exciting opportunity to listen to what our customers are doing, and to take pride in this status of ownership and the responsibility to which it will bring to all of us as engineers and developers. As a hairdresser, and then later an engineer, my default mode was often, I can fix that. Learning to actively listen gave me this better visibility into customers and clients' pain points when they wanted ideas versus when they needed, something just fixing. Understanding how a client's processes works allowed me to work for me and to be able to communicate my advice where my ideas were going to be listened to a little more and my customers going to be signed off. We often refer to this as walking backwards with the client. It also helped me as well be more ease when talking to a variety of clients, and ultimately what led me to present here today and to become a developer advocate, because I'd spoke with such a diverse range of people throughout my career. And then as a network engineer, that gave me the skills to talk with different network engineers or VPs, directors, and even CTOs as well. What we know is that customer engagement it doesn't stop when they walk out the door or you put the phone down, or even when code is complete. Our customers will always come back, and sometimes in the same day, because we know that software is never finished. So there is always going to be great opportunities for our customers to interact with both our products and our teams, whether they're acting with us in person, on the phone, via video chat, or they're interacting with us via documentation. And so the fewer snags that we put in their path, the higher the likelihood is that our customers and our developers who are using our products and tools will think more positively about us, about our company. For developers, they will often return to a frequency or of a reference point of a functionality. That might be documentation around APIs or code samples for a product and how to use it. So at this point, it's really important that our documentation should be kept accurate, updated, because let's face it, nobody likes stale and out-of-date documentation. It's far too easy or common for developers to wrestle with a problem that can be eventually traced back to inaccurate documentation or instruction. When developers know who to ask, they will greatly share their negative experiences, which allows you to remove them before others get caught out too. If you have that good relationship with your customers and your partners and your developers, they will flag something for you, enable you to fix it. In developer advocacy, one of the main strategies in maintaining and building that healthy community and partner ecosystem, if you will, is to create and maintain that good relationship with both our partners, our developers, and our communities. Often this area is responsible for creating this cooperation between the partners and developers within developer advocacy. And for this, a developer advocacy team needs to build that relationship and develop activities in the areas developers are interested in too. The developer-driven economy has been called the next trillion-dollar market. And what developers influence is round about things like more even purchasing decisions now. The second piece I want to share with you is walking in a client's shoes. The daily work grind can be really wearing. It can be wearing on all of us. Often we all go to bed when we log off feeling tired and exhausted. And it can be easy to fall into that wash, rinse, and repeat mode on projects, just like I was doing when I had clients in my cell. However, it is also good to remember that no clients are the same. Whether they are sitting in front of you in that salon chair or troubleshooting projects with you across a various different form of mediums, such as video conferencing or even via chat spaces like Slack or Teams or something, their problems will not necessarily have the same fix between two clients. So it's really important to step into your client's shoes and treat them how you would want to be treated if you were the customer. One of those things is respecting their time, no matter of the title or status of the person that you're working with. Always be present with them. Fully engage and listen to what they are saying, and not, just the words. Understand the issues to what is stressing them out. Then, when it comes to the time to plan, steer your clients towards options that tackle their issues head on. Based on their individual needs, you're able to access the resources that you will need to help solve their problems or their issues. About 35% of advocacy work I do is about the technical details or the tools as well as the APIs, but the rest will be about developing relationships with those different groups, teams, partners, and individuals. Acknowledging that some relationships can and will be always more difficult with others, and demonstrating genuine empathy. This is your true superpower, one that will offer valuable insights that can make the difference between a collaboration success or a failure with your client. The third tip is practicing professional patience. It's not personal. It's just business. 9 out of 10 times when you get that urgent client call, whether that's during the day or that client call comes at 2 in the morning, they're not reaching out to you to tell you what an outstanding job you and your team are doing or just to chat about their weekend plans. This is because something has often gone wrong within infrastructure, within cloud, and they need you to come in and help fix it. And they need you to do this like yesterday. The important thing to remember during the shouting, the virtual finger pointing, and the ongoing around in circles is what to do next is that most of the time, it's not personal. The client is stressed out because something seriously is outside of their control, and that's when they need you. That's when they need the company. And that stress pours out like steam from a boiling kettle. This is your time. This is the company's time to call on your powers of patience and listening. Let your client talk. Guide them back through the problems to calmly work out exactly what happened if they know this. Focus on the facts, not the feelings. Reassure them that you have a plan and that your company, your team is working on this and you'll be doing your best to resolve this. And while there may be sort of many definitions, it can be summarized in one single sentence. Developer experience is every interaction with your API or your dev tool, which makes all of us advocates for our company. It's really simple to state, but however, executing on that vision can be harder than it seems. The surface area of our developer toolset is much larger than it's ever been. Some of the interactions which we have with our customers might happen on local machines, which can't be directly measured, and they might happen in our infrastructure when we look at quantitative or qualitative data. But when you get inside of those details, inside of all of those interactions, you will see the far-reaching concepts that impact developer experience, the clarity of your positioning, the usability of your tools, the readability of your documentation, and so much more. This is why a good developer experience may begin sometime before the client even reaches your tool or before they reach your website. It might just be a working prototype, so you might be giving just an example or a snippet. Now, that isn't a long-term investment by any company who's got developer advocates, but this does pay off over many, many developer interactions. Never mistake developer experience just for design or just onboarding or just documentation. It's a lot more of those things. It's being by the customers and the partners side throughout their entire business transformation or an entire change that they're planning to make. In today's increasingly digital business environment, this need to continue and honing your skills is pretty much a given. We're all used to the upskilling that we need to do. But communication is one of those skills that we kind of overlook just a little bit. That technical expertise to counsel our clients and our customers. Whether you're managing say a managing CTO, reimagining your corporate technical strategy, or developing, creating systems that bring to life and translate the people skills you have built through your own unique experience. To advance all of these things, it doesn't matter where you started. Even if you started out just as a hairdresser, just like myself, this change is completely possible. Developer advocacy and hairdressing for me are so interlinked. Without the former, I couldn't have been the latter. All of the skills that I've carried over throughout my 15-year career in this industry have come back from basically starting at day one, listening and communicating with our customers, understanding what our customers need, talking with developers, and building content around what they need in order for them to solve the critical things and blockers within their jobs. I hope you've enjoyed this presentation today. My name is Stuart Clark. I'm a senior developer advocate with AWS. You can reach out to me on all of the links on the side. I'm very active on social media. I've got some code samples on my GitHub as well. Feel free to connect with me on LinkedIn, and you can see other things I'm doing with AWS, enhancing developer experience and developer strategies with the team that I'm working in. I'm going to be around a little later in the day to hopefully answer any questions. But if you've got any comments, feel free to pop them into the chat, or if you want to message me personally, that's fine too as well. Enjoy the rest of the sessions today. I've seen some great sessions so far, and better sessions.
Thanks, Stuart. Thank you for the great speak. I think we are ready then to try to start a Q&A session, but I think we need to wait for one of our speakers. Give me a sec. So here's Sven, Stuart, and I think we're missing Daniel. I think we can try to start. So first thing, guys, all of you, thank you for this great talks. It was a lot of good information to start with this DevOps series or summit. I think we're ready for the Q&A questions. So let me start right away. I think let's start with Sven. So your first question here is, sometimes when we want to progress too fast and you are unable to catch up, what's going on within the internals of the project? Well, this is can cause some frustration too. I think.
Definitely it can cause frustration if you can't catch up with what's happening in the internals. So if that came across with my presentation, that's not what I meant. I think progress, if things flow through, is important, that we work on that. And there's also a lot of frustration if your wait time is too long. But I think like we need to carve out time for working on internals too, to work on quality. We should plan that into the sprint. We should just like maybe take time off to clean things up. We have, for example, these getting stuff done days where we just like stop all meetings, stop everything, and just work on those things, or have a sprint in between to catch up, just like doing a just like quality sprint or whatever you want to call that. I think this is important, to take time off also to work on the internals, to work on quality, maybe even to work on documentation, which we all really don't like too much, but it is necessary. But yeah, take time off. So you can do some things like 20% time, which is more like for innovation. This is also important that you just like do that. We can't just like work on features and assume that we learn and we innovate. We need to take time off for that too. So it's not just like we work on features all day long, or just like the whole year. There's also more than this, like learning, innovation work, and we need to plan for that too. Otherwise, we don't progress.
Okay, no, thank you. That's totally right. And I don't know if maybe Stuart, you can maybe add some words to that.
Yeah, that's really good advice, as Sven said, and that's one of the things that I faced as an engineer when our business shift from waterfall into agile, and one of the reasons it did that back in the day when I was in engineering, we were putting up data centers at probably two data centers every month around the world, replacing the footprint that we were working on. And when you've got different teams flying to different things, you can often find yourself slipping behind. This was one of the things that we found by having things like retro meetings as well, to actually find out exactly how long things actually took if you came across things, things that caused delays. So that can be anything, from a shipping thing. I had an instance where I once was building a data center in Secaucus. The data center team arrived on site, and 50% of what we needed to build was still on the runway at London Heathrow. And when you've got a data center team who only have access to a data center for 5 days and they're only available to be in the United States for that length of time, you've all of a sudden condensed all of that down into building that data center 3 days. And unfortunately, somebody's always going to draw the short straw where, you're having to, burn the midnight oil and drink copious amounts of coffee to be able to deploy that. So in the retro meeting, you make notes of things like this for how long, things are going to take. And you build in those time buffers. I even do it now in my inbox meetings. If I'm busy with meetings, back-to-back meetings, I build a 15-minute blocker, within my meetings. So I have time to go for a bio break, drink more coffee, or, get a bit of fresh air, stop the dog from barking at the postman. Companies and teams have to take ownership of that. If companies aren't going to do that, that does fall on the individual. There's nothing to stop you from leading up the chain to your superiors, to your leadership, and saying, this is taking us longer than what we need. And this is when your leadership steps in. It's because this is what leadership does.
That's right. Yeah, you're totally right. Guys, for the guys that are listening our stream, maybe some of them are not able to see the chat in the platform. Please just refresh the page so that will solve the problem. Meanwhile, let me continue now for the next question. This, and here's a two-part question for Daniel and probably for all of us too. So Daniel, first, great presentation. I always heard DevOps is not for freshers. Can you guide the recent freshers to follow some steps to enhance in this field? Daniel, that's for you.
What is meant by freshers?
Like people that is just starting on DevOps.
Okay. The startups are actually companies to do DevOps because it's on the greenfield. It's much easier to implement all those DevOps practices and principles and new toolset and agile and architecture when you are starting fresh, when you are starting greenfield. So I think DevOps is for freshers much more than for years to be able to transform. And even after those years, if they don't get support from such a consultants as we are here sitting today, they will fail, will be non-efficient anyway. So this is like really hard. So I think DevOps is for freshers. And can you guide the recent freshers to follow next steps to enhancing this field? I'm not sure what is exactly meant by this question. Like what to learn, where to start learning. But I would say it really depends on which what are the goals. But there is a lot of material on internet in terms of books, audio books. I would start definitely Project or Unicorn Project. Those are probably the first books I would read if I want to start DevOps and be the DevOps developer. And I would follow with some certifications or learnings which are available. Depends in which exact area you want to focus. You can use PeopleCert certifications, you can use Microsoft certifications, you can even order DevOps Dojo I was talking about, or even other certifications from other providers. And of course, watching such a great summits as you are just part of where you can learn a lot. But really depends what area you want to focus on. If you want to be like more site reliability engineer, then go and buy the SRE book, and it exists. It's a really good book, and learn that one. If you want to be more like a quality focused engineer, then learn some other book related to testing. But this would be just generic advices, I would say.
No, thank you for that.
Yeah, just like great question. I'm sorry I dropped out. It's always when you just like need the internet, then it's just like dropping away. Anyway, so great question. At the same time, I'm frustrated about the question. I think this DevOps need to be taught. Everything need to be taught in university. It's just like if you come as an engineer without knowing what a development pipeline is, what a Git repository is. If you come then to your job, the university has done something totally wrong. And that frustrates me that we don't get the education. And also, when I hear the term DevOps engineer, it's like, what is that? Every engineer is a DevOps engineer. Every engineer should know these things and should just like know how to improve the dev pipeline, what happens if something breaks. They should just like go on there. And I don't really, if we coin the term DevOps engineer, yeah, sure. We're going more into like the platform engineering side of things. If you have also a good book, it's like when we hear recommending books, Team Topologies, great book, where it talks about just like streamline teams, which are just like the feature teams that develop the features, and the platform teams. Yeah, great, Hugo. Love it. And have the platform teams that actually care more about like the whole like setup and where developers work on and help developers to lower the cognitive load. Also a thing that I talked about. Great, but just like if you want to start a career in engineering, go for it. Start it. Go into what you're passionate about. There is nothing that stops you for being more DevOps oriented, because DevOps is basically where it comes from. It's just like develop on ops working better together. That's basically it. It's a cultural thing. It's not an engineering thing normally. And Daniel, you said that just like 90% of it, it's a people thing, right? And it's like 10% is tooling. So what is this DevOps engineer at all? I think this is a great question, and I love it. So students, freshers, whatever, just like go and build things that you're passionate about, that you want. And once you start with your job, you will just like drive into just like what you're good at and what you like to work in. And we are all DevOps engineers.
Yeah, that's a great comment, Sven, because as you said, universities should prepare everybody to be ready for that. But in the other side of the, let's say, frustration sometimes, if when we talk about DevOps, is like an organization change also. No? So companies should also be ready for that. No? So, and that's also something that I think this type of summits or anything that we are reading talks about the transformation of the organization. So this DevOps mentality really is we can apply that, and do the continuous delivery integration and everything without blocking because of the organization, how it's working. Great. Okay, let's go for the next question. I don't know, Stuart, if you have anything to say about that. Otherwise, I think I have.
I can weigh in there. And if we're doing books as well.
Okay.
If we're doing books as well.
Phoenix, yeah.
Fantastic book. Which there's a lot of great information out there. As Sven has said, as Daniel has said, and if this is something that you're passionate about and you want to start doing, just start doing it. One of the things that you get asked a lot at conferences online is, should I use, let's just take two tools, for example. Should I use Python or should I use Ansible? My answer is yes. Just start doing it. Somewhere down the line, you might think, well, that tool doesn't work for me. That's okay. change your work tool. Think about what you have in your sort of DevOps tool chest. And, we swap things in and out. We swap things in and out in production environments because they don't meet our needs. We swap things in and out because they don't scale, or we swap things in and out because we don't have skills for doing it. Just start doing it. That's the simplest way to learn. It's kind of like, and I always use Edison as a great example. It's kind of, someone said to him, you made the light bulb wrong 100 times. He said, no, I just found 100 ways it wouldn't work.
That's good. Yeah, that's right.
Yeah, good conversation.
Yes. Let's go to the next interesting question. What are the anti-patterns for DevOps? I think we're going to try to have a round with everybody. Can we start with Sven?
Oh my God. A lot of things come to my mind. I mean, as I said, like DevOps is about Dev and Ops working together. If Dev and Ops not working together, and if you just like throw things over the wall, what we had in the past, that's probably an anti-pattern. You shouldn't do that. I just want to get my thoughts together. Maybe I come back at the end, but this would be just like my first train of thought here.
Okay, Daniel.
Yes, silos. This may be repeating, but the silos, I mean, silos in everything, not only Dev and Ops, but the Dev, Test, Ops, security, business. All of these pillars needs to work together into DevOps. And the anti-pattern is the big anti-pattern, which is actually causing these silos is management mindset. Yeah, the anti-pattern is that management doesn't understand DevOps, and that not every management, but I mean in general, like when the companies are trying to do the DevOps transformation, they usually don't learn it and first learn it at least on a high level, and then they should go for DevOps transformation, because then they would be able to support it better. Because usually what happens is that organizations goes to DevOps transformation with this IT project, and no one from business is supporting it, and then they start to implement all those tools, implement all those methodologies inside some teams, but then they face the problem that it's not gonna work because of the organizational design, the topology as set or by culture or by style of management or product-centric model. So management knowledge would be DevOps anti-knowledge would be a big pattern.
Agree. Stuart?
Yeah, that's a really, really great question. One of the things I think comes to top of mind straight away is short-term thinking. For me, DevOps, it's more long-term thinking view of our software development with regards to things like deployment, maintenance. I've been on teams where we've solely focused on things like short-term gains. And by doing that, I found that we overlooked a lot of critical things about the success of our business. The other one as well, which for me, I mentioned a little bit in the retro meetings, but poor feedback loops. And I mentioned this a little bit in my talk as well, is that feedback is essential for continuous improvement, for everything, as DevOps included in one of those things. Without those clear feedback mechanisms in place, often teams are unable to learn from their mistakes, and then further on, not improve those processes. Feedback is feedback. It doesn't matter whether it's good feedback or bad feedback. Feedback is the same. It's how we react to feedback. That is the important piece. I think they're the two things which really jump out for me when we talk about things like anti-patterns of DevOps.
All right. I've put myself together.
Go on, sir.
So I think actually if one team cares about the tooling and the rest is just using it, that's a super anti-pattern for me. We should all be involved in picking the tools that we like and be responsible for the tools that we use. It's the same as you just like want to run a platform engineering team, and they build it, and developers will come. This is a super anti-pattern. That will not happen. Developers are smart people. They will walk around your your guards that you set. You need to work with developers, with engineers together to just like accomplish everyone's goal and for every team. Same as just like building a DevOps team in isolation. I mean, DevOps teams per se, that's another conversation. But if you build something in isolation and don't listen to the people that actually uses this and that need that, that's just like an independent for me. And I've seen things where just like, and that comes back to the silo discussion, where things just like being thrown over the wall, and the other team just like takes it and runs with it. I come back to just like dev and ops need to work together. And it's the same, like if you have people that care about the tooling, they need to talk together. They need to work together with the engineering teams that use those toolings or are just like relying on that tooling. And it will never work if you don't talk to each other, if you don't collaborate together, if you don't sit together, do retrospectives, do feedback loops, all those things. It will not work. And that's my biggest anti-pattern here.
Okay, thank you, guys. Let's go to the next. This is with Sven. Let's start with you, Sven, again. When starting to implement DevOps, it is easier to have success in small, isolated teams and for initial projects. Once DevOps initiative starts scaling to larger projects, it continues. Running on many more infrastructure, or once it starts spreading the other teams, it can come crashing down without proper governance in place. And continues with DevOps cost and efficiently starts spiraling out of control. How to overcome this?
Wow, it's a long question. And there's a lot of things in there, and a lot of things that I think we already said. Like, yeah, you just start in a small team, try to experiment, try to see what's working. But teams are different, and if you go to large initiatives, it's probably different than what you needed in this small teams. But if you don't take care about just like what you build there, then of course, yeah, it's just like it could just like go haywire, and you don't have the infrastructure in place that is actually necessary for other teams. So it's if you just like keep on just like slowly, it's like everything. If you want to roll out change, right? You start slowly, you just like keep it growing. Don't just like do all the things at the same time. Maybe you start with one team, you expand to two teams, whatever. It's all the time that, I mean, just like putting just like switch on and say, now we're just like, all of us are just like DevOps. I had the same conversation 10 years ago when we talked about Agile, and people were just like implementing Jira and said, now we are Agile, right? No, that's just like something we have to learn, something we just like have to just like slowly put into the organization, and where everyone learn. And still we get problems having Agile implemented nowadays on the development team level, which is pretty common these days. But getting that over on the organizational level, we still struggle with that. It's hard, and I can't just say like start small, expand slowly, and keep on building on that, and don't just like turn over the switch and then we are DevOps from nowadays on.
Yeah. Okay. Stuart, we have this other question here. How often, how much do you rely on surveys versus in-person qualitative observations?
There's different reasons for different ones. It really comes down to, what your, personal preference is. For me, when you're doing things like live streaming and things, it's not easy to get feedback, or whether you're doing presentations like this, it's not easy to get feedback. So, that's when surveys can come into that as well. In person is kind of my preferred thing. So I might try to do a mixture of both. I think the key behind both of those things is vulnerability, being willing to engage with people on those conversations. So, say for example, someone says, your coding sucks, or your code sucks. It might be easy just for you to kind of go, wow, okay, and then just walk away and go, okay, then I'll try to improve it. But jumping deeper into all of these interactions, no matter what you're talking about, the feedback, is going further into that to try to understand what the actual issue is. Taking the example of your coding sucks, that person might not be talking about your entire just piece of code. They might just have one opinion about a particular way that you're doing something. And so then going into that and being able to analyze that data and have that conversation, it does take a lot of, like as mentioned, vulnerability to go into that, especially when someone is perhaps pointing out what they believe is a weakness for you. But there's no reason not to do that. I take as much data as I can from people, good data, bad data. You don't have to always take that feedback. Someone might give you a piece of feedback about something, and the way that the question is poised, it's kind of, there is a particular reason for you doing that. So you might not decide to change that. Do you have to explain that? Sometimes it depends, who's asking you the question of why something is positioned in that particular way. But it's quite easy just to, to jump into that feedback and to be able just to constantly improve on it. We mentioned it, in the last, last kind of few questions around communicating across different departments and things. That becomes, really important. I would ask another team, who I work with to survey. If, Sven or Daniel was on a different team to me, say they're on an SRE team and I was on the network engineering team, I wouldn't send them a survey to say, how do you think I'm performing? I'd just walk across to their desk, sit down, pour a coffee and say, how can we collaborate better?
Got it. Yeah, I agree with that. Thank you. So now, Daniel, another question here. What is the biggest challenge that you are facing working in DevOps?
I will answer very quick to this question, and I will use a little bit of time to answer the first question, which was Sven before. So people, I think people are the biggest challenge. So that was easy, and I wanted to say just a few words to this governance question, because this is actually something what I work with a lot, and it is about when you want to scale DevOps from one team to more teams. Usually, you need to set very well the governance inside your Azure or inside your cloud in general to enforce all the things you want to enforce. Yeah, so you enforce the resources developers can use. You enforce the tools or methods they can use. Ideally, you enforce all the resource consistency things such as tagging, naming conventions. You enforce what SKUs are allowed and what SKUs are not allowed. You enforce all the cost management things, and you enforce all the security boundaries. You set up all the security rules well, and the more, let's say, strict the governance is, of course, it needs to be also allowing the developers to do what they need to do. But more strict it is, more mature it is, the more control you have actually over what's happening in your environment. So, and this is usually what platform team does. And so therefore platform, it's kind of work and job of platform team. Here was mentioned the book Team of Topologies, where it's this concept explained well. And if you would like to learn it, I was actually presenting about it last year in this DevOps days. So this concept of the platform team, which actually develops the governance for all those Streamline teams or those DevOps teams. It's something what is actually enabling those teams to work and don't do any mess or don't break anything, and in the same time like have the consistent, secure and governed environment and applications, and do it agile and still do it with high velocity. So thank you for these great 2 questions.
Awesome. Well, team, we can sit down here and talk for hours of everything that we want to discuss about DevOps, but we need to respect the time. I think right now we are ready for a small break, team. And well, thank you again. Thank you everybody who's listening. We are going to continue in the next block with other 4 speakers. And thank you, all of you. Thank you. It was really great. A lot of energy, a lot of information. And I think all of us are thankful for that. Thank you, guys.
Thank you. Bye.
Okay, folks, welcome back. We're still finishing our break. I'm letting you all bring your drinks and maybe something else to your screens. And just before we start, before I give the stage back to our moderator, I want to talk a little bit about our upcoming event. So yeah, I have Lydia here with me as well. So first of all, I want to mention that we will have our Software Architecture Summit in May. So this is one of our biggest events that we're doing here at Geekle, and this is going to be our 5th software architecture event. We're going to have cool awesome topics on for people who are either practicing architects or are thinking of joining software architecture areas and maybe becoming even a solutions architect. So please go register. We have a $99 price for the pro track, and of course we have a career track, just as today's one as well. And we have one more event that Lydia can tell you.
Yeah. Thank you, Nick. So I wanna invite everyone for our first API forum in June, and you can use promo code to take a 20% discount, DevOps Geekle. So don't miss that opportunity, and I will be happy to see everyone in June in our first API forum.
Yeah, thanks for that. And so let me welcome Hugo back to the stage. We have our next speaker who unfortunately wasn't able to join live because he's from Australia. It's like the least comfortable time that he has for this, but he's still prepared an awesome topic for us. And so Hugo, the stage is yours.
Okay, thank you. So welcome everybody to this the second block of the day. We already had 3 amazing talks with a lot of information that we were able to learn and understand. And now we have another 4, so it's a lot. Get ready. Let's start with the first speaker. As Nick mentioned, we are going to see the recording just because of the time zone schedule. But
hello and welcome everyone.
We start.
Hello and welcome everyone. I am pleased to give a brief talk on chatbots and operational patterns for event streaming applications. I'd like to start by giving a brief intro about myself and my current role. My name is David, and I'm part of the SRE team at IBM. I work extensively on operations and technical support, and also tackle things such as how to further improve the reliability and availability of systems, automate solutions, and implement tools for production efficiency. I have many years of experience working in cloud, DevOps, SRE, and in technical operations. I spend my personal time in playing chess, badminton, and learning computer science, which I find it interesting to learn about the newest and the latest technologies in this field. I will briefly mention about incident management, SRE, and event streams, then cover the SRE approach towards handling production issues and tickets. I will mention about some of the techniques used for this purpose and elaborate about an in-house chatbot solution that we are using in IBM for monitoring in event streams applications. I was reading a blog post on hilarious, funny responses by ChatGPT, which is an AI bot which has become popular in recent times. One of which is, someone was asking it to write a poem about sinking ego, and it gives a response like this, which I mentioned which I have shared the screenshot of. And another video where a programmer is requesting for a code and for a Docker container, for Dockerizing an application, and it is able to seamlessly generate the code. So these are very interesting developments in the field of artificial intelligence. However, this talk will focus on non-AI based bot. It's an interactive bot and not about ChatGPT. There is a paradigm shift in increased usage of chatbots and AI tools in DevOps and operations. Nowadays, an operations engineer uses chatbots and automated tools to resolve incidents. So I will just walk through some of the operational aspects in the next few slides, which will give some context and idea about this presentation. So what is SRE? SRE stands for Site Reliability Engineering, which is a field encompassing everything from process and business change to rewriting the entire stack to eliminate single points of failure in business logic. So we do not attempt to achieve 100% availability. Instead, we set an approximate availability target and work towards achieving that goal. We also find out what is the real work and how to automate it. So we manage service reliability largely by managing risk. We work on making the service more reliable by determining the risk of the business, and we also set tolerance in terms of unplanned downtimes and service unavailability. So when handling such incidents, when SRE handles incidents, there may also have customer impact. And one of the main focus of an SRE is to determine whether there is a customer impact and whether we are meeting SLOs that target SLOs or not. SLO stands for service level objective. This is a measure of target reliability. Above this threshold, almost all users will be happy with your service and the application. But below this threshold, users are likely to start complaining or stop using the service. So some of the key facts to keep in mind are, even if you could achieve 100% reliability, your customers might still not be having or experiencing 100% reliability. So you could go from 99% to 99.9 to say 99 point, the 4 nines, 99.99% reliability. But the extra nines comes with an increased cost. So this table highlights the correlation between amount of toil required to operate the service, the level of customer satisfaction with the service, and the respective SLO. Based on how we are doing against the first 3 columns, corresponding action can be taken to either tighten the SLO or to loosen the SLO. There are a couple of interesting metrics such as MTTD and MTTR to be considered when handling critical incidents. So MTTD stands for mean time to detection. Imagine humans staring at screens for hours to monitor the health of the systems. So this is not an effective way of detecting incidents. To explain with an example, long time back, I used to work on projects which did not have good monitoring or alerting systems. So what we did was we had multiple monitors, like computer monitors, and we used to stare at those monitors, and find out if there is a issue going on, like a production issue or some issue affecting the customers. So this proved to be a disaster when there is a real incident and no one noticed it for a few minutes or longer. So nowadays, techniques such as synthetic monitoring can be used to further improve the availability of various APIs that are used in production. Monitoring the ALB metrics, detecting partial failures of systems. So all these can be done by alerting on correct failure metrics. I will also like to mention about MTTR, which stands for mean time to resolution. So to resolve a production issue, finding out the nature of impact and why there is an issue. So these are the initial steps. Elaborate on MTTR. One could create custom tools and solutions to expedite the incident diagnosis that can help reduce MTTR. To reduce the risk of inadvertent mistakes. So when fixing the issue, runbooks and chatbots can be used. Some of the prominent approaches to improve MTTR are having fail-fast systems that fail to a different zone or a redundant subsystem. So this also ensures that the impact is minimized and one could use, then someone can continue with their automated or manual steps to fix the issue. And now that we have discussed about how SRE handles incidents, let's see some of the techniques widely used in service reliability to save production systems from significant outages. I'm not going to go in depth in these concepts. However, I would like to mention about them. Failover is a way of handling sudden failures by switching over to a standby or a secondary component. So this is essential for fault-tolerant systems. Timeouts are set when multiple services interact with each other and the waiting time for connections or read requests are high. So these should be set based on the response times of various services and how often are they overloaded. Throttling is a form of load shedding which aims to prevent the cluster or the nodes from running out of critical resources, which can cause health checks to fail or cause cascading failures. So a throttling alert helps to identify such issues and take appropriate remediation measures. So usually help, this retries helps with random and transient failures. This technique, along with backups, should be used carefully so that the system will not get overloaded. For those of you who are not familiar, I will briefly mention about Apache Kafka. And if you're interested in exploring further, we can check out various other articles available on the web, or you can reach out to me. Apache Kafka is a distributed streaming open source platform developed by Apache Kafka Foundation, written in Scala and Java. Kafka is an event streaming system that handles a continuous stream of events, and it is able to process trillions of records a day without much performance lag. IBM Event Streams is built on Apache Kafka. That is used to build smart apps and then react to events when they occur. Event Streams deploys an instance which has all the required Event Streams components and the storage. So next few slides we will discuss about chatbots, and then I will explain the in-house chatbot solution. The number of chatbots and the popularity of these chatbots have significantly increased over the years, and nowadays more and more people are getting familiar with these bots. So we should not confuse between virtual assistants and bots. So both use AI, both respond to queries and automate the processes. However, their implementation and scopes are different. So a good example of virtual assistant is Siri from Apple, which serves as an intuitive digital assistant. Chatbots are usually automated rule-based conversational AI platforms that enhance the customer engagement and support. Well, there are probably many others, but these are the three prominent ones which I'll be discussing today. So decision-based bots answer questions in real time, and it can use API calls to retrieve results for customer queries. NLP bots mimic human experience, and they also improve continuously with more data. And hybrid ones are the mix of both. Slackbot used for supporting event streams is a non-AI interaction-based bot that interacts with Kafka, IBM, and PagerDuty. So to explain this very, very briefly, the core is a bot engine integration. So the bot engine integration with Kafka clusters that run in Kubernetes clusters. The responders use this bot after you receiving the alerts, PagerDuty alerts, and they trigger custom commands. They just type the commands in the Slack bot. So they are able to see the output of the commands in a matter of few minutes, and this helps drastically to reduce the MTTR for critical incidents and alerts. So this monitoring system is deployed to cloud using Helm. So Prometheus-based integration is used for retrieving the alert events from various sources like various pods and then route them to PagerDuty. The Kafka clusters are hosted in IBM Kubernetes service, IBM Cloud service. Alerts are generated as per alert rules. Prometheus and Alert Manager processes the events from various event stream pods and node sources and other sources and route them to the PagerDuty so that the alerts are displayed to the responders. So this is a simple screenshot of the interaction. And as you can see, the human operator is prompting for a cluster health check, and the bot displays the status based on the prompt. So this is the screen that I was mentioning. This is a Slack screenshot that I just now mentioned about. So the main components of this bot are user interface, which is in Slack, a chat bot engine that interacts with event stream clusters and application, various APIs for authentication, APIs for cloud services and third-party systems like PagerDuty and ServiceNow. So the bot is an in-house solution that we built using Golang libraries, Kubernetes libraries, Golang, IBM Cloud, and third-party Sarama libraries. And some of you might be aware of these libraries already. Below is the format of some of the commands used. Usually they have a cluster name followed by Kubernetes namespace. The bot interacts with IBM Cloud and displays the list of clusters and the pods that are present. So this is quite handy when someone needs to know the list of pods in the cluster and what pods are unhealthy. Also, the operator is able to dive into the configuration of the pod and the logs using different commands. There is an option to display the health status of the Kubernetes clusters, and this provides information such as pod, cluster, and worker health status. Also, it displays if any update operations are executing on the cluster, and also the list of not ready pods. This command uses PagerDuty Golang library and displays information which is also present in the PagerDuty UI or the front-end screens. So information such as incidents and changes. Any of the production issues are due to node-related issues, and we typically replace the nodes or reschedule the pods. The infra-specific commands, there are a set of infra-related commands. So these help with information such as worker status, storage, and networking details. Also, we use Sarama libraries to get the Kafka status and to interact with Kafka. And the health check command displays a handy information about a brief information, a snapshot about Kafka health. So this is quite helpful when investigating customer issues or troubleshooting Kafka-related PagerDuty alerts. That brings us to the end of this presentation. Hope you found this presentation useful and interesting. So if you are curious to learn more about any of the information that I shared, please contact me in LinkedIn, and I'll be able to further answer your questions. Just please note that I will not be able to share any confidential information specific to IBM though. So thanks for listening for this presentation, and have a great day ahead.
Okay, Tim. So that was a very interesting talk. Our next speaker or next recorded speaker is from Yosef Arbiv. He's our R&D team lead at Cisco. The talk is about how to use OpenTelemetry to troubleshoot, monitor production environments. So let's go ahead and share his recording.
Hi, everyone. Thank you very much for joining me today. My name is Yosef Arbiv, and today we're going to talk about how to troubleshoot and monitor your production applications with OpenTelemetry. So we will start with an introduction on observability in general. Then I'll explain about OpenTelemetry, what OpenTelemetry is, and how can you leverage this open source project to gain better observability and better monitoring for your applications. And we will finish with a live demo of using OpenTelemetry to troubleshoot applications. So let's start. My name is Yosef Arbiv. I'm married to Adi and father of 3 amazing young boys. I work for Cisco ETNI, the Emerging Technologies and Incubation Group in Cisco. I am a group leader, and my group is responsible for contributing code to the OpenTelemetry project. Let's start with some observability basics. So what exactly observability is? Observability is a measure, it is a property of your system, and it is a measure of how well can you know what's the internal state of your system by looking on the external outputs of your system. So how well can you understand in which state your system currently is, or what's going on inside your system by looking on the signals that your system produces? You can say that your system has good observability or limited observability, for example, but let's try to understand what exactly does it mean in the context of software development. So let's consider this basic example for a monolith architecture when all of our logic is running on a single host. So this is an example for a web application. And after we deployed it, we want to understand whether everything is working as it should be or not. So we would like to, usually the first thing that we do is that we install an agent on this system that will collect some metrics from the host, and we'll send them to a dashboard. So we can look at the dashboard and see whether everything is working fine or not. And then let's say we have some error, we have an alert on our dashboard. So we need to look again and to search for the logs in our system. So we would like to install another agent usually that will collect the logs from our software, and hopefully it will send them outside to some log aggregator, and we will be able to look into this log and to understand what exactly is happening inside our system and how to fix this error in our system. But what happens when we move to microservices architecture? Nowadays, more and more companies are moving to a microservices architecture, and this is happening for a lot of very good reasons. This is why it is so popular, but it also produces some challenges to the development team. This is an example for a very basic architecture for a web store, a demo web store that is running in a microservice architecture, and you can see that there are a lot of different microservices that are talking to each other. It is very different to understand what are the microservices that we have in our system, which one of them is talking to each other, which one participates in each flow, and to gain a better observability of the system is much harder than in the monolith architecture. So I want to talk about 3 main challenges that teams have when dealing with microservices architecture. The first challenge is to model your system. If we go back to the definition of observability, the definition is to understand in which state our system currently is. But when we're talking about microservices architecture, we have a lot of different states that our system can be in because we have so many different services. So even understanding what are the different states that our system can be in can be very difficult when we're talking about microservices architecture. So understanding which are the microservices that our system uses, which one of them participate in each flow, this is the first challenge that we are facing in this case. The second challenge is troubleshooting the system. Let's say that we have an alert that we have too many 500 errors in our system. It can take a lot of time to search for the root cause of this error, because we'll need to search between different logs of different services and to try to correlate them and to understand which microservice is responsible for this specific error. Only then we can start look into the root cause inside this microservice and hopefully fix this issue. And the last challenge is optimizing the system. So let's say we have a customer that's complaining on that a certain flow in our system is not as fast as it should be. Again, we need to search between all of the different microservices that are a part of this flow and to understand which one of them is responsible for this behavior. And only then we can start fixing this error. So in order to deal with those challenges, we have the three pillars of observability. We have metrics, logs, and traces. Metrics are essentially numbers over a timeline, and metrics tells us what is happening inside our system. Then we have logs. Logs are the most essential kind of output, kind of telemetry data that almost any kind of application produces. And logs tells us why something happened. And we also have traces. And when we are talking about distributed systems, we need to talk about distributed traces. Distributed traces tells us where something happened inside our system. So a distributed trace tells us the story of an entire transaction as it propagates through our system. This is an example for a distributed trace in a timeline view. Each tile here is called a span. A span is a single unit of work in our system. Usually, it is a representation of one microservice in our system. All of these spans together are a distributed trace. This is another representation of a distributed trace, but this time in a graph view. So each node here is a microservice, and the arrows are one or more spans in our system. You can see how this representation, how this distributed trace can help us understand that we have an error in this operation, and you can see that the error is coming from a specific microservice within this trace. So we can understand why this error happened, and we can jump to the logs and try to fix the error and to be able to understand the root cause of this specific error in a specific microservice. But how do we implement this? We need to collect a lot of different spans from a lot of different microservices. We need to propagate context between those microservices, right? So we are able to connect those spans in our backend, like you see here. Then we need to export this data. We need to send all of these spans from our application to some backend. We need to store the data on the backend, and we need to visualize it so you can search for it and investigate it when you have issues. So this is why we have OpenTelemetry. OpenTelemetry helps us to deal with a subset of these challenges. So OpenTelemetry is an open source project. It is a part of the CNCF, the Cloud Native Computing Foundation. So this is an open source project that is not backed by a single company, but it has a wide range of vendors, of contributors that are maintaining this project. And let's try to understand what exactly does it provide. So OpenTelemetry is a collection of tools, APIs, and SDKs, and it deals with instrumentation, generation, collection, and exportation of telemetry data, which is metrics, logs, and traces. This is a typical architecture of an application using OpenTelemetry. So we have APIs and SDKs that are running beside our applications. or as a part of our application. We can also have processors and exporters that can run as a part of our application or beside the application. Then we have the collector, and eventually we have the telemetry backend. The telemetry backend is not a part of OpenTelemetry. This is outside the scope of the OpenTelemetry project, and we will explain later what are the different kinds of backends that you can use if you're using OpenTelemetry as your data source. So let's talk about what OpenTelemetry provides in more detail. The first thing that OpenTelemetry provides are the specifications. The specifications are the definitions of how the telemetry data looks like. What is a span? What is a trace? How does a metric look like? And so on. The specifications also specifies what are the expectations from the SDKs, how does the APIs look like, and what is actually implemented for every programming language. Then we have the language SDKs. So for every programming language, we have the SDK, which is the implementation of the specifications for this specific language. Usually we have two repositories in OpenTelemetry. You have the core repository, where we have the implementation of the SDKs. And we have the contrib repository, which contains extensions for this language. So in the contrib repository, we will have the processors and the exporters, so we can process the data and export it directly from our application to a wide range of backends or to the OpenTelemetry collector, which we'll talk about in a moment. And we also have the automatic instrumentations as a part of our extensions. So if you go back to this example of a distributed trace, you can see that there are a lot of different frameworks and microservices that we are using as a part of this operation. And from each one of those microservices or frameworks, we need to send a span to our backend. So in each microservice, we need to collect the data about the span. We need to collect the data on when it was started and ended, some metadata on it, like transaction ID and customer ID, and also to collect the data from the framework itself. So for example, if this is an HTTP, what was the operation, what is the return code, and so on. And as you understand, we don't want to do all of this work manually, right? We want to do it automatically. So OpenTelemetry provides automatic instrumentations for a lot of different frameworks. So you can automatically instrument it without the need to change code or with very minimal code changes when you are adding OpenTelemetry to your code. Additionally, we have the collector. The collector is a tool that OpenTelemetry provides. It can receive data from one or many different OpenTelemetry agents or applications that use OpenTelemetry. It can also receive data from data sources that are external to OpenTelemetry. Then we have the processors that process the data and exporters that can export the data to one or many different backends. The collector can run on the same host that is running your application or on an external agent. But if you remember previously, I mentioned that there are exporters that can run as a part of your application. So when do you want to use the collector? The collector can be used to reduce the overhead from your application. So if you don't want your application to have the overhead of connecting the backend and sending the data over the network, you can use the collector, and then this overhead will be somewhere else. And you can also have the collector if you want a specific place, a specific node in your application that sends the data to the backend, and then other nodes in your system can be disconnected from the telemetry backend. Another reason to use the collector is if you want to use the processors in the collector that can process the data and maybe remove some unnecessary data, so you save the network overhead and hopefully some time and money on your backend when you don't want to send all of the data that is collected to your backend. So let's talk a little bit about the backends. So the backend, as I mentioned before, is not a part of OpenTelemetry. You can use one or a couple of many different solutions as for your specific use case. So there are a couple of open source backends that you can use. There are many commercial solutions that you can use. They are listed in the OpenTelemetry website, so you can search for the different vendors that support OpenTelemetry. And at Cisco, we have the AppDynamics Cloud, which is a monitoring and troubleshooting cloud-native solution that supports OpenTelemetry natively. Let's talk on some of the things that the OpenTelemetry community provides to its users. So first, we have the OpenTelemetry documentation, where you can search for documentation on how to use OpenTelemetry, how to use the different backends, how to create your own instrumentations, and so on. Of course, we have the GitHub repositories where you can see issues and open issues for the different tools and SDK that you're using. We also have a lot of Slack channels. So in the CNCF Slack space, we have a lot of different channels for OpenTelemetry. So you can ask questions on your specific use case and get answers from the maintainers and other people in the OpenTelemetry community. And there are also SIG meetings. So for every sub-project in OpenTelemetry, we have a SIG, which is a special interest group that manages this specific sub-project in OpenTelemetry. And those groups are meeting usually once a week. So if you have something that you want to discuss with the maintainers or with the contributors, you can join those meetings and add the item to the agenda and talk about it with those individuals. Another great thing that is provided by the OpenTelemetry community is the community demo. The community demo is an example application, a web store, which is built in a microservices architecture. You can see that there are a lot of different microservices. Each one of them is written in a different programming language. And you can understand, by using it, you can understand how the data looks like, how does it look like to use OpenTelemetry in your own code, and to get some experience on using actual OpenTelemetry on your own. So with that, I want to pause this presentation and check the OpenTelemetry demo, so we can get a better understanding of what does it look like to troubleshoot an application using OpenTelemetry. So let's open the OpenTelemetry demo. I run it here using Docker on my own machine, as you can see. And this is the OpenTelemetry documentation. I opened the Docker deployment, which I used, and I can open the web store right here. So as you can see, we have a web store that sells some telescope equipments, and we can search for some products in this web store. But if you're clicking on this specific product, we see that there is an error, right? We can't see this product. So let's try to investigate this specific issue. So I will use the Grafana dashboards that are provided as a part of this demo in order to understand, to see some more details about this error. So let's open the demo dashboard. You can see that we have some metrics here. We have CPU usage and memory usage for a specific service. And then we have a graph for the error rate. So let's see this graph. And you can see that we have some errors. If I'm clicking on this arrow, I can see that it is coming from the front end service. So let's try to open a Jaeger and see the traces from this specific microservice. So again, I'm going to the documentation. Let's open the Jaeger UI. This is another open source project that is part of the CNCF, and it deals with distributed traces visualization. So you can see that we have many different microservices here, and we want the front-end microservice. And let's try to search for traces with error in them. So let's see. Okay, so we have some issue on our Jaeger. Let's try to refresh it. Okay, so now we can see we got some traces with error in them. You can see that this is a get operation, so it sounds like a good starting point. Let's see this specific trace. So first, I want to look into the properties of this trace. I can see that this is the product ID, and you can see this is the same product ID that we used here. So I'm in a good starting point. And let's see this error. So you can see that we use another service, the catalog service, and that it had some error in it. And the error is actually being transferred from one service to another, but you can see that there is some error because there is a feature flag enabled. The product catalog service failed feature flag enabled. You can also see some logs that are attached to this specific span. And now we understand the root cause of this error, right? That some flag feature is enabled. So I'm going back to the documentation of the OpenTelemetry demo, and let's search for the feature flags. So here you can see the product catalog failure feature flag, and let's try to disable it and see if our problem is resolved. And yes, we can see that it is now working. Let's try it again. So the problem is resolved. So this was a very quick introduction of OpenTelemetry and the OpenTelemetry demo. If you want to get a better understanding of how to use the OpenTelemetry demo, you can get it from GitHub using the documentation of the OpenTelemetry demo. You can connect the OpenTelemetry demo to your own backend if you're using anyone right now, or you can just use those open source tools that I showed you here today to get a better understanding of how to use traces and metrics in your own use case. You can also look into the demo code to understand what does it look like to instrument your code in your specific language or the specific frameworks that you are using. And that's it for today. So thank you very much for joining me. If you have any questions, I'm available on LinkedIn and on Twitter. And I will also be here later today for the Q&A session. So thank you very much and see you around. Bye-bye.
Okay, that was a great speak. Let me present our next speaker, Roy. Some sort of echo, I think. There we go. Can you hear me right?
Yes. Hello.
Hello. So, Roy, in Microsoft Cloud Evangelist, product expert at Sopra Steria. I hope I said it correctly.
Yes.
So, if you're ready, I think we can start.
Yeah.
Yeah. Can you share your screen so I can put it on the stage?
Yes, I will.
There you go. So let me add it. Well, perfect. Roy, all yours.
Okay.
Thank you.
Thank you. Thank you. Welcome, everybody. I'm glad to see so many people are joining this session to continue from the great talk on the APIs. I am going to present a talk about Azure multi-tenant deployment, and to understand a little more about where I come from. I prepared a little slide about me. My name is Roy. I mainly work with Microsoft technology. I've been focusing on the cloud for the last decade. Been a consultant for more, and currently live in Norway, or been living in Norway, this country here for all my life. But as a Microsoft consultant, I've been able to travel a bit as well. I do write articles on my blog, and there's a newsletter on LinkedIn that I like to post on every bi-weekly. Feel free to connect at your own risk in any social media you might find me. I'm happy to help with anything. Or if you're nearby, let's grab a coffee and have a good chat. Moving on from that, I got a little agenda for today. As said, we're gonna look at how we efficiently can use DevOps to deploy code into our Azure environments, and we want to emphasize that this is environments in multiple environments, as in a service provider or customer, or if you're an organization that has multiple tenants or spread across, or subscriptions spread across tenants. So we're going to look at what we need to do this, and go a little deeper into Lighthouse, DevOps, and the infrastructure necessary to make this happen all the way from your code. We're going to look at how this is going to work from your code to how it's landed, and dig a little deeper into what's going on behind the scenes in order to make this work, while wrapping it up with looking at some of the requirements, possible alternatives, and how you can maybe be more suited for your setup. But this is kind of the general way of doing it. So let's jump on to the what. And what do we really need in order for this presentation to be valuable to you? Well, you need to have Microsoft Azure. You need Azure as your platform for either virtual machines or apps or databases or whatever you can do in Azure, actually. We will need to have an environment where we are spanning across multiple tenants, because that's where the multi-tenant deployment comes in, when you want to do deployments to multiple tenants rather than only one. Of course, there's multiple subscriptions involved. You, at minimum, need to have one in each tenant in order to spin up Azure resources. And one last thing about the Azure or Azure AD is that we use service principal. And this is the key to making this work. And it's kind of your identity in order to be able to access this. Of course, we use Azure DevOps, and this is bound to work in Azure DevOps. It might work with other DevOps tools as well, but that's what I mainly work with and know this is working on. So from here, we need a repository to host our code. We need a pipeline in order to deploy the code, and we need what Azure DevOps calls a service connection, which is where we can connect to different subscriptions. And the third important part here is called Azure Lighthouse. It's been around for a while. It is a way to be able to access multiple tenants from one main tenant. So the main tenant in Lighthouse is called a service provider. That's kind of where you host your code. That's where your DevOps organization is hosted. And then you have customers where you deploy code to, perhaps additionally to deploying code in your service provider tenant. So that's necessary parts to make this work. Yeah, a little deeper into what we need, and part one is the Microsoft Azure, and we use the Azure Active Directory. That's the tenant where we have Azure subscriptions. We talked about the Azure AD service principal. That is something called an app registration. We register an application registration, an app reg in Azure AD in order to get a service principal. Service principal is a user. It doesn't have a password. It's not something you can log into, but it's an identity that you authenticate either using a secret or a certificate. And I'm going to come back to that later, but we have recently had an advancement in this identity part where we can see future support for and managed identity. I'll talk more about that a little bit later. So yeah, this is what we're going to need in the part one. Looking at part two, we talked about repository, pipeline, and a service connection. Repository to host your code, to work on your code, and the pipeline is meant for that to connect to service connection. The service connection has the connection to your Azure subscriptions, and we could use multiple service connections, but one pipeline can only use one service connection, and one service connection can only be attached to one Azure subscription. So when we want to do deployment to multiple tenants, we can't just do with this setup using a service connection, especially if we are deploying something that needs connectivity on both the service provider and the customer side. If you deploy something like a virtual network that's going to be paired together in order to get like a front end or a back end feature, you need to deploy that pairing on both sides in one code, which means that you will not be able to use multiple service connections. I'm going to go even further deeper to that a little bit later, but that's part two of it. And we talked about Azure Lighthouse, where you want to have a customer tenant and your service provider tenant. Service provider tenant will onboard customers to your service provider, and this is where we are able to get our service principal authenticated to each customer. And of course, we can permission-wise set you to deploy and have permissions to like 2 customers while you have 50 customers in your Lighthouse setup. So we give the service principal the right amount of customers to deploy into. And what Lighthouse does here is that it goes out and gets an access token from each of your customers, so it can use that one when it runs the code. Gonna explain it even easier later, but it's about being non-interactive with the deployment. If you were to do this interactively, just run your code directly against Azure, you will be able to do it without Azure Lighthouse, but you will be prompted for every tenant on every subscription you're connecting to in your script or your code. That works when you're interactively inputting your credentials, but when it's happening non-interactively, when it's going to happen without your credentials, then it has to be automated, and you have to have automated the connectivity to each tenant and subscription, and that is what Lighthouse brings to the table. Yes, so that's a quick intro to how this is, or to what we need, and a little bit about how it works. Now let's play a little bit about how this works in a little deeper scale before we dive into how we do the actual setup. So we have our code in our repository. We deploy the code using a pipeline. And as mentioned here, the pipeline uses the service connection in Azure DevOps to target the destination for your deployment. The destination for this is your service provider tenant. It doesn't matter if you're going to deploy anything into your service provider tenant or if you're connecting customer to your service provider tenant. We need to go through a main tenant, which is the service provider in Lighthouse. So that's the destination for this deployment in regards to your service connection setup. The service connection includes permissions to which pipelines are able or allowed to use the different Azure environments. So where this is kind of simple then, because the pipeline needs only permission to use one service connection, which is your primary service provider's subscription or tenant. We registered the service principal mentioned earlier in the service connection. So you have to either host your secret or your certificate in an Azure Key Vault for a service connection to get, or in a variable within DevOps. So that's where there are new benefits from the preview feature of using a managed identity. But for now, service principal has been the way to go. Although we do want to keep all credentials out of the code. That's kind of one of the goals as well, that we don't have to put any identity or certificate or secret or passwords within our code. That's not supposed to be there. Yeah. The service principal is then granted the specific permission by Lighthouse in order to understand which customers you are deploying the code to. Maybe you deploy it to multiple customers at the same time, or you're deploying it to one customer. Then that specific service principal in the principle of least privileged access should only be able to access that end of the end game tenant or Azure environment. But using Lighthouse will not give you the specific permission inside the customer's tenant or the customer's subscription. You could go and say, by doing it interactively, that you are invited as a guest to the customer's tenant. You will receive a role or that maybe has a subscription contributor or owner or even down to a specific resource group. But being non-interactively, we need to do this using a service principal. And in order for that to happen, we need to have that service principal in each tenant. We are going to do it in. So jumping into the service principal, we have to register this service principal in each customer's tenant, or if you're a multi-tenant organization, you have to register that specific service principal or app registration into each tenant. And by registering the app registration in your customer's tenant, you will be able to see the service principal. It will follow through to your destination of customers, and the customers can start setting specific permissions on your service principal. So be it only one type of resources or a resource group or a specific subscription, if you divide it into multiple subscriptions, custom roles set in Azure AD will be able to apply to the service principal. So that's how we can set the least privileged access for our deployment. We should then be good at documenting what we actually need access to in order for that to apply. So when this is done, you will be able to deploy your code to the Azure environments using the service principal you have registered in that tenant. And Lighthouse will, on behalf of the service principal, be able to get an access token from each of these tenants and subscriptions you are registered in, and that you are specifically allowed by Lighthouse to operate on. So it's a way to also segment how you can divide code deployed to different customers. So we are all different in how we need to apply stuff, and we're going to use a little bit time to talk about and discuss the use cases a little later. So on next chapter is a little bit more deep dive into an example of how this could work and what I used it for recently, and that is the prime example I touched upon a little bit, where you have network hosted at your customer, but also need to connect those into your service provider network. This can usually be done today using peer-to-peer or pairing between networks. So this is a setup where you have to deploy your code to a network hosted in your customer's tenant, and those are going to be connected to their own separate network in your service provider tenant. We do want to divide them up so they can talk to each other by mistake or something like that. And as looked upon in this slide, you perhaps have a service that they share, but you do have separate data. We talk a lot about ChatGPT, OpenAI, and machine learning these days, and being able to bring in data from each customer's applications and really gather this into a place where you can manage and learn from all the data they can register and bring back to you is one way of leveraging this kind of setup. So we talked about pairing two virtual networks in Azure, that it requires to both networks during the same command. So we create, if it doesn't exist already, we create a virtual network in your service provider tenant. We create a virtual network in your customer tenant. This in itself doesn't require you to be able to talk to or send one command. That's going to be two commands, and you could split them up into different pipelines and different service connections. But we know that doing it down that route can make for a lot of different kind of setup with a lot of pipelines and a lot of service connections if you're a service provider and not a smaller multi-tenant organization. Interactively, we could do this connecting the pairing between these VNets. That's one command to kind of pair them both, and it needs access to both tenants, both resources at the same time. Interactively, we would be prompted during the deployment, so we give them credentials for our service provider tenant, but then the next prompt will be for credentials to the customer tenant. Of course, we don't want to do this manually or interactively every time, so we have to use the service principal combined with Lighthouse in order to cross all tenants without being prompted, without having to do multiple pipelines, multiple service connections, because then we will not be able to perform the pairing itself. Looking at this from the flow, a developer will use the pipeline to push its code. It goes through the service connection, and the service connection is connected to your service provider tenant. It will be authenticated with the service principal. The service principal will use Azure Lighthouse in order to get an access token to all tenants defined in the code where you're deploying, be it multiple customers at the same time, but at the least we have customer VNet pairing to your service provider VNet. So our code will go to both places and start pairing them together in order to create a network between these two. So a little bit about the step-by-step setup of how you would do this. There's not necessarily one way of doing it. This is the order of doing it. You can make it happen in some different orders, but I find this to be the most useful way of doing it. Configuring Lighthouse. Azure Lighthouse is the first part. While this is just a service within Azure, there's no servers, there's no databases or such. You just search for Lighthouse and you will be able to start Lighthouse and configure your JSON files in order to onboard customers. So here's where you create your service provider setup, and from that you gain a JSON code you take on to your customers and deploy it there in order to onboard them to your Lighthouse setup. Once that's done, you're gonna go and create an application registration in Azure AD. We do have to make this a multi-tenant purpose application, so make sure you don't leave it unattended when it comes to permission. You would like to specifically have assigned the service principal or other users permissions to use it, because if you keep it open to everyone, you don't feel like you need to assign it. It will also be open to any user out there in a different Azure tenant. So that's a bad thing, and we saw that recently being exploited in Bing search results, where someone had left their application registration used within Bing open, and basically he was able to grant himself access to change the results of Bing search. So that's not good at all. Yeah, so be sure to have it assigned. Registered application or the service principal and each customer tenant done through the web interface. Will grant the principal permission to either the subscription or the resource group or whatever setup you have at customer side. You need to store these credentials for the service provider, which is the GUID and key or secret, either in Azure Key Vault. I would prefer that for many manageable reasons, rather than in the DevOps variables. We need to create the service connection from Azure DevOps in order to connect to this service provider tenant using that service principal. And depending on how you work with DevOps, you probably do your code and your deployment from like Visual Studio or some sort, and creating a deployment there can also create a pipeline and choose which service connection you want to use. So that's kind of one way of doing it. I'm notified or written in a blog post about how you do it is step by step. So feel free to go there and see how that's going to work out. And let's wrap it up a little bit at the end here and look at some of the alternatives. One of kind of the most used alternative to this is if you are already registered as a partner in Microsoft, the Cloud Service Provider Program. That's a different way of doing it rather than going with Lighthouse. Though there is a difference that you gain ownership of your customers' subscriptions. Often you don't really want that, or you don't need that, or the customer says they don't want you to have that. So that's where my solution, which is more enterprise friendly, works better. than the cloud service provider program. Option number 3, well, not entirely a new option. It will use the same setup, but rather than using an app registration or an service principal, you can use a managed identity. This is recently gone into preview, so test it out, work on it. It has the benefit that Microsoft will operate the identity for you. So what happens here is that you don't use a certificate, or a secret, like you do with a service principal, which you would have to rotate on a schedule and update in the key vault in order to remain secure for future use. Using a managed identity, you will gain access to it on a delegated way, but you don't have to use any secret or certificate in order to do that. We have used managed identities for a lot of other purposes, but now it's the time we will have that supported for in Azure DevOps. Part of the wrap up is that I want to make sure that you don't go into this and suddenly lack an important part, because when you created an app registration and service principal, you will have to register this app registration in your customer's tenant. But this is only possible if you are a Microsoft partner with a proper ID and are able to verify the app registration. This was prior not necessary. You could do this without the verification, but from, I guess, November 9th, 2020, you need to be a Microsoft partner, and a lot of service providers are partnered with Microsoft. Not necessarily all multi-tenant organizations are. So I have come across this issue for a customer that's spanning across multiple tenants, and there's always a good reason for that. And they had to enroll to this partner network in order to be able to verify and do this setup. Yeah, and to sum up the last wraps, I want to take a moment to discuss some of the use cases. One use case I have been working with is dynamic solution, where say if your IT department is managing multiple organizations or split up, and you want to share dynamics, you want to be able to take benefit of being multi-tenant and share the same platform, share the same code, the features, but you're staying separate in each tenant. So you can do this by this setup, and preferably using Azure Landing Zone or such to easily segmentate your setups. A different way of setting up is that you split into your front end and back end, where front end might stay in your customer's environments, while your back end or the service and where you store your data in order to be compliant is done in your service provider tenant. And there's going to be a growing examples of using big data this way. So you will be able to scout out and collect data from all your customers and bring it back home across this setup in order to analyze all data and do some great next step or in your roadmap or for benefiting on analytics to make the right decisions. It's also something that you can do to integrate with AI, where you want to teach based on different customers' data and feed that back into each customer's front end or what they can access. Yeah. So time is ticking. I want to just use the rest of the time to say thanks for everyone for attending, and hope you enjoy the other sessions as well. Feel free to connect at any point, and I think we can see if there's any questions I can answer or discuss. So I want to stop sharing that presentation, perhaps, but
that's great. That's great, Roy. Thank you very much for the talk. Yeah, we have a Q&A session after our next speaker. So I believe you are going to be around, so we can share those sessions. Okay.
Yes,
thank you.
Thank
you. Let me present our next speaker. Our next speaker is Radovan Bacovic. Let me see here. Hey, Radovan.
Hello. Hope you can hear me, right, Hugo?
Yes, perfectly.
Great.
So you're senior data engineer at GitLab, and I believe that I have your presentation already here. I think we can start whenever you're ready.
Yeah, I'm fine. Actually, thanks a lot for the invitation to talk and share our story regarding the data world and how we do the things in GitLab. Maybe you heard, maybe not, but actually the official title is how we're developing data services and data products in GitLab. So actually what we are doing as a data team in GitLab, we are using our product, which we are using to build our product, to build our data product, to analyze the data from our product. And this sentence is completely nonsense for you at the beginning. I would say confusing, very unclear, looks like recursion there down on the bottom. And at the end, it's still very, very confusing. But it's 100% true. How and why? Let me show you. And let's jump into the data team, what we are doing. Maybe you heard, maybe not. I'm working in GitLab company, and it's important to know for us, we're the biggest all remote company in the world. Actually, we're driving our business fully remote with zero office. And of course, everything starts with a mission. And our mission is everyone can contribute. In addition to that, I would say everyone should contribute 100%. Under the mission, we have a set of values we are using on a daily basis to drive our business, and it's fairly easy to remember. It's for credit. We have collaboration, results, efficiency, diversity, inclusion, and belonging, iteration, and transparency. It's very easy to remember, very easy to drive and align with your business needs on a daily basis. When we are talking about our product, also called GitLab, it's very, very crucial and vital things for you to distinguish the company against the product. Name is the same. I would say before it's DevOps product, help you to and support you through your development, software development life cycle. But today, these days, we have DevSecOps platform delivered as a single monolith application to help you iterate faster and innovate together through all stages in your software development life cycle. We have 10 stages for plan, create, verify, for package secure release, up to monitor, govern, and manage, with very detailed explanation on this slide. Sometimes, if you're lazy, don't want to read too much, also expose 10 stages in very humble opinion and very humble expose with only icons here. But actually, the point is the same. Without strong intention to kill you by PowerPoint and many, many slides, I want to share a couple of numbers. I think it's important for you to know and just to feel the taste about our data team and our company. As I said from the early beginning, no office is no problem for us. We are 11 years old company, and from the beginning, we do everything fully remotely. As I said, officially the biggest all remote company in the world. No office is no problem for us. 1,600 plus team members in more than 65 countries and regions around the globe. With few very minor exceptions, we hire the people from each country in the world, which make us 24/7 company by default. We are very proud of these numbers. Also, I think the most important and vital number for us and also for you to know and for us to share, it's about 30 million plus registered users. From small, hot startups over mature and big enterprises, including academia, government and non-government organization, both on-prem and SaaS installation. 30 million plus users are using our product. And more than 10 years, more than 120 times, each 22nd of each month, without exceptions, without exclusions and delays, we release cool and nice features of new products, of our existing product, I would say, end of the month. So you know what to expect, and you know when you can see the new cool features. Where we're talking about single source of truth for us to help us drive our business, it's a GitLab handbook. Officially, it contains 2,000 pages of text on the web, but then officially, I think it's a couple of times more. Why this is important for you? You can easily get and see what is in handbook. It's fully 100% open to the outer world, with few exceptions because we are a public company, but all facts how we drive our business, not only about the data team, you should find the handbook. Where to check? Why? Because let's say if you're a small hot startup and you want to hire new folks in your team, you can easily see what is the process GitLab apply to do the same job. Of course, if you feel you can feel free to fork our version of handbook, adjust it for your needs and use it on your resources, or just simply can be inspired there. For us and for our business, this is a single source of truth. When it comes to the data team, let's check what is inside for us or for you. And also we have our mission to deliver scalable solution with trusted data to the business and stakeholders that can make decisions. In short words, we want to be or become a data-driven company. When we are talking about maturity of the data and our usage, I use data value pyramid to describe in a real example. For purpose of this presentation is laying down on the slide. From all good data on the left, through information, knowledge, and wisdom as the ultimate goal for us in our data team, we are somewhere in between, but with strong intention to move forward and treat data as a knowledge and wisdom. When we are talking about data capability model, and in the early beginning, we understand what's happened. Then we want to migrate and mature our platform to understand what we should do in order to force some events and apply the change. So we're going from descriptive up to prescriptive analytics as our ultimate goal. Our current situation is also in the middle and want to move to insights and right part of this capability model. On that road, we have a couple of challenges we want to sort out in order to move forward and make our enterprise data platform trustable and scalable for the business. We want to reconcile maturity of our recently formed data team against the GitLab. As I said, it's more than 10 years old company and our data team is recently formed. How to reconcile these two things? Of course, what is the cost efficient way to scale and drive our business and our enterprise data platform in a very, very efficient way? It's fairly easy to burn the money if you don't pay attention of the optimization from the cost perspective. And on the other side, you need to drive business and move very fast. How you should orchestrate, harmonize, and synchronize all components in your system in order to deliver what is important for the business and stakeholders. How to decrease time to market and how to move fast. This is one of our challenges. We always think how to go in short toes, move fast, iterative solutions to bring the value to the company and to the business. How to increase visibility, both internally and externally. When we are talking about internal visibility, it means one of my colleagues, for instance, said, okay, I'm using your data, but I'm not sure how do you exist or not, but your data is pretty much okay and useful for my part of the business and my daily job. On the other side, these kind of talks are a very good way to increase our visibility externally and say, okay, we are GitLab data team and how we are doing and drive our business on a daily basis. Maybe you can be inspired. And of course, this leads us to action. And one first of the action I like to mention and can't stress enough to see how vital is it for us is open source, because organically we are open core company and create to and for the community. And it means we strongly embrace the open source as our strategy or initial way how we do the business. Also, because we have our product and we are eager to learn more how to use our product efficiently in the data world and daily business for us. We call that dog fooding. It means get as much as you can from your product and learn as much as you can in order to move faster and faster and automate so many things. Also, we try to embrace and cultivate DevOps or DevSecOps culture. In my humble opinion, it's not a set of tools, it's just a mindset or culture, how you shift your way of thinking in order to embrace the DevSecOps or DevOps way of work. When I start working GitLab, I came from another world, and when it comes to GitLab flow or Git flow, it was 4 types of branches like master, develop, hotfix, and release branches, plus some kind of short-lived branch. Here, when I move and start working in GitLab, I see something called GitLab Git flow, and it means you have only master branch and short-lived branches. I was wondering, okay, how we should do the business and what's the advantage of using this kind of approach. And using our tool with that dog fooding, we easily incorporate only 2 types of branches in our daily work and release process, which is kind of continuous 100% of the time. And it means you do a small incremental change and you merge your code and your change to master branch. After that, if something screw up, you want to revert back, you can easily do that because your change is so small. And our product will do the rest for us because we create a set of pipelines, can do the checks, deploy, revert, and roll back of the code. I'll talk about that later. But new flow is something we should consider as a part of our dog fooding process, as a piece of action we took. We want to iterate fast all the time, moving even faster and release frequently. Also imagine we release code all the time. We have a release train, and if you miss the train, you have another chance very soon, and in your merge request, everything should be automated 100%. So there is no manual work, there is no role like the release manager in our case, because our tool is do that for us. It's also one of the advantage to use the dog fooding approach. And of course, everything, each communication, each request for change, each discussion started with issue. When we define what we want to do, we move to merge request, and everything on merge request level is automated. So also one important part of our dog fooding process. One most vital thing I would say when you're talking about any success business is about the people. So we went through all stages, through forming, storming, norming, and performing phase in order to harmonize the team, define roles and responsibilities. One of my favorite slides is the next one, because as I said, organically we're based on open source data stack. I want to be on the safe side and said mainly. Probably it's not 100% possible to have everything open source, but here is where magic happens. On the left side, you recognize well-known cloud providers. We're a multi-cloud solution because we are based on GCP and AWS at the moment, and also we're using Rancher, formerly Rancher and Kubernetes, formerly Docker, to orchestrate and harmonize the things, especially for local development. You're using Rancher to evaluate the test environment. When we're talking about orchestration part, we use Apache Airflow for all our jobs to orchestrate and load the data in Snowflake, which is a single source of truth for our data storage. When it comes to analytics, using also open source Snowflow provider, where you can track front and back end events from your product and easily get the data in Snowflake. If you have, let's say, major providers, you can easily use out-of-the-shelf tools like Fivetran and Stitch. In our case, some data are easily predefined, like, okay, this is my source and this is my Snowflake target. I want the data in. You pay to these providers, you will see the data. And easily it's everything set up automatically on their portal. When it comes to customer structure, you're using Python code, well-known, and also for data science work, we're using Jupyter. For transformation, we have a single source of truth called DBT, which stands for Database Transformer, and also use Singer.io as an ETL framework and Meltano. Meltano is something we call ETL as a service, which can support you in all stages of your ETL or ELT process. Already mentioned Snowflake as a database, our single source of truth, fully cloud warehouse, Jupyter for data science work primarily, and Sisense, and in future I think it will be Tableau as a visualization process. Something new we should consider, because these days it's fairly easy to create a pipeline and move the data in wherever you want on your target. It's something called data observability tool. In our case, we're using Monte Carlo. It means it provides the full scan of quality, frequency, and amount of your data, which can easily predict based on machine learning models the behavior and, let's say, frequency of your data. If something is wrong, you will be easily alerted via Slack or on their portal or any type of communication you predefine in their tool. I want to also pay attention to a couple of tools I think worth extra additional attention and explanation. Why? Because I think it's handy to try it if you didn't do it before. DBT stands for Database Tool or Database Transformer. It's fully open source. Of course, there is a paid version, but for our needs, we're using command line open source tools 100%. This is a great combination of SQL, Jinja templates, and Python code. And you have out-of-the-box documentation based on your definition from YAML files and working application with full lineage, even on Calm level, if you're using only this tool, and everything can be run using command line or, let's say, Airflow. What is a great stuff here? Because simply you type your SQL code with Jinja templates, you can have a function, routines, and in the last version, you can, let's say, strongly use Python, and the entire lineage is fully automated. But really, really worth to give a try to create your transformation, very powerful tool using only DBT. When it comes to Meltano, as I said, it's a ETL as a service, which supports you in extract, load, and transformation part. Usually we're using for some extractor for not major data sources and providers. We're also proud of this tool because this was created by our ex-colleagues. They're working in GitLab data team before. And also we try to use it as much as we can. Everything is open source. Also, there's some kind of contribution from our side, like we had Adcast tab provider and we create a source. So what is the principle of working in Meltano? You have a tab like a source and target as a database by your choice. So you just define tab and target, and you can easily move the data from your tab to your source and database, and everything can be orchestrated as a cluster. And also you can put it on your resources on command line. Now they have a cloud option, so up to you and your needs to try this kind of tool. As we're talking about data observability, it stands for Monte Carlo in our case because we introduced it last year, and it means you can easily check what you defined, set of your data, all tables you want, for instance, in Snowflake, in BigQuery, wherever you want. Monte Carlo will learn the pattern and behavior of your data, and for time you'll have a better and better results when it comes to accuracy of your data, quality of your data, frequency of data, deletion of your data, or modification. It's fairly easy to be proactively oriented in order to solve the problem with the data. As I said, it's fairly easy to create a pipeline, but it's much, much harder, more difficult to find something wrong in your data. This is a really X-ray for your data sets and can help you a lot. I think this is really must-have part in 2023. Of course, when it comes to the tooling in our solution for data platform is automate the work using pipelines. For each kind of work, we create a set of pipelines help us to automate our work. Let's say we change the Python code, and few pipelines will do and run test cases, check the linters, quality of code, and then release the code if everything is fine and code is reviewed and accepted properly. When we check or change DBT code, also small subset of pipelines regarding DBT will be executed automatically. Of course, some things can be done manual based on use case. As I said, we have versatile test cases and use cases, so we have plenty of pipelines. Everything can be checked in our handbook. Just type GitLab handbook data CI pipelines, you will see the results with full and detailed explanation. About test environments, I mentioned Snowflake is a single source of truth. In our pipeline, the first commit, we create something called test environment, but with single copy clone without additional cost. This is a great stuff. Why? Because you have prod-ready environment in a minute or in a second, depending on the size of your schema or database, fully copied from production. You will not be charged until you change the data. Of course, when we deploy our code or automated after some time, that database will be purged and deleted. In that case, you can easily be very cost efficient and also have a fully ready scalable test environment prod-like. You know the pain when you try to test something and develop something, it's very fast. When you go to production, it's super slow. So that this is the way how we reconcile production against the test, not only about the structure, but also about performance and amount of the data. So you can do a real live test and everything is really deleted after some time. As a result, we have enterprise data platform in open or mostly open source data world. About the people, we have clearly defined roles and responsibilities for each seat in the data team. About the recently formed data team as a part, I'm so proud of these folks from data science team. I think worth to mention a couple of projects they created and super interesting for all of us. Propensity to expand, it means how likely is one customer to unlock more of our 10 stages and start using more stages in our product. In percentage, you can easily and clearly say, okay, this customer in 70% will stay with us. Propensity to contract, it means what is the probability of churn or our customer will leave us and go to our competitor, in which percentage we can be sure, okay, that guy will stay with us or not. User segmentation is used to nicely profile the customer and put it in a proper bucket. Everything in order to have a really great and unique way of communication with the customer without any generic approach. But to check this project as well. As a result, our data is everywhere among all departments in the company. And of course, I like this slide because we put the data in the heart of our organization. And as a result, we have a process. And on this slide, you see DevSecOps process with 10 stages, and everything started with the issue. And through this process, it's converted to MR or merge request, where you can do your changes, and most of the things should be automated. We have a trusted data model. We use this frame to go through all 6 stages to build any new piece of software of data platform. This is super important because you can keep and rise your quality and keep your bar for your quality, because you need to go through all these stages. Without that, it can't be done definitely. Something you heard or not, of course, ETL processing or ELT processing, but we have D in addition to that. It means documented everything. It's very boring part, probably the most boring part for each data engineer or each member of data team. But in the long run, it pays off because you have or create a single source of truth. After some time, you can easily forget what's going on. And if you're searching for source of truth, okay, what I need to do with this data source, so what is the meaning of the data, you can use this D. It stands for documentation. As I said, not favorite option, at least for me, but in the long run, something super important to have. And also, as a process and results, we have a short-term and long-term direction. In short-term direction, we created enterprise data model, trusted data framework, visualize our data, and create self-service and data program. As a long run, we also want to contribute more and more to open source data projects and be able to create a really deep analytics to our GitLab customers using our product. And we want to align and move forward to data value pyramid to be on the top, in our case, on the right side. And of course, on quarterly, yearly base or 5 years base, we'll create KPIs, key performance indicator for the data team. And of course, before we close this talk, I just want to share some takeaways with you. I hope you will be inspired in future or remember something like, okay, I can use it, or I remember I don't talk about that. Maybe it can be handy for us. We are not done yet, and work is in progress all the time. And we want to keep the permanent iteration mindset. Just move, no matter what. We want to iterate and do a small changes and go with short toes and move fast. But on the other side, it's fairly easy to get lost. So we want not get lost the bigger picture and want to remember and know our direction and trajectory of our progress every time, all the time. From the beginning, we support and embrace DevOps and open source principles or mindset or way of working. This is important because this is probably one of the ways how you should survive today and can bring and work your work and create your nice software in the future. Why? Because it's important to go with this principle, DevOps and open source. Sometimes new shiny tools can do the job for you, and it's very fancy, and all engineers want to go and see the latest technology, but most of the time, boring or best practice solution will do the thing for you, and you can done your job or finish your task. So we have something like go for the boring solution principle, which is fairly okay because in 90% of the time, it can do the job for you. When it comes to quality of your code, you should be very strict and very disciplined to put everything you need to run your project in the source control. Do not have something here and there looking for that, so create all another document, sheet, whatever, everything you need to run a project should be in your version control or source control. You should be even more strict about your testing your code and then try to automate everything all the time. If you're lazy, you should automate this stuff, and when you automate stuff, you'll never forget anything, and it will be part of your pipeline. So be very, very strict about this. Be very brutal, cruel, and insensitive when it comes to quality of your code base. You heard and you see the pain when something screw up after 5 years, 1 month, or whatever. It's very costly and expensive operation. Prevent it as soon as possible. Deal with that, and don't forget to automate it. All the things when it comes to how you check your code quality and what is the bar you should raise all the time about your code base. Of course, make your documentation first-class citizen. I already mentioned our handbook, and it's our single source of truth. There is no more searching through emails, through chats, through sheets, create one integrated document again and again in 100 zillion versions. We have our single source of truth. And also I suggest to you to have something like that. It doesn't necessarily mean you should go like handbook. It can be in any format, but up to you to decide what you want to have and how. And do not forget to create your set of values, promote, propagate your values, and leave your values. It will help you to drive your business on a daily basis. Let's clarify before we close what we are doing. We are using our product GitLab to build our data product, enterprise data platform in another world, and to analyze the data from our product called GitLab or gitlab.com. I hope it's much more clear now, right? And don't forget the mission, everyone can and should contribute. Of course, this is me, or this QR code is me. If you want to discuss, to ping me, to ask you, or just to have a coffee chat, do not hesitate to contact me anytime. I'm always eager to see what's going on in the community and to bring something back to the community and also learn from community. And of course, at the end, large thank to you. I hope you enjoyed the presentation. I think now we'll have a Q&A session. If you have any questions, feel free to ask. Have a great day. Enjoy the conference. Thanks.
Thank you, everyone. And thank you for a great talk and very comprehensive information in each of your slides.
Thank you.
Let's go for a Q&A. Let me see if I have everybody. So I have Roy, I have Roland. I think we may, I don't know if Joseph is going to join us, but meanwhile, I think we can start with some of the questions. Okay, so first, yeah, we have our first question. Is it always good practice for developers to have an all-in-one platform to manage DevOps stuff? I think we're going to do a round, so each of you can answer. So Roy, maybe you can start.
Oh yeah, I would say that all-in-one platform is one way to go, but you don't necessarily get all the tools you would like if you're putting all your things in one basket. So usually the platforms we work on are connected to different third-party services that provide us with certain features or services that we use, for example, when it comes to plugging security into DevOps. So if I get the question right, it depends. You can work with all in one platform, and it's probably easier, but you will probably lack some tools that you could benefit from.
Yeah, great, Roy. I agree with you. Actually, there is a very easy answer to say, yes, it's cool to have everything all in one. But on the other side, there is hard answer, especially if you're working for clients. There are many of limitations, like, okay, we are using this tool. There is nothing you can change. So also you need to adapt and adjust and put your things in several baskets. And also from DevOps stage evaluation, you start from self-made DevOps tools, and ultimate stages have one size fits all. Like let's say, for example, it's GitLab tool. I don't want to advocate for GitLab. I'm working in that company, and we have no limitation except to use only that one tool. But from case to case, I would say probably the truth is somewhere in between. Depends on your needs and type of a project, actually what you want to have, what is the goal of your project and what is your budget. Sometimes you just don't want to pay for something, or you have a lot of limitations. So I would say easy, quick answer is yes, it's cool to have. Hard answer is depends on the situation. Probably it's not always the perfect world. So that's my answer, definitely. So I will give it you, Roy.
Yeah. Thank you for those answers, guys. Let's go to the next one. Is it possible to transition from network engineering role to DevOps? What is the best roadmap to quickly learn and also get a role?
Yeah, I can get onto that. I can relate to this. I'm not coming from a specific network engineering, but I'm an engineer for virtual platform, and going to become a DevOps engineer. It's not hard. It was kind of something that inevitable would catch up to me, because even as a network engineer, when you're dealing with Azure or Amazon or Google, you have to consider deploying your networking appliances and networking configurations as code. And doing that from a DevOps perspective with code, you need to know how things work and what is a pipeline, what is a repository, what is it that you need to do in order to do this. So by going from network engineering to coding and deploying your network as a software, it will get you a long way to actually becoming a DevOps engineer.
And also, for sure, these days, this DevOps role is in high demand, definitely, especially with rising of the cloud or cloud-only approach. And also, I would say suggestion, if you make a transition from network to DevOps role, is to have that abstraction, like everything is now as a service most of the time, if you want to switch to that world. And I would say, from my point of view, also, I'm not coming from network engineering background, but I think it's a good advantage because you fully, deeply understand what is going on when it comes to network. And also there's some specialties in depends of cloud platform, but you should learn and also grab that part and that part of the role. So it's not strictly just DevOps. You can be a network engineer in cloud world, but also combine it with DevOps strategies. And also in our case, it's kind of DevOps to manage and deploy everything on our own, the entire data platform. And also I would say probably the quickest way to learn is to open a repo somewhere, depends of your preference, any tool you want, GitHub, GitLab, you name it, and then start working with cloud components and run DevOps. And I think also I call all of you, because we have very generous free tier in GitLab, you can run our GitLab runners, you have 40 minutes per month or something, 400 minutes per month. So it's more than enough to learn something. And also resources are for free. So basically just try and put your hands in dirt. That's always the best advice.
I want to add that I previously written articles, or not long ago, about my journey from being more ClickUps to being able to fully submerge myself in DevOps when it comes to especially Azure and the development there. So without doing a commercial, feel free to look me up and I can show you how I made it. And I agree with you. DevOps is not necessarily a role in itself that you only have. It's something that you use in your network engineering.
Yeah, definitely. It's too big to cover only with one position. You can find your niche and focus exclusively on that part, or depends, you can try this and that, and you'll find your preference and really enjoy the journey. So I agree with Roy here.
Correct. Yes, I agree with both of you. So yeah, and some of the concept of DevOps is that that's why we have this the image, that is a progress. So it's not just a role, it's like a methodology or a way to work, So let's go to the next one. Which certifications are key in making in DevOps? Any advice, guys?
Oh, well, what helped me kind of know where I am when it comes to knowledge is by doing certifications. Of course, I make it day to day, but it's also nice to have a stamp on it. And I am, as a Microsoft evangelist, focusing heavily on Azure DevOps. So there are certificates in Azure DevOps that you are able to work on and pass. Not sure. It's not a way to start, but it's definitely something you should consider as a value to when you're feeling ready for it.
And also, despite of the cloud provider, there is a disclaimer: do not try this certificate until you have 1, 2, 3 years experience, which is also good, because if you try it without experience, it can be super difficult. After some time, it will be really better than better for you. So you can easily and fully, deeply understand what's going on in cloud. So from my point of view, it's not necessarily to have a certificate, especially when you start. You need hands-on knowledge, and how you get the hands-on knowledge, you need to practice. After some time, it can be a good milestone, or it can be a good structured knowledge for you, just to have a shortcut. If you have some experience, like if you're in analytics or big data, you want to move more in network, okay, then you should apply for certificates, because you have a structured knowledge here somewhere prepared and ready to eat for you. But it's not essential to make a progress or be part of that DevOps role, in my humble opinion.
Good. There's another question here that is interesting. Is any of you are usually using VMware as backbone for virtual machines?
Not usually. As a consultant, and I've been heavily focusing on cloud the past 10, 12 years. So that's not where I work, although we do create within my company our own cloud solutions, which is based on VMware called Solid Cloud. So yeah, there's good things there, but you're probably building your cloud and not just deploying to a cloud.
Yeah, in my case, it's similar situation, except I'm coming from and want to talk from data perspective, as we are running enterprise data platform when it comes to DevOps part on our own. So actually, we're using Kubernetes cluster mainly on GCP, Google Kubernetes Engine. So it's probably the preferred way how we do the things, or we create virtual machine in the cloud, because we are cloud only or cloud first or whatever cloud option for us, which I think in my experience is much better option these days, especially in the last 5-10 years. A long time ago, I'm a little bit older, we used VMware as a backbone for virtual machine, but it was on-prem era, and now on cloud era, I think suggest you to go with Kubernetes or any kind of virtual machine. Depends on your needs and size of amount of work you have. Yeah.
Good. Now, Radovan, here's a question. Thanks for the nice presentation. May be a bit of out of topic. Do you see any introduction of GitHub Actions made life difficult at GitLab? If yes, what could be the strategy to tackle it?
I don't think so. I don't see any problem with that. So for me, it's okay, I would say. And to be honest, I do not use it very often. For me, it's kind of this dog fooding is still in progress for me and for all of us. As I said, there are plenty of options. For our daily work, it's more than enough. But businesses request for us or what we want to evaluate. So I would say no strategy from my point of view. Google ask, probably it's a better option than ask me in this case.
Yeah. I would add that it's healthy to have competition in the market. So this is only something everyone benefits from.
Definitely, it's always good to have, I would say, and it forces you to move forward faster and faster, right? I mean, it's healthy competition. I mean, I won't say it's competition. It is, but actually, it's a different point of view. Just want to say this: GitLab is open source software for closed source solutions. And GitHub is other way around. It's a closed source platform for open source projects mainly. So I would say it's something like that, but yeah, it's always healthy. As I said, in our company, exclusively we're using GitLab and nothing else when it comes to DevOps approach.
Okay, good. Next one here. I would like to know if the panelists can provide some open source tools that can be used for self-service dashboard analytics with AI, connect them to the end of the data pipeline.
I'm sorry, I'm not able to provide such open source tool. Not something I've been working on.
Yeah, I would say usually for any dashboard you should pay if something is serious. I think that's probably the not strongest part when it comes to open source. I don't know how it's going these days, but Streamlit can do the job for you. I did some evaluation, and I think it's acquired by Snowflake, if I'm not wrong. But also there is still open source part for visualization, and dashboards can do many things for you, especially Python is under that. So that's my number one recommendation for you, Streamlit.
Okay, I think Joseph is having some issues with the connection, and we saw all the questions already. I'm really thankful, guys, for all the time that we spent together during these sessions. It was as usual. There's a lot to discuss, a lot to learn. Thank you for that. And I think we will see later on other speaks, and that's also all for me today. I think I'm going for the next round of speakers. I think we have Gustavo as the moderator, so I'm going to virtually send him the control, and he will continue later.
Yes, thank you, Hugo, for your help today. Thank you, all our speakers. It was very pleasant to hear you and see you today. I hope that we will continue cooperation with you and we will meet you on our future events. So thank you a lot, guys. We will have break now.
Break ahead of us. Thank you all for joining. This is the middle of the event. This is not the end. I gotta specify it, but yeah, we have a next session coming up in around 40 minutes. So we have enough time to get yourself a break, to grab yourself a meal, maybe do something, but return to us later for 2 more blocks of the sessions. But for now, thank you all 3 of you for joining today.
Thank you.
Thank you, folks. See you. Bye-bye.
We have Yosef. We have Yosef just joining. Yosef, your voice is very robotic. Can you please reconnect and double check? Yes, because the voice is really robotic. I'm gonna very quickly take a look if we have some questions for you. So yeah, people, we finally have Yosef here with us, so I can ask you something.
Hi, can you hear me now better?
Yes, it was so strange. But yeah, it looks good now. Yeah, so now that Hugo obviously said his goodbyes and other speaker as well. Yeah, we had this Q&A session a bit earlier than was planned before. Let me just find a couple questions that was for you. So give me just a few moments to double check with questions we might have for you. So I think.
So this question was for you, and I just deleted from our.
Yeah, we actually went through it probably, but yeah. So what's the reason behind using Golang as a context?
So I'm not sure what this context refers to. Maybe it's regarding the OpenTelemetry collector. I'm not exactly 100% sure why Golang was chosen for the OpenTelemetry collector, but basically the OpenTelemetry collector is just an executable that is being run on whenever architecture you're running it. So it doesn't have such a huge importance, the specific programming language.
Okay, yeah, I guess that's answers. So yeah, speaking of Golang, we actually have our first Golang event planned for later this year. Check it out. It's event.geekle.hr/Golang. I'm just saying this. Yeah, for our audience. So this was more probably for you. Is OpenTelemetry a standalone monitoring service? And if yes, how is it different from Apalnes, Splunk, etc.?
Okay, so OpenTelemetry is not a standalone monitoring service. it is actually it deals with the telemetry data generation. So only the part of the telemetry data generation is taken care by OpenTelemetry. And the idea behind OpenTelemetry is to be a unified way of generating the data and collecting the data and exporting the data to whatever system you're using as your backend. So if you're using Splunk, Grafana, or any other Jaeger, App Dynamics Cloud, or whatever you're using for your monitoring and observability system, OpenTelemetry should support it. And those vendors usually support OpenTelemetry. So the idea is by the mission and the goal of OpenTelemetry is to be a unified way of generating the data. So regardless of which vendor you're using to process the data and to visualize the data, you have one way to create the data and to send it to this system.
All right. Thank you for clarifying. There is a question that was most probably asked before, but are you using VMware as a backbone of virtual machines?
I'm not that I'm not sure I understand the context of this question. But if you're referring to the OpenTelemetry demo, then I use it with Docker and Docker Compose, and you can also run it with Kubernetes.
Oh, okay. Thank you. Yeah, we'll have more about Kubernetes in the next block, so definitely stay until that if you want to learn more. Okay, we have one more question that was asked for everyone, but can you provide some open source tool that can be used for self-service dashboard analysis with AI for connecting them at the end of data pipelines built?
Yes, so I'm not familiar with such tools.
Okay.
I'm sorry.
Yeah, okay, that happens. But let me just
Sorry, I have
let me
an
just
issue with the
do this real
camera.
quick.
So 1 second. Yeah.
Oh, okay. Yeah. So what is your take on this?
So I'm not familiar with such tools for AI.
Well, there's a lot of new tools, and of course,
Yeah.
it's hard to keep up with them. And like we ourselves, I'm sorry for another shameless plug, but yeah, this year we're trying to collect these knowledge for people who are doing AI in their jobs, and of course for software development and software architecture. So maybe we'll be able to talk about that as well. We have those events in summer. Okay, Yosef, I thank you for joining this. On this session, real quick Q&A session at the end of the block and answering a couple of questions. Let me double check if there are any more. I think that's it for now. So that was a short one. So we'll continue. We'll go through our break, and thank you for your presentation one more time. And hope you will.
Thank you very much.
Join on our events in the future. I'll have a
see you.
Good day. Yeah.
Bye.
Right. So. As I said, we still have a session in 35 minutes from now. I want to bring my colleague Paul to the stage because at the beginning, at the intro, he mentioned that we have a partner. And so that partner provided us some goodies.
Yeah. So we have partnered with this publisher. They called Manning.com. Probably you know them, and probably you have own you have their books, or maybe you own a PDF or EPUB of one of their books, because they have lots of cool books on programming languages, on practices, and so on and so forth. And what they did, they gave us a special discount, so it's going to be a 35% discount for all of their books. And also we have from them 3 copies of their books for free. So what I'm gonna do, we're gonna post those claim codes. So basically it will be a claim code for using and redeeming this code on their website. So I'll post the link to their website in the chat, and also you can use this this special code, a gift code, to get yourself a free copy of one of their books. And the book that we are giving out today is going to be Azure Infrastructure as a Code. So yeah, you can grab one of those 3 books for free today. And yeah, I will send them to our broadcasting team, and Nick will help me with posting them to the chat. Yeah, and also we will have this code also in this promo code in our Slack channel. So if this chat goes too fast and it gets lost, so you can use the link or the QR code. So we'll also have a QR code if it's easier for you to scan with your phone. So basically, yeah. So thank you, Manny, once again for helping us out with some resources. So those 3 codes, they will be available for grabs throughout the next session. So we will post them gradually. So we will post one, and then second, and then third one. So please look for those codes, the redeemable codes for free books in the chat. Yeah, and have a great rest of the day today. And yeah, let's have a quick break. Maybe grab yourself a sandwich, a cup of coffee. And it was nice talking to all of you today. And I hope to see you tomorrow also. Thank you.
All right, everyone, we are back. I think we can start our third block, second part of the event. We have still lots of topics. We have 6 more sessions ahead of us and also Q&As. So I want to welcome back to the stage from our previous event, our amazing moderator, Gustavo. So welcome. How are you doing today?
Hello, Nick. I'm very nice. Thank you very much for having me here again. It's a pleasure to be here.
Yeah, were you watching the previous talks?
Well, I tried, but I couldn't, unfortunately. But I
definitely will be able to watch these ones. Yeah, so where are you joining today from?
I am in Scalea, at Scalea in Italy right now.
Oh, awesome. Yeah, I think we can start with giving the intros for our first speakers. So I'm leaving the stage to you.
Okay, Nick. Thank you very much. So, guys, it's a pleasure to be here with you again. Last time I was in Brazil. Right now I am in Italy. The weather is good, but it's cold for me. Not very good for Brazilian people here. It's 13 degrees Celsius right now. So our first talker will be Marko Jovic. I believe this is that I pronounce that. Hello, Marko. How are you? I can't hear you, Marko. I still can't hear you. I don't know if there's some issue with your sound there, with your microphone maybe. Yeah, I still cannot hear you. Let's try to see what's going on. Oh, yeah, I heard something very briefly. No, not yet. Okay, well, sometimes there's just a brief sound. I don't know exactly what's related to. Okay, while Marko is trying to fix his sound, I will tell you a little bit about Marko. Marko Jovic is a senior DevOps engineer at ASAP. Oh, yeah? Yep, I believe something happens. Yeah, oh, yeah, now it's fine.
Yeah.
Thank you.
Sorry for this.
Now it's
So,
fine.
hello, Gustavo. Greetings from snowy Belgrade. So maybe you can see behind me.
Oh, Belgrade, very nice. How is the weather there?
So it's snow.
Oh my God.
Yeah, winter in April. So it's not so good, but yeah.
Yeah, but you don't seem to have a cold to be cold there. You are used to the snow already.
Yeah, this is today's surprise. So
okay, Marko. Well, thank you very much for being with us today. I will tell you a little bit about Marko. He's presenting today moving SPM workflow application on Kubernetes. So Marko is a experienced network and cloud infrastructure engineer with a demonstrated history of working in multinational information technology companies. Last few years, he's working as a DevOps engineer with focus on cloud technologies on all the cloud providers that I can see here: AWS, Azure, and Google Cloud Platform. Well, Marko, tell us a little bit about your professional life or about your life in Belgrade.
So last few years I'm working as DevOps engineer. Currently I'm in SAP, and there I'm working as a DevOps in development team. So it's very interesting because every POC you are responsible for that. Every migration and testing things you are on the beginning, and you are on the end, on handover to other teams, and to follow everything from the beginning to the end. And that's the most interesting here on this position. Previously, I worked in Endava, again as a cloud engineer, and the most experience I have in AWS. Before that, I worked as network engineer. So I'm network guy who moved in the DevOps.
Well, that's a very nice combination.
Yeah, it is.
Yeah. So Marko, thank you very much for being here with us today. And do you have a presentation here?
Yeah, I have it. I think that I already uploaded. Yeah.
Yeah. Okay, Marko. So thank you very much again, and the floor is yours.
Thank you, Gustavo. So let's start with our use case today. So workflow application is, let's go to see what is workflow SPM application. So it's a business process modeling platform. What that means? So if you have some business and you want to describe it and improve it with some application, you can engage workflow, and you can everything track in it. It's similar to SAP application, but on lower level. So related to the features, workflow can be multiple platform for multiple things. For example, it can be case system, ticketing system like Jira, for example, but also it can be application for paying salaries, for example, scheduling payment, scheduling things, and also we have, for example, scripting feature. That scripting is, for example, you have your database and you have our application, and you can export data from our application into your database, and with this scripting, and then you can use that data for your purposes, for example. Also, SPM workflow is selling in the bundle with other SPM applications like commissions, like territory quota, and other applications. So here you can imagine that we have integrations and very interesting things from engineering side, because you need to integrate everything with other applications and things. So this presentation, I created it to compare things what we had on-prem. When I say on-prem, I'm thinking about virtual machines, and what we will have on Kubernetes and on pod deployments and things. So during this presentation, I will compare things, what we had on virtual machines and what we will have and what we have already on Kubernetes. So first of all, I wanted to explain the project and how everything begins. So before 2 years, SAP decided to go on cloud, and that means that cloud is the priority for SAP products, applications, and the much as more things that we can run on cloud to be on there. So that project is called One Strike, and that project is very, big, and it is still in progress. So plan for our application was to move from virtual machines. We had, and we have still virtual machines on some private clouds and our cloud, SAP cloud. and we needed to move it from these virtual machines on Kubernetes clusters on some hyperscalers or BTP platform. BTP platform is SAP Business Technology Platform. Maybe somebody of you heard about that. It is a platform developed by SAP, and there you can create everything what you need for your application. So plan was to run pods, but again, to keep all code same as much as possible. So to not to distract developers and guys who is maintaining complete application, because we wanted and aiming that run application into same application on-prem and and also same application to be same code to be on Kubernetes. It was very tricky, and it was very complex to achieve that, because on one side you have virtual machines, you have storages, NFS, and all other things, but on the other side you have containers, and you have just only one process in that container, and how to achieve this and how to split into microservices, because it was let's say monolith-like application, but without too much developing and programming, and so related to the included teams, we had a lot of teams included in that project. For example, a release management team, also DevOps team who maintained clusters. On the beginning, I mentioned that I'm DevOps in dev team, but we also have whole DevOps team who created cluster for us, who are maintaining Istios and things, so security and everything, and we are deploying our applications. So also we have PMs, POs, and all other teams included for that huge project. So when we are speaking about the tools and platforms, on the left side, we have some tools that we are using for building, deploying CI/CD, for hyperscalers and other things. So mainly our Kubernetes clusters are spin up on GCP, and we are using Jenkins for building our application, for building our Docker images, pushing them to the Artifactories and to the repos. Then for the code revision and for code tracking, we are using GitHub, and normally we have webhooks and things. Everything set it up for CI/CD, and first of all, we needed to deploy new deployment procedure for deploying to the Kubernetes clusters, and we made something like a Helm, but with ourselves, and we made it very well, because we can on click, we can deploy whole production or whole development or whatever you want. So production is not continuous delivered, because we want to have control on that, and also we wanted to track everything to track everything and to avoid some disruptions in the services. On the, I don't know why it is changing, but okay. So related to the right side, there is a technologies with what we are using for our application. So we have 7 groups of Tomcats. These 7 groups are, so we have identical code, but with different settings achieved by config maps, for example, from Kubernetes. And these tomcats are acting, 2 of them are acting like a front-end tomcats, and 5 of that groups are acting as back-end tomcats. Also, we have Hazelcast. It's like a memory cache for these tomcats, and there we are maintaining, for example, user sessions. Why we have a sessions? Because application has 0 downtime deployments, and during deployment, user can be on one tomcat, and when this tomcat is down, we can store user session on Hazelcast, and then when this tomcat is shut down, when it is transferred to another tomcat, his session will be good, and it can continue to work. That's for example. Also, we have a RabbitMQ. It is for asynchron tasks, and because we have a lot of scheduled tasks, asynchron scripts, and we need to have that for that things. For database engine, previously we used Postgre, then Oracle, and now we are using SAP HANA. I don't need to waste my words about HANA. It's super powerful database engine. And also we have a Liquibase. It is like a job in Kubernetes. It is for DB upgrades. So our deployment is based on a DB upgrade, and then new code deployment on Tomcats. So here you can see some block diagram for our application. So everything is on Kubernetes cluster. We have two groups of Tomcats for API calls and for user traffic. It's deployments, and we have some auto scaling for that if we have a problem with traffic or memory consumption. It can be increased, and if everything is good, then this deployment can be decreased with pods and things. Also, we have backend Tomcats. It's 5 groups of them. Some of them are for notification, for example, sending emails or something like that. Also, we have some scheduled tasks. And we have one microservice. It's data exporter. That microservice is used for exporting data from our database for customers. For example, they want to export some cases, or they want to export some data. They can use this data exporter. Also, we have Liquibase that was mentioned in previous slide. That Liquibase is used for HANA upgrade. And what we also have, we have Hazelcast and RabbitMQ. So Hazelcast are also in the pods, in the deployments, and the Rabbit is a stateful set. I will speak more later about them and challenges and problems about them. So that's our application. On-prem, on virtual machines, we have similar setup, just instead of these applications and deployments are virtual machines. So you have, for example, 2 or 4 virtual machines for front-end Tomcats, and we have 2 virtual machines that acting like scheduled tasks. And in that case, you will see that we are losing our money, because here you don't have auto scaling, because we are in private cloud and we didn't have that possibility. And now with horizontal pod auto scaling, we have that kind of auto scaling, and we have that possibility to save some money and resources. When we are speaking about HANA is virtual machine on bot. So on Google Cloud, and also on-prem. We are using HANA as virtual machine because everybody we know that HANA and all database engines is not so good practice to have it on containers, but probably it will be changed soon, so we will see. So related to the challenges about this project, so first of all, when I got this task to run and spin up some POC and run SPM workflow to the cloud, I tried to run RabbitMQ in the pods, and for example, 2 pods, and to connect them in the cluster and to present it like a cluster to my pods. And that was the most challenging thing because when you don't have a knowledge about that, and when you are lack of documentation on the sites and running it in the pods, it was very challenging. And luckily I successfully did it, but I spent, I think, 2 months to run it, because you have some documentations, but it is not so accurate, it's not so up to date, and you can easily move on the bad track. So we run it in stateful sets with Kubernetes plugin enabled, and then you need to create some service entries things, destination rules, service accounts, role bindings to allow everything, and then to connect it. So you need to enable self joining in the cluster, and it was very problematic, but we did it. Next was the Hazelcast, same thing, but Hazelcast has that possibility automatically, let's say. But anyways, we found that some bug in our version of Hazelcast. I cannot remember the version, but it was a bug in the Hazelcast, and we needed to change one class, for example, for that, to be able to join in the cluster, and successfully we did it, but it was very tricky again. So next thing is, for example, email server. So we used locally installed postfix or something like that on virtual machines, but as you know, on Kubernetes it is not possible, and we needed to achieve that. We achieved that with SAP official mail server, but as a big company, we are very closed for sending emails outside and allowing that things, but with corresponding with other teams and with explaining situation, they allowed us, and it was very it is easy thing, but again it is complex thing when you say the procedures and things. So deploying strategy. So related to the deploying strategy, I already said that we needed to think about that and to implement it. And we tried with Helm, but Helm is also, we needed to change a lot of things, and then we decided to implement and configure ourselves application or deployment strategy. And we did it in Gradle, thanks to my colleagues from dev team that helped a lot for that. And now we can choose for every component. You can remember the block diagram of application. So every component on that block diagram you can deploy, or you can deploy everything, you can just only part, and we used potential of that Kubernetes things and Kubernetes solutions and everything, and we can deploy application very efficient. So zero downtime deployment. So we, as you know, Kubernetes had mechanism for that, but we needed to test that together with our application, because we have application when you broke the Tomcat, you need a session on Hazelcast, or you have it on Hazelcast already, and it needs to be stored there. And we had a lot of problems there for that, and we spent a lot of time for that, but successfully did it. But just mentioned that as a challenge, because we spent a lot of time on testing and things. Again, related to this is also graceful shutdown of the Tomcat. So when you want to upgrade application, when you want to new version of that application, you first of all you need to graceful shut down your Tomcat firstly, then to deploy new version of application. And we did it with exit point script, for example, and it is very interesting. Istio, so we had already on cluster Istio, but just as I said, SAP is very demanding related to the security, so we needed to create multiple namespace and spread our application in multiple namespaces, for example, and then to create a lot of service entries, egress tracking, ingress tracking, a lot of Istio side, let's say, things that we need to check. Related to the monitoring, we are using Dynatrace, for example, and Dynatrace is very powerful, and I can say very good words related to that. And also we had auto scaling. Related to the auto scaling, we just created horizontal pod auto scale, tracked the memory and CPU, and we tested it. And I thought that it will be very hard to maintain it and to configure it, but it was almost the easiest part of this project. So when we are speaking about the problems, so sticky sessions. So from on-prem, we had the sticky sessions, and these sticky sessions are for some features in our application and needed to be there, and we needed to implement it on Kubernetes also. And together with Istio, multiple namespaces, egress gateways, you can imagine how it was. But you don't have that possibility to change your application a lot, and then you need to keep some things on the cloud and to keep things as it is, and to find solutions. And sticky sessions was one of the challenging part and the problems that we needed to find solution for that. Just as I said, RabbitMQ pods in the cluster mode, it was very hard for me, but again, I learned a lot, and now it's very good. Again, Hazelcast, without my colleagues from dev team, we achieved that together. Change the class and change the things, rebuild some things, and then we successfully did it on the Kubernetes. Another part and another problem that we found is NFS. So on the on-prem, we are using NFS and mounting it for on the virtual machines, and we are using NFS for storing, for example, customer attachments, and we are using it for application logs. Okay, application logs you can move on another location, but with customer uploads, you don't need to lose them and things to delete them or something like that. And we needed to make it work on same way on Kubernetes. So we found solution for that in GCP file store service, and we presented it on the pods and mounted it on MNT, and then we are good. But then DR exercise came on the, you need to check, and you need to see if you have DR possibility for everything. And then we came with a problem that Google cannot move your files, or you don't have replication on from one zone to another, and then we needed to think about that and find solution for copying files from one zone to another, from one file store to another, to have some sync between zones and things. So that was the problem, and we resolved that with some pod which is syncing, and also Google promised that they will develop some service for replicating things. Maybe already they deployed, but we still don't know about that, and we will see what will happen in the future. And last but not least is collecting thread and heap dumps. So when you experience some problem, Tomcat has some problems with out of memory, or I don't know, heap space outage or something like that, you need to collect thread and heap dumps. And we did it again with exit point script. But if health check is good, then you don't need to do that. If you have health check down, then you need to do that because you have a problem. And we did that with that. So related to the future plans, so future plans is to remove sticky sessions because it was the problem, then we have a plan to migrate our customers to the Kubernetes. So we already have some customers, but these customers are new. It is not old customers that already on-prem. So probably this year will be a year of migration. So we will see how it will happen and what we will do. Then we need to implement Argo CD. Everybody knows how Argo is powerful and how it is working. And currently we have a Spinnaker and Jenkins deployment. It's deployment procedure, but our decision is to move to Argo CD, for example, again, to try to create Helm charts again with from our deployment procedure. And we will see what will happen for that. And also hand over deployments to the release management team. From this perspective, currently our team is deploying customer-facing environments on Kubernetes, and the release management team is deploying with Ansible on on-prem, on virtual machines. Future plan is to move that everything to release management teams because they are responsible for that. And I think that's it. Yeah, thank you for watching and listening. And
thank you very much, Marko. Very nice. I have here a lot of questions that I would like to present to you, but I will wait until the Q&A session. We will be with us, right?
Yeah, of course. I will be there. Yeah.
Thank you very much, man. It was a very good presentation. A
Thank
lot
you.
of information, a lot of doubts. I'm sure that everybody that's watching, they also have questions. So to anyone that's watching us right now, please do not hesitate to make your questions. Please write them down, and we will get back to Marko by the Q&A session later today.
Yeah.
Okay, Marko, thank you very much for your presentation. A lot of information, very heavy presentation, a lot of information, and we will speak later at the Q&A session.
Okay, thanks.
Okay, thank you very much, man.
Thank you.
See you later.
See ya.
Ciao. So our next presenter will be David Calvert. Calvert. How do I pronounce your name, David? Hello. I can't hear you. Just a second.
Yeah, sorry, I was muted. So yeah, just like you, like it's David Calvert, but
Calvert.
I'm fine with all the spellings.
Oh, you French?
I am.
Oh, très bon. Mon français, c'est pas bon, mais je parle un petit peu. So, David, thank you very much. Merci beaucoup for being here with us today to share your knowledge. So, David is he's a site reliability engineer at OQTON. OQTON is that how to pronounce? OQTON.
Octon.
Octon. Octon. Très bien. So, David, tell us a little bit about you, about your career. Where are you talking from right now? Where are you right now?
So I was planning to do that during the presentation, but sure. I live in the south of France. I'm working remotely from there. Octon is a company based in Belgium, and I'm mostly working on observability, security, performance aspects of like Kubernetes deployment and cloud platforms. So this is what I do. Previously, I mostly worked as a DevOps engineer and previously as a system administrator. So basically that's it.
So you are based in Belgium?
No. I'm working remotely from the south of France. Yes.
Oh, okay. All right. Do you have a presentation?
Yes. I'm gonna upload it right now.
Okay. So the topic that you were talking today, it's about Grafana dashboard design. Is that it?
Yes, exactly. So
very
my file is still processing.
Very nice. So how is to live in the south of France? It's not far from here, where I am right now.
So yeah, I think it's there. So I think yeah.
So I will leave you with your presentation, David. Thank you very much. We'll talk later.
Yeah.
Okay.
See you after.
See you after. Bye.
So hi everyone. Today I'm gonna talk about modern Grafana dashboard design. So. Well, like I just said, so I'm a site reliability engineer at Octon. I've been working on observability, reliability, and security aspects of Kubernetes and cloud platforms for quite some time. If you're interested in what I do, you can find me at those various places. So today I'm gonna start with some basic generalities around Grafana dashboard design. Then I'm gonna speak a little bit about a few Grafana features and especially visualization that you can use in your dashboard. And I also speak about a few user experience consideration you should think when you design your dashboards. And lastly, a few resources you can use to learn additional stuff. So I'm going to start with some basic stuff. So a good dashboard should have a purpose. So it sounds very basic, but it's really important to keep in mind that when you design the dashboard, it needs to have a defined goal. It must not be just a collection of data, metrics, without any goal. So it's really important to have this goal in mind when you design the dashboard. And stick to that. And if you have various goals, it's best to divide them into several dashboards depending on the use case. A dashboard should also be user-friendly, so it should be easy to use, straightforward, so easy access to the information we want, relevant, so the information we want must be relevant, and ideally it's configurable. So Grafana dashboard can use templates and variables, so you can basically show the different kinds of information based on different inputs, data sources, like configuration of metrics and data, and you should take advantage of that instead of reusing the same panels over and over. Just copy paste them, just template them, and reuse only one. Another thing that is really important is, as we're going to see later, I'm going to show a lot of different fancy visualization panels, but most of them would sacrifice the time in the visualization part. So time is really important when we analyze data. So keep this in mind, that if you use a representation, like for example here we see two panels that represent the same thing but not with the same form. So on the left we only see the global CPU usage at the time, at the current time, but you don't see the historical data. And on the right, you see that the first one, on the second one, we see a spike that we cannot see in the first one. So this is why each time you use a panel that would hide the time dimension, you need to also add a panel that will show it, because it's really important to see the evolution in time. So there is also a way to organize your dashboard. So depending on what you want to do, there's going to be several dashboards, or because sometimes you want to see things from higher up. Some things you need to dig into more detail, or really detailed component-specific information, and you need to organize your folders and dashboard accordingly to make it easy for everyone to find the information. Ideally, they should work with one another. For example, later I'm going to speak about a Grafana dashboard project I made for Kubernetes, and there is like different kind of views, and you can switch from one to the other with links depending on how deep you want to go to find the data you need at the moment. So I'm going to now speak about a few Grafana features. So the first one is the time series visualization panel. So if you have a look at grafana.com, if you go to the dashboard page, where there is a lot of community dashboards where you can download them. Most of them are pretty old and still use the old graph visualization panel. If you make a new dashboard now, it should be the default. But if you have like old dashboards, you have an option to switch to that new visualization panel that includes a lot of new stuff. Gradient mode, fill opacity, connect null values, so you don't have gaps in your graphs. So on each visualization panel, I show you the link to the documentation, so you can go have a look. So, for example, the time series includes now a gradient mode, which enable you to use it in different kinds of way. So here I have two examples. One is you can use gradient mode to show the hot points in your graphs. So, for example, here we see on the top right that the data is in red because it's the highest value, and on the top on the lower left, it's green because it's the lowest value. If you open a graph, it will instantly show up like the come to your eyes what's the highest point and what's the lowest point, which can be really easy to get access to the information quickly. And another example is that on the right here, you can use the gradient mode to comply with some steps. So, for example, if you have a few thresholds, so here it's temperature. So the consideration here is that below 20 degrees, we consider it's cold. So this is represented by the green color. Between 20 degrees and 30 degrees, we'd say it's cool temperature. So it's like warm, and it's represented by the orange color. And anything higher than 30 degrees, it's considered hot. So we can clearly see when the temperature was low and high over time. So this can be really handy to represent those kinds of things. There is also many other visualization panels, so they are probably less used and less known too. But depending on what you are trying to do, it could be really interesting. So the status history visualization panel can be used to, if you have a state change that is going to change over time, it's really handy to use that, because you instantly see the compliancy of or the state of a particular metric in time using those small boxes. So like it's like a matrix basically. And there's also the status timeline, which is pretty similar, but that will be more like a timeline format. So the box would be merged together. So you have only one block until the state change. If you use histograms, the Grafana team just, it's been quite some time now, but they've revisited the heat map panel to take advantage of their new sparse histograms from Prometheus. So they've like completely rebuilt it. So if you use histogram, you should definitely have a look and maybe use the new one. If you want to learn more about sparse histograms, I've also added the link of the Google Sheet from the project. It's been, this is kind of an old feature now, but not very projects are using it. Even myself, I don't use it a lot. But you can now do fancy stuff using tables. Like depending on the values, you can like color the text, the background, or even using gradient gauge directly included in the tables. So depending on what you do, this can be a really fancy feature to add to your table visualization panel. There's actually a lot of stuff you can do with tables. So if you need to represent data this way, definitely go look to the documentation. It's really, really huge. One thing that is been around for quite some time, but not used that often, I saw, is that you can use data links directly. You can build data links directly from the output of your queries. So, for example, this is a dashboard I've made for to detect CVEs from trivial operator on a Kubernetes cluster, and there is an option which is which will export the CVE names as a Prometheus label. But it's really it will probably have cardinality issues on bigger deployments, but it was just to test. And I wanted to have the link to the CVE itself. So I've built the URL using the CVE ID here. And when I clicked on the data from the table here, it will directly go to the CVE with the description and all the information I need to comply or to treat the problem. So you can build links to internally or externally. It's up to you, but it can be really handy in some cases. For example, I use it internally in my dashboards to move from one dashboard to another with some data. So yeah, keep in mind that you can do that, and it can really help like with the investigation flow. So it's a really good feature. There's also, so most of what I do would use metrics from Prometheus, but there is also many other data sources you can use, log, traces, or other even completely different data sources. Keep in mind that you can mix and match now pretty easily in Grafana dashboard, so don't hesitate to do if that's relevant in your use case. Lastly, so a few days or weeks ago, Grafana shared the Canva feature in Grafana 9.3. So we don't see it here, but it's a really fancy new visualization panel that it's dynamic. So it will like the thing can rotate. You can see the flows of the electricity here. So I didn't have time to have a look. And I don't think I'm going to need it a lot, but it's depending on what you're trying to do, it can be a really fancy way to show data, especially if you have if you have a dashboard mounted on TV or stuff like that on the wall, like it's constantly available. It can be a really good visualization style to do that. So yeah, it just came out, and you also have the link to the Grafana discussion from the GitHub project where they are discussing this feature, because it's being actively developed right now. So maybe you should have a look. Okay, so now about user experience. So like I said earlier, dashboard should be easy to use and straightforward. To do so, it's best to respect the natural eye movement. So most countries would have this flow, but could be different in a few countries. But mostly you want to stick with this flow of information because it's the natural way. If you force it, you can catch the attention, but once you catch the attention of the user, he wouldn't know what to do after that. So he don't know if he need to go left, up, back to the beginning. So yeah, to not disturb the users, it's best to stick with the natural way of reading the information. Sounds obvious, but yeah, important to deal with that. Also, a few other considerations about user experience is the performance. So if your dashboard or general Grafana setup is slow, users would be affected. So if you have a huge amount of information, you can create rows in your dashboards and you can fold them. So for example, you can create rows, have the first ones open and fold the other ones. That way, each time the dashboard gets refreshed, it would not query the data of the folded rows, which can highly reduce the refresh time of the dashboard, especially the bigger ones. What you can do also is do not enable auto refresh by default. So if someone needs to investigate and have updates on the data, they would, it's one button away, and they would probably know how to refresh pretty easily because it's really easy access. You can really access the button really easily. Same for the default time picker. So the more time frame you select, the more time it will get to be queried. So by default, depending on the use case, keep the things as short as possible. If someone needs to look for the last 24 hours, the last week, months, or anything bigger, they would, as in the same manner, we really easily could change that. So yeah, by default, keep things as small as possible. And also, if you have really complex queries, so I'm mostly using PromQL, but it should also apply to other data sources. If you have really complex queries that you query a lot, you should definitely make new series using recording rules. So this is for Prometheus, but like I said, I think it should apply to other backends. And if you need to query big time ranges, for example, if you have years of data, you should be able to. You should have a look at downsampling technologies. So in my case, I use Prometheus. So Thanos offers a service like that. So it allows to reduce the data sample and accelerate, like speed up the query times when we query a broader time range. So it's really important for the user experience to have the data and not make them wait too long to access the data. So I don't apply this myself because I don't have any Daltonian or color blindness suffering people in my team, but maybe you do. So you should ask your user if any has color blindness problems, because if they do, you should definitely try to pick a color scheme that would that would make their life easier. So yeah, think about that. If you have any one of your user, I think they are greatly appreciated. And finally, the resources. So this presentation was inspired by what I did. So I've made a project of a Kubernetes dashboards. Because the community ones was not as I'd like, and also most of them were pretty old and some parts were broken back in the days. And I decided to create my own project, and I later decided to show it to the world. So I created the .dc/Grafana dashboard Kubernetes on GitHub. And I recently, last year, I've made an article why I created it, what kind of technical choice I've made, and also why I started to catch up with the latest Grafana features to make the things better without sacrificing usability. So the goal is not to make a super fancy dashboard with a lot of visuals, but to keep them pretty usable and take advantage of the new features when they are relevant to my use case. So here's one example. So as you can see, I'm taking advantage of the gauge panels to quickly have an overview of the load of the resource usage of my Kubernetes clusters. So it's pretty clear, but like I don't have the time dimension here. So each time I use these kinds of relation, or here like a static metrics, I will always have one that shows the evolution in time either next to it or underneath. So because time is really important, you really want to track the evolution of that. And the second example is the pod view. So I use this dashboard to size my pod, and I consider that anything below 20% or higher than 80% is either too much resource or not enough. So I use this dashboard with a background using a color scheme. And everything that's in the green area I consider good. Everything in the yellow area I consider that could be okay, but maybe need to check it from time to time. And anything, like I said, below 20% or 80%, I consider that either I have allocated too much resource to my pod or not enough. And in this case, I need to make change accordingly. So this is an example of how you can use color scheme as a background to comply, and the graph line itself would take the actual color of the data. If you want to learn more or have access to more resource to make good Grafana dashboards, you should definitely have a look at this Grafana webinar, which is called Getting Started with Grafana Dashboard Design. So it's really good video to watch. You can also go to the Grafana blog. They often make articles on features, use case, either from Grafana directly or from the community. So there's a lot of resource there you can use. If you want to test things, you can have a look at Play Grafana, which is a sample Grafana instances where Grafana showcase basically all the feature mentioned there and even a lot more. And every year there is the Grafana Con where they prepare the release for the new Grafana version and also announce all the working progress and what have been done during the year. So yeah, if you like, you can also attend the Grafana Con. It's a really nice conference if you work with Grafana. So that's about it. If you have any questions or comments, feel free to join me in the Q&A session. I'll be there in, I assume, a few minutes. So yeah, that's it. I hope you enjoyed the presentation. And yeah, see you later.
Merci beaucoup, David. Merci beaucoup. Very nice presentation. Well, as we should start the next presentation. I hope you'll be with us in around 20 minutes. I think it's time enough to.
Sure. I think I received a time change, so I think now it's planned in 5 minutes.
Oh, I'm sorry.
But maybe it's not. No, no.
I didn't get this announcement. Hi, Lilia. Would you please join us a little bit? Just a second.
Yeah, hi everyone. Hello, David. Nice to hear you today and see you. So yeah, we have a bit misunderstanding with our timeline because one of our speakers who should be present today unfortunately couldn't, and that's why our timeline is not we're not exactly in time, but for sure we will have a next session now, and after that session it will be recording from next speakers during 16 minutes, and we will have general Q&A session with you and other two speakers. So I will please you to stay here on the background, and we will continue with next speaker.
Okay, thank you.
Thank you.
Okay, Leila, thank you very much.
Thank you, Gustavo. Let's start with next speaker. You could
introduce him.
Introduce him, yes, and I will start recording.
Okay. So thank you all again, David. See you later.
See you later.
So, guys, our next presenter, this is a recording section that we will hear now, we watch now. It's the Shubham Srivastava. He is head of dev relations at ZenDuty. And he will talk about monitoring Kubernetes the right way. Let's see here.
And welcome to my talk about monitoring Kubernetes and choosing the right metrics for incident alerting. I hope you're having a good time at the conference so far and that you take away something valuable from my talk as well. A quick introduction to break the ice. Hi, I'm Shubham. I'm a developer relations engineer at ZenDuty. We're an advanced incident management and response orchestration platform, and I call myself an expert at making mistakes, learning from them, more importantly, and advocating for best practices for orgs setting up their DevOps, SRE, and production engineering teams. So the burning question, what is this talk about? So we'll start by introducing the right metrics you should be monitoring in Alert Manager. We'll play around with some metric algebra to formulate some statistics that should matter to you personally. We'll then move on to learning from mistakes made by veterans in industry. So it'll definitely be a quick primer on what to do and what not to do. We'll briefly touch on anomaly detection and whether your system could benefit from proactive alerting. And finally, the kicker, which is bad monitoring costing you, and should you care about it? So building an efficient and battle-tested monitoring platform, it takes some time. You need to burn your fingers before you really get a lay of the land. You need to learn the ropes before you build a monitoring system that's worth anything. But there are a few things that you can keep in mind on day one. And firstly, your alerts should be based on impactful systems. You shouldn't be getting alerts in the middle of the night about things that don't have a business impact at all. If an unexpected value in a metric doesn't have any appreciable impact, it shouldn't be an alert at all. You can check those values later. You can generate maintenance tasks, but really don't wake anybody up in the middle of the night. Your alert should be actionable. Nobody wants to get woken up and just completely dazed, look at an alert and unsure of what they should be doing at all. So make sure that your alerts are about something that an L1 or L0 engineer could do something. And finally, your alerts should be concise, accurate, and minimal. Simple as that. So this is a quick field trip back to grade school for a few of you guys, but let's touch base with some basics for the sake of continuity. So SLAs are the agreements you make with your clients or users. SLOs are the objectives your team must meet to hit that agreement, and SLIs are the real raw numbers of your performance. So I bring this up because we'll be building alerts to measure your SLIs, which track the SLOs that are a part of your SLAs with your customers. Quite a mouthful, but yeah. So a quick fact, the current published target for the Google Compute Engine's availability, that's GCP, is 3.5 nines. That is 99.95% of the times. An example to really nail it in is the SLO error rate for an API is 1%, which is 99%. The owners of the API will get paged if their backend has returned more than 1% responses over their monitoring window. So proper monitoring allows you to monitor your error budgets and know when the system requires more attention. So this is something that a few of you would be familiar with. This is what SLO monitoring with Grafana looks like. You can see your availability over 30 days, remaining error budgets, and descriptive graphs on when and for how long an SLO was breached. This must be familiar to a few of you. I was once told by a colleague of mine that Prometheus can be too prompt for its own good. If you don't rein it in, you're going to have a dedicated Slack channel full of hundreds of alerts every couple of days. And now to the meat of the talk, learning from mistakes. We'll be going through some existing monitoring and alarm set by companies in production, what they're missing out on, and we'll have some fun with algebra. So the first biggest mistake you could do is not alerting at all. Again, a no-brainer, but we got to start somewhere, right? Not setting up any alerts is a complete blunder, and you have no idea how many companies are really still having like two shifts, two teams looking at graphs and dashboards all day long. That's just a no-no. Secondly, not enough alerts. They say that half knowledge is fatal, right? Well, so is setting an inadequate number of alerts. This could lead to situations where you're doing guesswork based on improper assumptions, and the business impact over there is just increasingly incremental. And finally, not setting the right alerts. So this could be setting up excessive alerts, mislabeled alerts, and this could lead to noise, alert fatigue, and then you're eventually going to miss out on the alerts that really need your attention. So firstly, we have Nginx too many 400s. So what is this alarm? It tells you the number of 4xx requests that are received in 1 minute and fires a notification when more than 60% of all requests are 4xx. What's right about this alarm configuration? Well, keeping a track of 4xx in the first place is a welcome behavior, and it only generates warnings if you can look at the severity over there. So that is something that an engineering team would really appreciate. But what's wrong about this alarm configuration is that it is also counting HTTP 429 requests, that is the requests that are falling outside of the rate limit. So if we had to correct this, we would simply change the equation to disregard the requests outside the rate limit. So, and that's as simple as it can be. Just remove all the requests that are falling out of the rate limit. So many companies still do this and they just roll with it because it's been how things have gone on forever. And after this update, we found out that the noise to signal ratio for this particular alarm was around 18 to 82%. So that is only 18% of the alerts were legitimate. And like even if I were to stop my presentation right here, you would have immediately already gotten some value. And now host context switching. So this alarm monitors the number of times your node switched context in a period of 5 minutes, and it fires notifications when the figure exceeded 5,000. So the suggestion is, if this property is too high, you should switch to a RAM optimized instance instead, and just don't keep this configuration longer. In fact, context switching is not recommended for mature products at all. It's only for teams still in R&D phases, establishing their benchmarks. So if your performance is on par with your usual benchmark constantly, you can run this much less, like around instead of 5 minutes, maybe like 30 minutes. And if you don't monitor this metric at all, and if you really need this, you won't know why your systems are choked up. HP at max capacity, something a lot of you would be familiar with. What is this alarm? It fires notifications when the answer to maximum possible replicas minus current replicas is 0. So what's right about this alarm configuration? Well, surprise, almost nothing. Because what's wrong about it is that when the alert will be triggered, the HPA would already be at max capacity. The result is 0, right? So it delivers alerts too late for you to do anything. The butler has already killed the estate owner, and you cannot avoid an incident at this point of time. So a basic correction to this would be getting alerted when you're at 80% of your capacity. And after this update, Alert Manager will trigger an alert when you're at 80%, and you will have some time to scale effectively, or at least diagnose by this spike. HPA scaling limited. So what this alarm does is it notifies the team when the number of pods decrease below a certain threshold. This isn't a very common one, but some product teams have setups that run a risk of a pod shutting down physically. And this can act as a grace for them and when there's a failure like that. What's wrong about this is that it will fire alerts when the pod is at minimum threshold as well, and will be a constant source of noise for well-scaled systems. So we'll look now at some more examples on what to do. So firstly, we have Prometheus replica down. So if your replicas are below certain limits, or maybe they're about to idle, you need to get alerted and understand why that would happen. This is very similar to the previous examples where we were getting an unexpectedly high load and we were nearing the maximum capacity. In both these cases, you should get prompt alerts so you can modify or understand the scale. This is a no-brainer one, but sometimes it may happen that your Prometheus is not connected to the alert manager any longer. We've seen this happen when there were some name changes or some configuration file errors, and it's a pretty basic alarm that helps you save some embarrassment down the lane. Container CPU usage is very similar to the HPA scaling examples that we looked at earlier. Very similarly, you can track container CPU usage with some reasonable thresholds based on your benchmarks and approximate response times. So sometimes it may happen that we are relying on automation so much with auto restarts, but we forget to track them. And this is a basic alarm which is missed sometimes, but could surely help you correlate some service delays or changes with other issues. So this one detects when an unsupported node is attached to your cluster. So this could lead to situations where your structure might not work as intended, and it is hard to diagnose without an alarm like the above. So this is a pretty basic one about out of memory, where your pods are killed due to out of memory issues. Nginx too many 500s. This detects when there are too many requests being returned with a 5x6 response code. It can help correlate some system or code changes to drop requests. This is a friendly reminder that your engineer should also keep tabs on the Nginx configurations or network interface reaching its capacity levels. We recommend that you track what your Prometheus is scraping because if it goes out of memory, your Prometheus instance can go down or at least frequently restart, and that will cause a lot of delay in alerting. Obviously, we recommend that your team be monitoring P50, P90, and P99 latencies, have benchmarks set, and trigger alarms whenever there's a larger than expected deviation from the average response time. So this allows your team to correlate an increase in latency with external causes like some system changes, new feature pushes, marketing campaigns causing an increase in traffic. So now we move on to something a little more advanced, and that is being proactive with Prometheus alerting and putting some light on anomaly detection. We stumbled upon some really good research by some amazing folks at GitLab and decided to give it a swing ourselves. So the following serves as a kind of case study of our implementation of anomaly detection. So why is anomaly detection useful at all? Firstly, diagnosing incidents. You can lower the average amount of time it takes to discover an incident by immediately identifying which services are operating outside of the regular bounds. Detecting application performance regression. So if an n+1 regression is introduced and it leads to another service being called at a very high rate, you can quickly track down the issue and resolve it. Identify and resolve abuse. You can get credit from a small subset of users who might try to take advantage of your free services. And most importantly, security. Anomaly detection is very essential to spotting unusual trends. Now let's look at Z-score. So some of the primary principles of statistics can be applied to detecting anomalies with Prometheus. But first, the time series data must be aggregated correctly. Here we use a standard counter of total HTTP requests as a data source for this demonstration, although many other metrics can be applied using the same techniques. So the Z-score is measured in the number of standard deviations from the mean. So a Z-score of 0 would mean the Z-score is identical to the mean in an aggregate time series dataset. So now that we're assuming the underlying data has a normal distribution, 99.7% of the samples should have a Z-score between 0 to 3. And the further your score is away from 0, the less likely it is to exist. And this pretty much lays a base on to your anomaly detection foundation. So how do we calculate Z-score? Firstly, we calculate the average and standard deviation for the metric, which is HTTP total requests, using data with a large sample size. And for this example, we're using 1 day's worth of data. So we find the long-term average value with the below expression over a period of 1 day, and the long-term standard deviation with the below expression again for a period of 1 day. And once we have the result for both of these, we can calculate the Z-score for the Prometheus query with the below expression. Once we have all of this, we are here to presume that any result that is outside of the range of +5 to -5 is an anomaly based on the statistical principles of normal distribution. So with this, we've laid the starting brick of proactive alerting, and we are making the assumption that the underlying aggregation has a normal distribution. And there are some metrics that don't have normal distributions easily, including things like error rates, latencies, queue lengths, etc. And for those things, I would suggest that you look at the GitLab blog from 2019, which also covers seasonality. They've done a pretty good job of summarizing both of these things pretty perfectly. But why correct our math at all? Why do so much for just a few missed alerts here and there? Except some hassle to a few employees, it's not costing us anything, right? Well, you're wrong, and now we're going to find out how much is bad monitoring actually costing you. So this is going to be a list of conservative estimates. So we're not counting storage costs, VPN costs, cloud add-on costs, and so many other vendor costs. So the final figure could be much higher for you depending on your organization. Well, the bandwidth cost per GB per NAT is around $0.045. The NATs required for a minimum of 2 regions, we're assuming you have that, is around 6. We're assuming there's a 500 employee org with 70 people in the umbrella for senior engineering, DevOps, and SRE. So again, from that, only 30 people are monitoring this data, and they're consuming around 20 GB of monitoring bandwidth every day. When you crunch all of these numbers up for a period of 1 year, you get a figure that's close to 60 grand. And that's higher than the total compensation for some engineers in a lot of parts of the world. How much can you save with proper alerting? And with well-configured alerting and metric monitoring, not only is your Prometheus scraping and storing only relevant data, but your team is much freer to spend much lesser time manually monitoring your performance and rely on intelligently set reliable alerts to let them know when something is wrong. And we found out that according to our data, on average, a team can save up to 35 to 45% of the previously calculated expenditure with the right metrics and alerts. And great, we will now be generating only alerts that require attention. But how do we approach incident management here for cleaner resolution? A good alerting structure is definitely a must for quick resolution, but make sure that you don't lose the war against time during firefights due to human errors or miscommunications, which are plenty during times of stress. Assess whether your organization could benefit from a better incident response tooling to keep responders on the same page, harness context-rich data from your observability plane, and enable teams to jump back from issues as fast as they can. And that's all my time. Thanks a lot for tuning in, and I hope you're taking away something valuable from the session. Feel free to reach out to me on Twitter or LinkedIn in case you have any questions, and have a great day ahead.
Hello, guys. Hello, Lilia.
Yes, so thank you to our previous speaker, and I invite everyone to Q&A session. Let's welcome David. Hello. Gustavo, you could continue with Q&A session, and I will check our chat. Probably we have additional questions also.
Sure, Lilian, no problem. Hello, guys. Hello, David. Hello, Shubham.
Hello, hello.
Hello.
Is that how I should pronounce your name, Shubham?
Yeah, that's pretty good.
Hello, Marko.
Hello.
Thank you very much for joining us for this Q&A session. Let's see what questions do we have here. So let me read the first question here. Question is to anyone as well that using the tools. Let's show the question. Question is to anyone as well that using the tools. Have you ever used Thanos as data source to aggregate metrics between S3 bucket and Prometheus? Did you notice slow performance on PromQL queries? Who would like to answer that?
Actually, I didn't use Thanos. I used S3 and Prometheus, but I didn't use Thanos, so I cannot answer about the performance degradation. Sorry for that, but...
Anyone else?
So I've used Thanos, but very few. I've just started a new job where I have a Thanos deployment to learn, so I will probably be able to respond to that maybe in the future, but not now. So what I know from Thanos is that you have a service which is a querier that you go through to query some data, both on either on the sidecar of next to Prometheus, or on the S3 storage, depending on the query you make. So I assume maybe you can tune the querier or maybe scale it to increase the performance. I know that there is also a way to shard the request. So I've never encountered like this kind of these scales. So I never had the problem. In my previous company, we didn't need it Thanos. So yeah, but I would definitely have a look to the querier configuration, and if not, just ask on the Thanos community. They will probably have a Slack channel somewhere, or make a GitHub issue to talk with the team. I'm sure that they are pretty aware of those kinds of stuff.
Okay, David. Thank you very much. Would you like to add anything? Shubham? Nope.
No, I think that's pretty much it, yeah.
Okay, thank you. Let's see the next one. Thank you for the presentation. About Istio, what are, for you, the key features that everyone who uses must embrace? And what are the challenges and learning lessons you embrace during the usage of Istio?
Yeah, so from my perspective, the most interesting is, for example, certificate manager together with Let's Encrypt, and that's constantly renewing certificates, for example. Also, virtual services are very interesting because you can do whatever you want with virtual services. So redirecting, routing, things like that. So everything in Istio is interesting, but it's very complex, and also achieving sticky sessions from my presentation, it was very, very interesting because you need to use virtual services, destination rules, service entries, a lot of things to achieve that. So
Okay. Thank you, Marco. Do you guys would like to add anything? Shubham, David? Nope.
So I've never used Istio in production because I never needed it, but I've used it to investigate an existing deployment, and it's Istio comes with Kiali, which can be visualize your deployments. And if you don't know, or if you need to analyze how the different microservices communicate together, it can really handy to map and get the flows of data between each microservice. So even if you don't want to run Istio in production, you could like do it on a dev cluster to just learn from how your service communicates. It's really good, actually.
yeah, I can agree about that because Kali is you can visualize complete your Istio network. Also, if you have some errors in your configuration, it can show you easily. It's very powerful and very good. Yeah.
Yeah, I think they made effort on Istio side, but I think it still costs quite some money. So it would add compute and memory usage to your cluster. So Istio is far from free. So keep this in mind also.
Oh, I thought that was open source. It's not open source.
No, the project is open source, but the additional cost on resource usage is not.
Oh, I see.
That's what I meant.
Yeah, I understand. Okay, guys. The next one, I think it's for David. Hello, David. How do you deal with the backups of your dashboards? Who is in charge of the management of this tool, yourself or an ops team?
So we don't do dashboards. We don't do backups of our dashboards because we provide dashboard as a code to our Grafana instances. Actually, nothing in Grafana is. We don't even have. I don't even know if we have a physical volume behind. Maybe just for snapshots, but we don't intend to track to keep the data on Grafana. We just provide that as a code, and it's the SRE team who is responsible for all the observability stack. So yeah, we just commit them to a Git repository. So you have several ways to do that. You can provision dashboard using Terraform, using customize flat dashboard, the API. I mean, you have what's best for you. You can provide that as code.
Okay, thank you, David. Let's see the next one here. Marko, is thing storage better for customer data than NFS storage?
So it is, but the problem is that you cannot mount it on the multiple pods. Or multiple Kubernetes node. So if you have read write many policy. For example, you cannot you cannot achieve that with that. So that's the problematic.
Okay. Would you like to add anything, David? Shubham? Nope. All right. Next one. It's for Shubham. Shubham, as a starting DevOps team, can we carry on mutation without Kubernetes and content ourselves with Docker Swarm?
Again, I think we circle back to the same thing that you can use Docker Swarm for small scale. You do not need to rush into adopting Kubernetes and prepare for scale that you are not expecting right now. It's the age-old question that every DevOps engineer sometimes has to answer. So yeah, Docker Swarm is perfect for a small scale.
Okay. Let's see the next one. What are the services that a node gives and its responsibilities? What are the services that a node gives and its responsibilities? Kind of a broad question.
I cannot understand it. So if we can get some.
I'm not sure.
Yeah, well, trying to give a clue, I think a node can actually do anything you want, right? That's something that it's in your architecture. So I don't know. It needs to be more specified. I don't know if you could give me more details to us to understand better. So maybe we can answer a question. Whoever made this question. The next one, what is the namespace? How many namespaces are there in Kubernetes?
Yeah, so namespace is a logical thing in the Kubernetes, so you can isolate your workloads. How to explain? So, for example, let's imagine that you have a whole cluster, and then you want to bring up multiple applications there. You can create namespace for one application and second namespace for another, and you can have, for example, DMZ namespace for some network resources, and then these namespaces can be isolated, and also you can communicate between them, and you don't need to communicate if you want. So you can do whatever you want, but it's logically separation of resources. And also in one namespace, you can bring, for example, some workload with name up1, and you can do the same in different namespace, again up1, and they cannot collate with themselves, between themselves, for example.
Yeah, I've seen a lot of people use it, especially for RBAC purposes. So it just adds another layer of separation that bigger teams enjoy.
Yeah. And I don't know the number of namespaces, how many you can create
I think
in the cluster, but
probably more than you need.
Yeah.
Yeah, for sure.
Yeah, very, very nice answer. Probably more than you need. You never need like more than 1,000. So the next one, why do we need container orchestration in Kubernetes?
Kubernetes is about container orchestration in the first place, so it's the purpose of Kubernetes itself. So I'm not sure what's the question.
So, for example, let's imagine that you have a cluster with 10 virtual machines, and it forms Kubernetes cluster. So you need something that can move these pods, deployments, workloads, whatever, containers between these nodes. And that's the purpose of Kubernetes. So you need something who can manage all these containers and on the same time to look on the resources on these nodes and to take care of that these containers can be online anytime, you know. So that's the Kubernetes job.
Okay. So I have let's see here. What specific steps do you take to ensure the security and compliance of your systems, and how do you stay up to date with the latest security threats and best practices? This is yeah. Go ahead, Marko.
So it is very good question. So we have a team for that. It's called the InfoSec team, and you know, there's the boring guys who always had something to say and something to complain related to the security and things. So we are getting always requests from them what to do, how to do. Also, we have some automation tests during the build process, and also image Docker image checks, scanning, and a lot of other things. Also, we have a policies in the SAP who prevent you to use any malicious software or something that is not 100% free or is not paid. So, for example, that's the things that it is taken care by other teams, but again, we need to collaborate with them. So the most, for example, network securities, also we have team for that, and they are bringing to us policies that we need to follow, and we cannot do on ourselves. Again, we need to follow the best practices, for example, 12-factor, and we need to work together to deliver the most secure and the best practice solutions for that.
That's especially true for a company of that size that can afford an InfoSec team. But if you're a small company of like 10, 20 employees, you just have to subscribe to a lot of feeds that update you about any impactful incidents that affect you. So there's one the one called Full Disclosure by Seclists. I'm not sure if I'm saying it right. Full Disclosure is what it's called. You can Google it. And they are very prompt. In fact, we were affected by an Atlassian security incident earlier this year, and we got to know that within a few minutes of the CV being released. So if you're a smaller team, it's kind of hands-on. You cannot rely on a lot of people. You just have to be in the game.
Yeah, so to add on what has already been said, so yeah, the strategy would highly depend on the scale of your company. So big companies would probably have a dedicated security team who would work on that. But on smaller team, you can still find a strategy that works well. Most of it would be for the compliance part. There is a lot of tools out there in the open source, like for the Kubernetes world, you have like Trivi, which will basically run a lot of security benchmarks and best practice around your infrastructure as code. So you can use that to follow best practices and make the good design choice for the security level you want. And also, so if depending on how many workloads you have, you want to make sure you have a build system that would automatically deploy and automatically build your application using security patches. So if you use something like, I don't know, Argo CD or Flux, you can use a wildcard on the SemVer to automatically deploy security patch. So if you're a smaller team, you you would maybe more inclined to use those kinds of features. More bigger companies would be afraid to do that because they want to validate every version, stuff like that. But yeah, I mean, really depend on the scale. You are Gustavo. I think you are muted.
I'm sorry. Let's take the next question. Marko, do you use Kubernetes operators? What is your opinion for production?
So, related to this question, I'm not sure what means for this, because have in mind that I'm not maintaining the clusters, so I'm not sure and if I can answer on this question. So I cannot say. Maybe somebody of you, yeah.
I can take it. So I use Kubernetes operator on my cluster. I've used a bunch of them. It would so about the opinion to run them on production. It highly depends on the operator itself. So, for example, the Grafana operator, the Prometheus operator is safe to use in production. But I think there is a website that lists them all with the features, the feature implemented in each of them, and also the how much time they've been around. So, I mean, it really depends on what you want to do. If it's a well-known operator made by an organization, an open source group, or a company you trust, then you can safely go with it. If it's an operator with very few updates made by some random person, yeah, maybe not.
Okay. Thank you very much, David. Another question here. If an application contains many services, it is perhaps a good idea to separate them by namespaces. For example, front-end namespace, back-end, and operator. Would you like to answer that?
So,
nope.
So you can add you can separate it like that, but I think that the best practice is to have one application in one namespace, and also you can put again multiple applications in one namespace or in different namespaces. It's just depends of your decision how you want to separate your application. But have in mind that if you have, for example, Istio and a lot of security policies, like we said previously, you can experience some let's say network issues or problems that you need, for example, for every microservice that is exposed by Kubernetes service, you need to put, for example, to create service entry for that. And you can imagine if you have, for example, 30 or 100 microservices in your application, how many service entries you need to create between all of these namespaces to communicate it between all of them, for example. So you need to think about that, and you need to design system very good. I can say that you can separate between namespaces, but you need to see what you will get and the best possible solution from that.
Yeah, I agree with Marko here, and I think the best reason to use namespaces is when you really want isolation for resources, for security purposes. In this case, I wouldn't say that's warranted. You can make it work, but that's not the right way to go with it.
Okay, guys, thank you very much. I have one last question here. Also, how do you balance the need for speed and agility with maintaining a stable and secure infrastructure? would like to answer that?
So again, it depends of scale of your company. So it's related to previous question again. So from my opinion, if you have a big company, you can take care of everything because you have multiple teams dedicated for multiple things. And from my perspective, it's very easy. But if you have small company and if you have multiple things to do, it can be very complicated. So question is very, very tricky from that side. So
Yeah. Also, the definition of stable and secure changes with your scale. So if you're in a smaller company like us, maybe in a few hours of testing, you're like, you know what, that's good to go. Let's just push it. And but if you're in a bigger company, you're gonna need multiple rounds of testing, going through multiple teams. So yeah, definitely depends on scale.
Yeah.
Okay, everybody, it was on mute again. Yeah, well, okay, guys, thank you very much. Marko, Shubham, David, thank you very much for your time to be with us today. Well, there's another question here. That's the last one. On the last time. What is the best practice about using server entry CRD? One per namespace or something else?
So what is the best practice about using service entry customer resource definitions? One per namespace or something else? So I think that it's not good understood our explanation related to that. So for example, you have one namespace and second one with multiple resources. So if you want from first one to access multiple resources in the second namespace, you need to have for every resource in second namespace, you need to create for one service entry to be able to access it. So just as we agree about that, it is isolation. It is better to make isolation into one namespace and put, for example, one application into one namespace and second in another and things like that. So it's not so good idea to have spread between namespaces.
Okay, Marko, would you like to add anything, guys? That's it. Okay, so may we finish? There's another final question. Nope. Okay. Thank you very much, Marko, Shubham, David. Thank you very much for your time. It was very valuable. A lot of issues that for sure will help many of the newbies that are coming to the DevOps activities. Thank you very much, guys.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.
Good day, everyone. Bye-bye.
Bye-bye. So, guys, we are...
Yes.
Hi, Lilian.
Yes, we will have a short break for 3 minutes now, and we will continue for our next speaker, Gabriel. I want to say thank you to everyone and thank you to all the speakers. It was a pleasure to have you today, and let's have a short break, and we will continue with Gabriel. It's just for I think 3 or 4 minutes, okay?
Okay.
Thank
See you guys. Ciao.
Okay, hi, hello everyone. We are ready to continue with our next blog and next speaker. And I'm happy to introduce Gabriel. Hello.
Hello. Hi,
Nice
everyone.
to see you today. Nice to meet you, Gabriel. So Gabriel is director of DevRel in a Pyramid EO. And today he will talk about GitOps as a future, Streamlining infrastructure management. So I'm happy to see you today, and you could continue. The stage is yours.
Thank you. So, hello, everyone. Usually when I'm doing virtual talks, I like to take the permission to have it more unofficial, do some chat on the background. I can't see the chat window here. Maybe it's considered a private chat. But anyway. Okay, so we will have also time for a Q&A after. And for now, let's just start and start with the talk. Okay. So the topic we are going to speak about today is GitOps. GitOps is actually a new term in the DevOps realm. And I won't just go back to the history of DevOps. I'm not sure some of you may was in that day where we deploy code by using manual tasks. So when I start my work in tech, the way we are deploy software to a remote server or a remote application, we use this window, this nice window called FileZilla, which open an FTP connection to the server where we want to deploy the software that we try to deploy. And the software was just there. And it all was manual task. And the only permission we need to deploy stuff was the password to this server. And that was quite easy because the whole application, no matter how big it was, sits on one server in our data center. And the only thing we have to do is deploy the code artifact to the remote server. But then the cloud came, and instead of one server where they deploy our code, we had cloud machines. And then we started to have cloud services. And after the cloud services came what we called software as a service that we use as a developer. So think about database as a service, think about network as a service. And in 2012, there became a term called DevOps. And what we can see here is a set of tools, of DevOps tools from 2015. Back in that day, most of the tools that you can see here actually automate the way we've done manual tasks before. So instead of just pushing code, we use automated scripts and by using APIs and workflow to deploy the code. And that helped us because instead of one deployment point, as we have before, now we could have much more deployment points, because instead of just drag and drop code artifacts to a remote server, we have nice scripts that actually pushing code to remote servers or remote services. Now, the thing about DevOps is that this revolution is actually bring the dev, which are all the script that the tools you see here handle, getting into operation. So from manual operation, we got to operation that driven by development, by script. And then we got very easy way to deploy software, right? So today, to deploy software, we don't need much more than 1 or 2 lines in a script and subscribe to a cloud services. And that's actually lead us to another problem, because now if we look on a typical organization, on a typical code organization, we can see tons of deployment points where we are pushing our code to. So for example, if we look at the company I work for, we have 64 repositories, and our backend is actually monorepo. So think about it. We have backend, which we deploy to many Kubernetes pods. We deploy it to some Redis instances. It could be even deployment that we are not responsible for the code it run, but for the infrastructure we are running. So the DevOps revolution actually make it easy to have as many deployment points as we want. So now instead of doing manually stuff and manage manually, we can do it all automatically. And for us as a developer, it makes us to have a lot of deployment points. We can deliver our code to many places. And that's actually became complex because you have another script and another script. And then you need permissions for developer to deploy stuff because it's dangerous to deploy something to production. So instead of just having the DevOps control on the deployment, there is now a ticket system, and this ticket system controlling who can deploy where, and all these deployment points became a very complex mechanism to maintain. And to solve that, a trend started like 5 years ago called infrastructure as code. Infrastructure as code is actually the way to declare our infrastructure on end application as code, as it sounds, infrastructure as code. This actually what we see here on the screen is the Terraform architecture. So we are writing the infrastructure instead of configuring it manually and then control it by script. Then we review the changes and apply it. Apply means deploy. And in this way that we are declaring environment, it makes us easy to control as many deployments as we want. For a new deployment, we need just to declare some new infrastructure as code and then move in the usual approval flow that we have for code review. We can scan the infrastructure in static analysis tool, as you heard before with, for example, Trivi and Keeks and Chekhov, etc. And infrastructure as code actually made it easy to deploy as many deployments as we want. So for now, with infrastructure as code, we can, for example, define or declare infrastructure for many environments, for many stages in each environment, staging, production, test environment, etc. And that actually make the work, the DevOps work, much more organized. And this is the problem that infrastructure as code actually solves. And we should think that the world of infrastructure as code should look like this. But in the real world, that's not true. Because in the real world, we still deploy manually. The last step where we, for example, push our code to the new pod in our Kubernetes in production, or where we are creating a new staging environment and want to get access somewhere, or when we are need a new resource. So as far as I know, infrastructure as code is solving you the way to declare a new resource, but still it requires some permission model, and someone need to authorize the way that you are deploying stuff. And that's actually bring a new problem. The problem of the last step. This last step is where we deploy actually the changes that we are just running in our CI/CD, in our pipeline. And to solve that, we get another trend now. And this is the trend we are going to talk about today. We are getting to the GitOps trend. Now, if you ask me what is GitOps trend, GitOps is more like a mindset. Until GitOps days, developers would use the term pushed. So if you ask a developer what he did at work today, he will tell you that he pushed a change to production. Means in the infrastructure as code world, he declared a new infrastructure or pushed just a code into an existing infrastructure and pushed it to production, right? So the responsibility is of developer. The GitOps trend is saying do not use push, use pulled. Let the Git version control, let the Git source of truth control the software that you are running. So instead of developers that actually pushing code, we want environment to pull code. Okay, so in the old world of infrastructure as code and DevOps, and even before DevOps, the developers was responsible to deploy. But at the end, the last step was a responsibility of developers. And now in the new GitOps world, the responsibility is of the environment. The environment is automate the control of deployment by asking or by get notifying from the Git, from the source control, from the relevant branches, from the relevant stages, what the code should I run now, and run that code. And that's actually solve this last mile problem. We don't need anymore someone with escalated permission to push the code to production. We are developing automated lifecycle that letting the environment manage the code for themselves automatically. Sounds cool, right? But GitOps is actually not new. Git is a tool which is, I think, already 30 years old. And Git has many benefits that developer can use. So for example, we can look on branching strategy. Git actually has built-in very good branching strategy to manage versions and stages of code. And also there is version history. And there is also a very good support in handling files. And code is actually files. And this is why developers used to develop something considered GitOps for decades. And speaking about doing GitOps, I'm going today to share our story in our company. How do we develop a GitOps-based product? And what is the best practices that you can take from it? So speak a bit about myself. My name is Gabriel, and I'm the director of DevRel at Permit.io. Permit.io is a startup that doing everything related to authorization. So if you know access control, you usually authenticate your users to the system. You ask them for username, password, or for some other sort of identity, and then you let them enter into your application. In authorization is the phase that comes after. We know who is the user. Now we need to know what they are allowed to do. And this is the authorization phase, and we are providing a full stack solution. So we have like a SaaS, software as a service product, that letting you configure permission, and then you can pull it in your product and use it in the code to ask if a user can do something or cannot doing it. Sounds simple, but it solves a very complex solution, the authorization problem. So if you look at the code here, this is a typical solution. This is a typical code that a developer trying to see if a user can read a document, right? So think about an API endpoint, and then we are declaring the user from the session who called the API. There is a document, and then we are trying to see who is the what is the document that user can read. And then we are checking also if this user is paying, because a non-paid user is a user that we don't want them to access. And then we ask if user role is admin, or the user geo is US, which means he can access the document, and it allowed for the document type, and is a paying user, and is an editor or viewer. So as you can see here, there is sometimes a very complex decisions we need to make in order to decide if a user can get access or not to a resource, right? And if we look at typical application, this is a very problematic when we are mixing this kind of code, the code that actually get the decision of what we do, doing the decision, with the code that need to enforce what we are doing. So think about it this way. We have dozens of API endpoints in our application, and every API has a different decision to take about what a user can do. And it could be a complex implementation, and we need to find a way to consolidate it, because this is a danger that a user will be able to do something they are not allowed to do. So we want to consolidate it. So we create like a library for authorization. And then from this library, we are asking a different developer to using it. But then we are also need to deploy it to another microservice. And then the points where we get information for users became more complex, because we having like a stick here for example, Stripe wrapper, and we need now to propagate this Stripe wrapper to another microservices. So doing authorization in a modern system, in a microservice architecture, is complex. So what we are trying to do is have a centralized place to get policy decisions. This is actually the product we are giving to customer. And to solve the consolidation of the decision, we are supporting something called policy as code. What is policy as code? So instead of doing all the decision in the application that you are using, we are using a language called Rigo, which is developed by an open source product called Open Policy Agent. And by using Rigo, we are actually declaring the policy. And then what we need to do in the code is only run one query into the policy agent that aware of the policy that we see here. And in the application code, the only thing we have is actually the enforcement point. We don't need to mix anymore between the enforcement point and the decision point. As you can see here, when a user got to application, he got to a PEP, which is policy enforcement point, which is the application code, and ask if I can go to the resource. Now, instead of writing code that doing the decision, we are getting into decentralized container called PDP, as you can see in step 3, policy decision point, that can communicate with the administration point, which has the policy code itself, and also gather information for another data sources, and then returning the decision. In this way, it might look complex here, but if you think on scale, this has become much easier because we have one place to manage the whole policy and permission decision for the whole application. And this is the way we are doing. So for the beginning, we have only UI. We let our user to define all their policy as code in a user interface. As you can see here in a table that they are like configuring policy instead of writing the code. And that works smoothly. But then the users grown and they were need in more complex policy decision. And they ask us, no, I don't want anymore to use your user interface. I want you to help me to manage my policy as code. And as you can see here, we became a product, instead of becoming a product that managing permission, that doing what we need to do, we become a product that manage code for another users. Okay, and this is actually what the DevOps does. DevOps is actually managing code for developers. And when we got to that problem, we understand that this problem is not only ours. For every company that doing what called low-code tools, low-code is like tools that letting developers do a lot of logic with mostly no-code or low-code. This problem actually happened to many companies. Why? Because the users start to use with a real no code. They start to use your UI, implement your very small portion of SDK, but then the use case grow. And then you need to start to manage their code. Manage other code is a headache. You work in DevOps. You know that manage other people code is a headache. So what we've done, we actually created an open source project called Opal. Opal is actually open policy administration layer, but is not only for open policy agent. Opal is actually a server client architecture to manage GitOps for policy as code. So how Opal work? We are actually having our server. Our server is like the GitOps controller. The server is actually connected to the Git repository where our users storing their policy as code, and we have a client. Client, think about it, is like the agent that sits on your environment, your cloud account, or something like that. In our case, the agent sits on where we get policy decision. But the agent can sit actually in your or other GitOps architecture where you need the code to be deployed. In this way, we actually enabling our users to manage all the complex policy as code configuration in an automated way. Instead of worrying about all the cloud that you can see here and the client itself and the agent of the policy or the application, they only need to manage the policy code in the Git repository. So what we are asking from user is getting credentials to their Git repository, and then our Opal server start to track this Git repository and do all the GitOps magic, pulling their policy configuration, pushing it to the environment, okay, which is the open policy agent, and then their application can get the right decision, right? And this is actually how every GitOps tool works. It has a controller and it has an agent. The controller is actually connected to the Git repository and manage what happened in the code. And there is an agent. The agent sits on the environment, on the live environment, and it's responsible to pull the relevant code. Opal is actually open source. I encourage you, if you'd like to do more GitOps and you are looking to do collaboration on open source, you can just scan this QR code. We have a very friendly issues that you can just start to work with. I know that many junior developers want to contribute to open source. Actually, Opal is not a commercial product. You can use it everywhere. You can use it with every type of policy as code that you want. And I encourage you to take a look at the issues page and also star us, because it's very good for open source and the community to get stars on GitHub. So as you can see in the top right of every GitHub repository, there is option to star the repo. So just if you want, you can even contact me directly. You can join our community. I'll share the link later. And also consider how could you contribute yourself for open source. And now let's talk about how can you do GitOps. So the good news, you can do GitOps yourself. Usually GitOps is not that complex idea to implement. You just need to develop the script. Instead of DevOps script that doing the deployment in a push manner, you start to think in a pulled manner. The bad news, there is tools that doing that for you. And I'm saying bad news because I know developers want to develop from scratch, but my recommendation, use one of those tools. The only problem with one of those, with those both tools, is that the good tools for GitOps now in the market works only for cloud native Kubernetes environment. So for example, here is a diagram on how the tool called Flux works. You are installing the Flux agent in your Kubernetes environment, and then the Flux agent is actually synced with all your code artifacts. So instead of your pushing to your Kubernetes clusters, the Flux agent is pulling the changes. Again, we are using pull instead of push. And also Argo CD work in the same way. The only problem with those tools is that they work only in Kubernetes clusters. And for example, for our private needs, we developed a tool that doing it also for container registry. We are pushing container registry daily for our policy decision point. And we were need for a tool that, just a second, sorry. We're in need for a tool that actually do the work for us. So Flux and Argo are good, but you need to work in a cloud native. And now let's see what is the best practices we learned. So as I said, we do a lot of GitOps for ourselves as a feature, and we learn stuff along the way. So the first thing is about enforced the automated tests. So the key for pulling smart the changes to your environment is make sure that the whole pipeline is automated. You need to make sure you are not only running tests, you are also enforcing them, and do not let the pipeline continue without you make sure that all the tests actually running smoothly and end successfully. If there is a problem with the test, your pull is meaningless because you can pull wrong changes. You can also use infrastructure as code to manage GitHub, which is also a strategy that we are doing. And instead of manage GitHub from the UI with a very vulnerable way, you can manage GitHub from Terraform files, and then you can enforce as code things that you are going to do as code, like authorization for authorization. And also, it's a very good to use preview environment. So our strategy is that for every PR created, we are creating environment. And the reason why it's so important is because in this way, we are making sure the PR, the deployment are smaller. Because if we see that some preview environments took a long time to come up, we understanding we are not deploying independently. And that means our deploying could be complex and depend each other. And then it became dangerous for the GitOps to pull the changes because we don't want to break services because each other. Also, we are very encourage our developers to do frequent merges. So for example, we have hooks on the PR that remind them, hey, dude, you haven't merged from main for 1 day or for 2 days. Or for any Git operation, we have like a warning that say, hey, we see that your branch is not merged with main lately. please merge it with main. This is important because we need to avoid conflicts as soon as possible. And one way to avoid conflicts when we are benefits from Git tools is to encourage developers to merge from main a few times a day. Also, we want to deploy quickly. And to deploy quickly, we want to deploy often. And to deploy often, we want to deploy quickly. And the way to deploy quickly is make sure always that your microservices and infrastructure are actually independent. The way that make a process of pipelines and CI/CD stuck is where services became coupled to each other. So make sure your all services are decoupled and you can deploy quickly and deploy often. Also define and document this conflict strategy. You don't want that the conflicts will make developers to get avoided to deploy software. So what we are doing, we designed the conflict strategy on the GitOps, because Git, when it comes to be automated, it could easily get into conflict. So we design how the conflict works. Who is the source of truth? How do we push to production, and how do we push to staging where there is a conflict? But not less important is also document that, so developer will know what we are doing now for a better conflict resolving. Another practice is use hooks for state management. Sometimes something stuck on the state, right? So the GitOps agent tried to pull something to the environment, and then something stuck. And no one knows what to do and how to solve that. So we want to have a hook like a button that said, release this stuck pipeline, resolve this conflict, remove this branch, etc. But what we need to remember is create all these hooks in a pull manner. Instead of a push manner, in a hook that doing something, the pull is actually doing the operation on the Git itself. And then we are still enforcing all the automated test and the automated state management, even if there is manual hooks on the way. Also, enforce the way developers work on branches. We are enforcing that for every branch, we have only one code collaborator. We are not allowing multiple developers to work on to push directly to a branch. If developers want to collaborate on a branch, they need to pull a branch and then pull branches from it. So when developer commit partial code to branches, we are enforcing that only one collaborator is working on the branch. And the reason why is that important is because we want that we want to consolidate every branch that developer open PR for. And this actually maximize our safety when we are automate deployment of GitOps pooling. Also, it's important to define the naming convention for branches. And the reason for that is that you need to remember that there is declarations behind your environment. So even if you do GitOps cannot work with a good infrastructure as code declaration. GitOps is not something that knows to operate in something that is not actually declared as code. So you need to remember the infrastructure as code need to know how the namings work. And this is important for it to have a very good naming convention for the branches, and then you can propagate them to the infrastructure as code and make sure all the parts playing together. Another point is about linking logical environment. So you think about a logical environment, for example, in our case, authorization and environment that we are deploying application to it. And then we can link this environment as branches. We can have, for example, branch for staging and branch for production and branch for every testing cycle, nightly testing cycle. And this linking is actually important for you to understand always how do you look at the code and understanding how actually the parts playing together. And also when the environment became complex, you should start separate repo. We are not big enthusiastic of multi-repo in our company, but we understand that sometimes you better separate repo for infrastructure as code, policy as code, whatever a code, or the application themselves, to avoid conflicts and have a better permission model on the infrastructure as code components. And last but not the least, because I'm pretty sure after you'll have some more best practices, is use policy as code to control the pipelines. The meaning of that is you can use Open Policy Agent or the admission controller in Kubernetes to control what happened on GitOps. So you don't want the GitOps to just pull every change. You can configure with code, the same as you configure environment, the permission of what your clusters and what your environment can pull from the GitOps controller. So this is the best practices that I have for you. I hope you will do GitOps. I hope you already do GitOps, because I believe this is the way infrastructure as code could work better for all of us, and also make our life as DevOps much easier, because now we don't need to worry about code anymore. We let Git worry for it. As I said, I will really appreciate your support in our open source initiative. The main support you can bring is just star us on GitHub. GitHub stars is actually letting developers understand that what we are doing is actually important and can help them in the day-to-day job. Thank you. Bye-bye.
Thank you very much for your presentation. Toda rabá.
Thank you.
Toda rabá, Gabriel. I hope everybody's taking notes of the questions. By the end, we will have a questions Q&A session that everybody can ask you questions, Gabriel. For now, I would like to just thank you for sharing your time. It was a very interesting presentation. Very nice product. I hope it has a big success.
Thank you.
Okay. See you later, Gabriel.
See you. Bye-bye.
Bye-bye. So, guys, it's time for our next presenter. It will be Elkhan. How do you do, Elkhan? I'm sorry, I
Bring me
just
to the
missed you
screen.
here.
Hello, everyone. How are you? It's Elkhan. It's a silent K.
Elkhan. I'm sorry
Elkhan,
about
yeah,
your
just
pronunciation.
You're
Elkhan.
fine, Gustavo. It's usually not an easy name to pronounce, so you did pretty well. Okay.
Yusubov.
Yes, Yusubov is my last name, correct.
Where are you from, Elkhan?
I'm actually originally from Azerbaijan, but I'm currently in States. I mean, I'm joining from the East Coast.
Very nice. Azerbaijan.
Yes.
Very nice. And for how long have you been in the States?
It's been like more than 15 years now. It's been a while.
Yeah, it's been a lot. Yeah. So, Elkhan, you were a manager and an architect for the T-Rex company. Is that right?
Yes, that's right. I'm managing the cloud engineers and architects in a company called T-Rex Solutions here at East Coast, United States. And we deliver cloud modernization and cloud services to our customers.
That's nice.
Mm-hmm.
So you were talking today about securing infrastructure
as a code, yes, in your cloud environment.
That's very nice. Thank you very much for being here with us to share your knowledge. And
thank you, Gustavo, for welcoming.
Sure. So this is your presentation.
Yep. Thank you.
The floor is yours.
Great. Thank you. All right, everyone. Welcome to this session. I know that you have been in this session, probably in this marathon for a long time, and probably are a bit tired, but I will try to make my session a bit more different, maybe dynamic in terms of if you put the questions there in comments, I will try to address them right away. And what I'm going to do here in this session, Zero to Hero, is to take your knowledge of understanding infrastructure as code and security concepts into the next level, where you can actually don't just Google those terms, but you also know the principles. You know what are the main cornerstones that you need to have in your project, so that you can say that your infrastructure as code that you use to deploy your cloud services is actually secure, and how to achieve those state. And in addition to that, I'll provide a small example and demo at the end of the session. But before doing that, of course, I want you to become familiar with the principles, with how to understand this concept and how to get on a right foot if you are trying to secure your infrastructure as code. Okay, I hope that's interesting to you, so that we can start our session. So a little bit about myself. Thank you, Gustavo, for introducing. My name is Elkhan, and I'm a cloud architect manager, as I mentioned. But in addition to that, I'm a Microsoft MVP. And on the left side of this slide, you see some of my social contacts. I'm on LinkedIn and on Twitter. I really appreciate if you put a direct message there, or want to get connected with me, as because if you get connected with me especially on a LinkedIn platform, you would see that I usually push some really informative and new content regarding the infrastructure as a code, DevOps, and automation that you may find very interesting. And in addition to that, I'm also author on a LinkedIn. So if you see any video courses here and there, it might be some of the latest editions that have been published from the LinkedIn platform. But I'm there to guide and mentor people, and especially the community who are trying to learn. Okay, it's enough about me. But I also have a blog that I'm running, the cloudmarathoner.com, and if you see a hashtag cloudmarathoner, know that it's actually my thoughts and some of my perspectives in terms of how to approach certain technology concept, or implement something, or solve the problem. All right, that's it. I want to just spend couple of seconds here on this slide, which is a compact infographic about the company where I'm working. We are proudly actually working on delivering mission critical systems, which are cloud-enabled solutions to our customers, with a team of engineers that I'm managing here at TRX Solutions. We have strong partnership with cloud solution providers as well, that help us to deliver the best we can to our customers, and we also support our local communities here. In addition to that, this is another infographic that show you information about the different agencies that we are working, and a scale of the work that we delivered, especially during the US Census 2020 program, which was actually conducted under as you know, it was a COVID time, people were locked down, but still this program was successful in terms of not revealing any major vulnerabilities during the operation timeframe. And that was in part due to security-minded professionals that that are employed within this organization, and open-minded approach to secure the customer workloads before the vulnerability is there. Now that said, I want to go through what we will cover in this session, so that you can get some expectation in terms of what to expect from this presentation, and let's dive in. So first we'll start with manual configuration risk, right? So everybody knows that when things are not done in a proper way, and if you don't script or automate or version control things, then certain stuff can go wrong very easily and get out of whack. So we'll look into how we can avoid those manual configuration risks, how we can we'll look into how we can declare resources as infrastructure as a code. And while speaking about infrastructure as a code, keep in mind that sometimes I will use abbreviation IAC, and IAC will stand for infrastructure as a code, so that I'm not repeating the same thing over and over again. Then we will look into DevSecOps principles, which is DevOps, is building security into that. and what to expect, what should be the cornerstone of that approach. Then, of course, after that, we'll look into policies and governance that would enable your organization to use infrastructure as a code and its benefits to this approach. And finally, we'll look into some use cases and demo at the end of the session. And I will also try to spare a couple of minutes at the end of session so that I can address any questions that you may bring into the studio. All right. So I hope that sounds interesting to everyone here, and we can kickstart our session. All right. Okay, let's start with the first one. So manual configuration risks across any cloud vendor, that may happen because when you log into any cloud vendor portal or console app, you would see that you have the ways to configure. But poor and inconsistent configuration of cloud resources can lead to a lot of errors, right? Which could have a negative impact on the performance of your cloud environment, first of all. And secondly, the manual updates can result in errors and mistakes but even if the update works well, what always annoys me as a professional is about the manual updates that they are almost never consistent, right? When you have manual updates here and there or different places, they are never going to be consistent, which creates pain points and issues down the road. So we have to have a better way to manage it. Next is security risks that are, born with these manual configurations. Manual configuration can also lead those risks due to misconfigurations, right? And the lack of strong security measures that are baked into the proper configuration that you need to provide for your service. Next thing that we worry about this configuration is the vendor lock-in. So manual configurations of cloud resources may lead to vendor lock-ins, meaning that if you decide to switch cloud vendors from one cloud solution provider to another one, you will have to manually transfer all the data and configuration to the new cloud. Just to give you an idea, let's say you want to switch the data service providers, like it can be your S3 bucket and cloud storage account in Microsoft Azure. Their configurations, of course, they are similar concepts, but they are different. And if whenever you just use one of them, you kind of vendor lock in with all the configurations that you can apply to that service. Next is cost overruns, right? So manual configuration of cloud resources can lead to cost overruns as it is difficult to accurately estimate the costs involved in creating, configuring, and managing cloud resources. And especially with the manual deployment, whenever you don't have automated way to manage your resources, cost of the running resource, more than you intended, or not having any specific schedules will always result in cost overruns. And finally, lack of automation. With manual configuration, you miss out on the benefits of automation. It means that you just take all this goodness that brings efficiency into your project and you just throw them into the trash. So lack of automation usually is actually not just about time, but it's also efficiency and security. With manual configuration, though, you miss out on those benefits of automation, such as faster deployment, improved scalability, and flexible resource management that can be done with part of the automation and scripting that you can bring into your project. So before going too much into infrastructure as a code and those principles that we described, I want to actually dive into infrastructure as a code options and tools that we currently have. And some of them might be familiar to you because if you follow me on different social media, you would see that I am sharing actual information about that. And first of them, let's start with Azure Bicep, which is the newest family in infrastructure as a code. And as you know, Azure Bicep is a new domain-specific language for provisioning the Azure resources. It's focused on Microsoft Azure platform. And the purpose of this language is to simplify the authoring, experience with the cleaner syntax and more code reuse in the components that you try to create and manage those cloud resources that you have to have in place to run your project. This new language is actually aims to make it easier to write those infrastructure as a code for developers and DevOps engineers that typically create those Azure Resource Manager templates to provision and maintain infrastructure where the project should run. Next, as you know, there's like another big player in this infrastructure as a code field called Terraform, right? And Terraform enables infrastructure automation for provisioning, compliance, and management of different clouds like AWS, Azure, GCP, data centers, and services. And with Terraform, you learn one syntax and one structure that gets applied to the supported cloud providers, right? But it comes with its own nuances that you have to manage, like state file and other pieces that you have to be aware about. Next, tool that has been used a lot, especially in the projects that we did for our customers, is Ansible. And Ansible can be used to provision the underlying infrastructure of your environment, virtualize hosts and hypervisors, network devices, and bare metal services. And it can install those services, add compute hosts, and provision resources, services, and application inside of your cloud. So it's a very powerful tool that's used across the organizations. In addition to that, when we look at the cloud side and to AWS, AWS came up with the cloud infrastructure tool called AWS SDK, which probably are familiar with. And it is known as a Cloud Development Kit. That stands for that CDK, sorry, for that CDK. It's a framework that, again, developed by AWS that allows you to define and provision cloud infrastructure in code and deploy it through AWS CloudFormation. And finally, the last but not least, we have Pulumi, right? And Pulumi, you can, if you want, you can compare that with Terraform in a way that while both Terraform and Pulumi are declarative tools, Pulumi uses general purpose imperative language. So you may ask, what does it mean, right? Imperative language. It means that Terraform automatically generates the infrastructure based on the code that is written, while Pulumi requires the user to write the code that specifically describes the infrastructure. So it's a different approach in terms of applying those concepts. Okay, now knowing these major tools in infrastructure as a code field, now it is time to dive to our next portion, where we'll look at how you can declare resources as IAC, or how you can declare them as infrastructure as a code, and what benefits it brings to you, right? So why you should care about them, or why does declaring these cloud resources as code will minimize the security threats and improve the security compliance posture of your organization and your customers. So first of all, declaring cloud resources as code refers to using this programming language or configuration file to define and provision cloud resources, such as, it can be your virtual machine, it can be your compute, storage, or network services. By doing this, organization can benefit from a number of security-related advantage. And first of them is consistency and repeatability, as you see on the screen. So declaring cloud resources as code enables organization to maintain a consistent and repeatable infrastructure across multiple environments. And this, in fact, reduces the risk of human errors and configuration drift, which can lead to security vulnerability. So this is one way how you can prevent it. Second way, of course, is automation, automation, and automation. With IAC, which stands for Infrastructure as a Code, you can enable your organization to automate the provisioning, configuration, and management of the cloud resources. And this, in fact, going to reduce the need for manual interventions, which are basically correlated with introducing security risks. So less manual work is done on, setting up your resources, and more repeatable process you use. It means the more secure, more reliable it is. Next is, it's not just about setting the cloud resources. In addition to that, we need to have certain type of testing to verify the stuff, right? And that's where IAC tools can help you to identify security misconfigurations and vulnerabilities in cloud resources before they are deployed. With security testing, you can include checks on default passwords, open network ports, and insecure storage configurations that you want to avoid in your deployment. So part of the verifying what you deployed is very important, especially with infrastructure as a code. Next is, of course, things will go wrong, right? No matter how awesome your automated script is, in a real world, you will have your oops moments where, for example, deployment of the infrastructure as a code went with the wrong version, or things that used to be working in one environment for some reason magically do not work as an update on another environment. So to manage those risks, and in order to be very confident that if things goes wrong, you can have this ability to revert back to a prior state of the resources and the services that you run for your project, we need to have this thing called version control. And by using version control tools, your organization can track changes made to their cloud infrastructure over time, enabling them to quickly revert to a previous known good state in the event of security incidents or issues that are, or a big issue that's you're getting, calls from tier one support or from the customers. Next is, of course, part of this movement is about compliance, especially when you are working for a regulated environment where compliance is dictated by the authorities. Then you want to declare your cloud resources as a code so that you can help your organization achieve and maintain compliance with security standards that are actually mandated on your system. And when we speak about those standards, we talk about regulations like SOC 2, HIPAA, PCI compliance, and similar ones. And automating the deployment of security controls and configurations will make sure that your organization can more easily demonstrate their compliance and security posture to auditors. So when you get the audit, you have basically, proof points to show why your system is actually, compliant. So to sum it up, declaring cloud resources as code has many benefits, especially for your organization's security posture. It ensures that infrastructure is configured consistently and consistently meets security requirements. That consistency is something that you actually value very much, especially under that security, mindset, under that security requirements that you have to be compliant with. It is also makes it easier to detect, identify, and remediate those security vulnerabilities that may come up, during this development stage or even staging stage when you are planning for your deployment. By automating those deployment of cloud resources and infrastructure resources, your organization can reduce those manual errors, and enforce the security best practices, and as well as ensure that all resources are properly secured and ready for deployment. Again, using this code to manage cloud resources will also enable your organization to track the change and detect unauthorized or malicious modifications that happen to your environment, which is also very important to have a monitoring on top of that. And finally, it allows you to quickly deploy a secure infrastructure on demand by reducing the time to market for new application and services and making sure that you have this confidence of bare minimum secure baseline that your infrastructure is actually compliant with. Okay, that said, this is just the part of the infrastructure as a code and security. But as you know, when we speak about operations and we speak about how we can bring all of this into the one kind of concept and principle that we can use, then we need to shift here to DevSecOps principles, right? And what are the modern DevSecOps principles that your organization should invest to adopt, right? Because if you want to be on that curve, you have to be ready. And DevSecOps is a philosophy and set of those practices that integrates security into your DevOps process. And first one that you may hear a lot is shift left. And what it stands for is that it's an emphasis of shifting security and testing and controls to the left or earlier in the software development lifecycle, which will enable your team to identify and address the security vulnerabilities early in the development process when it is much cheaper or not costly to fix, and that would reduce of course the cost and impact of those issues so you can remediate them. Or in another word, shift left will also help you fail fast and often by basically making sure that you have a frequent iterations and you can test your code without expecting that it to be a perfect, in a perfect state. So you can provide this, I would say, so that you can provide those um, gradual incremental value on each deployment and show the progress to your customers. Next, we have automation, right? Automation, again, you can't skip that. And automation is a key principle that's coming with the DevSecOps. It enables teams to quickly and consistently test, deploy, and manage code while also ensuring that security controls are in place. Then we have, of course, CI/CD, right? You can't skip that from your DevSecOps principles, which is your continuous integration and continuous deployment. And this is a software development approach that always emphasizes frequent automated testing and deployment of code change into your environment. So with DevSecOps, you have this requirement that your security testing and controls are integrated into your pipeline, into your CI/CD pipelines, and enabling team to quickly identify and address security vulnerabilities as they occur. Of course, because we talked about code, now in order to have that compliance, we want to make sure that our security itself is also baked into the code, or a notion of security as a code, right? So security as a code refers to the use of code and automation to define and manage security controls, policies, and procedures. So this will enable your team and your project to manage security in a consistent and repeatable way by reducing the risk of human error. Again, this is part of the automation that you want to bring into your security aspects of the project. And of course, with DevSecOps or principle, we should always emphasize collaboration and communication. This is very key and very important thing that might be skipped, because emphasizing this between development, security, and operations teams is something that will bring the best minds to collaborate, and it will ensure that security is integrated into every aspect of the software development lifecycle, and that all the teams will work together to identify and address the security vulnerabilities. So you want to make sure that it's your basically DevSecOps principles are more in the it's a team sport rather than just security teams trying to find the issues and fix them. And that's also part of the continuous improvement that with any pipeline and any approach you want to build into the team, so that you can take your team can take those constant improvements and assess them and improve each security practices, process, and tools to ensure that they are keeping up with the latest threats and best practices, because with security, the landscape is always going to change. You'll get the new threats no matter what, and having this continuous improvement as part of your process is going to help your team to, to reflect on that and make sure that you have a continuous iteration and feedback loop. So overall, by investing yourself, your team, or your organization into these modern DevSecOps principles that we counted, you can improve your security posture dramatically and deliver software that is secure, reliable, and high quality. Now, this is going to be the last, I would say, last slide before we switch into some demo, to some showcase on how you can apply those things. But with policies and governance, what we are trying to target is what are the those policies and governance that drive your organizations toward the adoption of secure infrastructure as code approach. So basically, what policies you need to have in place in order to make this adoption happen and come to the way that you have this secure infrastructure as a code mindset within your organization. So first of all, security compliance, that we mentioned before, it's all about those standards that you need to comply with. And as you mentioned, we talked about HIPAA, PCI, and SOC 2. There are some of those compliance standards. And using those secure infrastructure as code approach can help your team and your project to achieve those security compliance by enabling them to enforce those security policies and best practices in a standardized and automated way. Then to achieve that, you need to have DevOps practice, which is a mindset. It's not just tool, it's a mindset where your software development approach will emphasize on collaboration, automation, and integration between development and operations teams. So it should be something that you have this practice across the organization and disciplines. And IAC, or infrastructure as a code approach, is a natural fit for DevOps practices, as it enables team to manage infrastructure using the same tools and processes as they are used for the application code. Then, of course, next thing here is risk management. And organizations need to define and mitigate risks to their infrastructure and data, right? Data is the most important, I would say, most valuable assets that you have to protect and secure. And with IAC approach, you can provide to your organization a greater visibility and control over the infrastructure, making it easier to identify and address security vulnerabilities. Again, secure infrastructure as code approach helps organizations to reduce the risk by ensuring that security measures are built into the infrastructure from the start, and codifying them, making them secured as a code is part of the process. Then, of course, once you have that in place, continuous monitoring is an observability. Having good monitoring is must to have, and it's a critical aspect of maintaining the security of an organization's infrastructure too. Security can build in the infrastructure from the start by using the infrastructure as a code approach, and this approach will provide your organization with the ability to automate security testing and validation, ensuring that security measures are maintained and tested over time. So you use and you update them. And finally, compliance auditing, right? So auditing is a requirement for many organizations, and depending on which industry you are serving your customers, you may have different requirements. But with infrastructure as a code approach, audit trails can be automatically generated and maintained, making it easier to demonstrate compliance with security policies and regulations. Secure infrastructure as code will provide to your organization with the ability to audit their infrastructure and resources for security vulnerabilities and demonstrate that they have implemented appropriate security measures to protect them. So in summary, the policies and governance that drive organization toward the adoption of secure infrastructure as code approach are security compliance, DevOps practices, risk management, continuous monitoring, and compliance auditing that we covered in this slide. These policies and governance provide organization with the tools and processes to build, deploy, and manage secure infrastructure at a scale whenever needed. All right. That said, in terms of use cases and demos, before going to the questions and answers, I want to share my browser here for a second, and you should see a Azure subscription that I'm using here for policies. And here I have two policies that have been deployed. These are the initiatives. One of them is a standard one, as you see there in the red, and I have tag governance policy. So this tag governance policy is here. Whenever you are trying to tag and maintain the security, you want to make sure that each resource is have a proper tagging policy so that you can query them and look at the state, right? So here, as you see, these tagging policies are based on the resource and the resource group concepts within the Microsoft Azure. And if you are interested in how to apply them and how it works, I have a repo, and I'm going to share the QCR code on the next slide to this repo. But here under the, you can find many useful information about the security concepts that you want to use, and as well as tagging policies here in this folder. If you go there, you can find the descriptive code of each definition of that policies that have been deployed, and you can get understanding what's going on. So if you want to deploy this, I would just say you come to this repo, read it, and also look into the scripts where you have ready-made scripts for you to help you with the deployment of those resources. Okay, that said, I have this questions and answers section. So if there are any questions in the studio, Gustavo, you can bring them up.
Hello, Elkhan.
Yes.
So we are organized in a way that we leave the questions and answers for the last part of the block. So
all right,
thank you very much.
Works fine.
Thank you very much for
let me just cover it
presentation.
up, Gustavo. Thank you, because I promised in my presentation that I'll put the QCR codes. So these are the QCR codes that you can scan with your mobile phone if you are on a mobile device, and get the information about that, how to get to learn with Bicep. On the left side, you have this first look course on a LinkedIn platform that you can watch if you'd like to and get familiar with that tool. And I also maintain with the community, we maintain this GitHub repo called Awesome Azure Bicep, where you can get up to speed with policy as a code, kind of concepts, and other things that this specific infrastructure as a code tool will provide to you. So that said, I want to thank you everyone here because our questions are going to be at the end. So thank you everyone for joining my session, and thank you DevOps Global Summit DevOps for organizing this event. This is really a great initiative, and thank you everyone who joined. And I hope that you can get some helpful information from my presentation, and you can get connected with me on LinkedIn or on Twitter. Feel free to direct message me and say hi, and let me know if you have any questions. Thank you.
Thank you very much for your time, Elkhan. Was a very nice presentation, and I hope you can stay with us in about 30 minutes after the next presenter, and we will for sure discuss a lot, and we have a lot of questions for sure.
Sure, I will join that session. See you.
Thank you very much.
Okay.
See you. Bye. So our next presenter is Audrey Long. Hello, Audrey. So let's test your microphone right now. Let's see.
Oh, oops, I was muted. Can you hear me okay?
Yes, now I can.
All right.
Yeah.
Awesome. Let me
How
go
are
ahead.
you? How are you doing?
Doing well. How are you?
Good, very good. Where are you talking from?
Right now, I'm talking from North Carolina.
Oh, North Carolina, because I saw Tijuana somewhere and I was thinking about, wow, Tijuana must be nice to live. I don't know.
Yeah, absolutely.
Yeah.
I'm trying to share my screen. Can you see my screen?
Yeah. Yeah, I can see your screen here. Just a second. It's a little bit small here, huh?
Yeah, that's weird. One moment. It's probably because the monitor is it's vertical. So let me see if I can swap that.
Yeah, you can try to upload your presentation as well.
Okay.
Let's see if that works.
Let's upload it. Oh, the file size is too big.
It's too big?
Yep, the file size is too big, unfortunately. So let me try this one more time.
So guys, while Audrey is loading her file, just a quick introduction. She is a security software engineer at Microsoft, and she's presenting us today Threat Modeling, Star Wars Edition.
Yes, and I will just share my screen.
Let's see here. It's not loaded yet.
And I will present. Can you see my screen okay?
Yeah, much better. Take a look.
Okay.
Yeah.
Awesome. So I'm going to go ahead and get started then. So thanks everyone for attending my talk, Threat Modeling Star Wars Edition. So a little bit about me. I'm a senior security software engineer at Microsoft. I love to travel and I love to cook. Some of the nerdy things I like to do is, play PC games, I like to read, I like to do presentations, and I like to tinker. I have my master's of cybersecurity from Johns Hopkins University, and I have my bachelor's degree in computer science from the University of Cincinnati. All right, so today we're gonna have a deep dive session over the wonderful world of threat modeling. We will leave today's talk with new perspectives and learning. By the end of the session, we will obtain a security mindset, gain some threat modeling fundamentals, walk through the steps to generate threat models, threat model the Death Star, and obtain some cool security knowledge along the way. So what is threat modeling? Let's set the table here for a second. So threat modeling works to identify, communicate, and understand threats and mitigations within the context of protecting something of value. A threat model is a structured representation of all the information that affects security of an application or of a system. In essence, it is the view of the system and its environment through the lens of security. Threat modeling can be applied to a wide range of things, including software, applications, systems, Internet of Things devices, really business logic, anything can honestly be threat modeled. Your door can be threat modeled and has been threat modeled, I'm sure. Okay, so let's take a step back and now ask, so who should be threat modeling? So software engineers, security engineers, architects, program and technical program managers, software testers, really anyone that has a working knowledge of the system can create a threat model. When should we use threat modeling? So it's best performed during, design sessions. It's easiest to make the changes to the threat model when you're generating this from the beginning. It's less costly than actually adding the mitigations and testing them after your solution has already been implemented. So really, we're trying to shift security to the left as well as threat modeling. We say that a lot here in our industry, but in this case, threat modeling earlier on does lead to better security outcomes when generating architectures. So we want to use threat modeling when we design new systems or if we want to update existing ones. Some examples, and these are just some technical examples, can include new Azure microservices or cloud applications, designing a public API to provide customer access to your data, adding a new feature to an existing old application, or creating new cloud infrastructure projects. And as I said before, you really can do it for almost anything, but those are the use cases that I really jump into today with my job. All right, let's talk a little bit about a security mindset. Security requires a particular mindset. Good security professionals see the world differently. We can't walk into a store without noticing how we might shoplift. We can't use a computer without wondering about the security vulnerabilities that lie inside. And we can't vote without trying to figure out how to vote twice. We just can't help it. This kind of thinking is not natural for most people. It's not natural for engineers. Good engineering involves about thinking about how things can be made to work. The security mindset involves thinking about how things can be made to fail. It involves thinking like an attacker or an adversary or a criminal. You don't have to exploit the vulnerabilities you find, but if you don't see the world that way, you'll never notice most security problems. By adopting a security mindset, you emphasize the attacker, their motive, their means, and all the ways they can wreak havoc in a system. This approach looks at an entry point in system weaknesses and allows you to focus on critical assets holding highly confidential information. When weaknesses are discovered, emphasis is placed on protecting those assets instead of the entire system. Let's talk a little bit about the phases of threat modeling. So depending on your use case, threat modeling could look a whole lot different than this. However, this is what I like to call the phases of threat modeling for cloud applications or for applications that are new, being created right now and today. When you look at a threat model for the government or any other type of industry that requires threat model with a lot of probability and vigilance, the phases of threat modeling there might include a few more phases, or in some cases, a lot more phases. However, if you're starting out and you work primarily in cloud applications, or you have a system design that you're interested in creating, these phases of threat modeling are pretty lean and they can really apply to most things. So let's go through them all step by step. So the first thing is to analyze the existing system. And we also call this as the design phase. And the design phase is the starting ground for your threat modeling activities. You'll gather as much data as possible about what you're building and what you're using to build it with. So some of the high-level goals here when analyzing the existing system include developing a clear picture of how your system normally functions, enumerate services consumed by your system, investigate environmental assumptions and security controls, gather system requirements and requirements documentation, and identifying those key security stakeholders from your customer side of the house or within your own industry. So we could all decide holistically, what we need to gather to create some of these threat modeling artifacts. And this step is really important. We don't want to over-index on what we need to know fundamentally as a system before we understand how we can break it. All right, now the second step is to design some data flow diagrams. Data flow diagram is a visual representation of a process or system's flow of information. By mapping out your processes or your system's flow of data, DFDs will help you better understand your processes, your system, and it covers some of the weird kinks that are within it. And it can help you implement a new process or a new system as well by uncovering some of the weird edge cases perhaps within that flow scenario. So some of the high-level goals here when we're creating data flow diagrams are to understand the user and the system scenarios throughout the system, to establish trust zones and boundaries within your system, identify user permissions used throughout the lifecycle, and investigate protocols being used inside and outside of the system which is being designed. Here are some data flow diagram elements that should be pretty universal throughout the threat modeling community. Data flow diagrams are made of shapes that create graphical representations of the system. Each shape represents a unique function. Each interaction is analyzed to help you identify potential threats and ways to reduce risk. Using shapes correctly helps you receive better input from colleagues and security teams. Everyone will then understand how the system works. It can also help everyone avoid going through countless design documents and development plans to get them up and running. Now, the third step here is to identify threats. This phase is where you use the data flow diagram to find potential threats against your system. We will use a threat modeling framework to help you find the most common threats and ways to protect against them. A threat modeling framework is essentially a series of rules and guidance associated around teasing out threats within a system or an environment. Threat modeling is a great technique to help you find issues early in the development lifecycle. Choosing the right focused approach helps you tailor the threat modeling exercise. You'll find more actionable threats and ways to solve them. Microsoft traditionally uses STRIDE, an acronym for the 6 main threat categories, to provide an extensive but not exhaustive list of threats. And we'll talk about that a little bit later on. Some goals when identifying threats include to apply your security mindset to your data flow diagram. You choose whether you want to find ways to protect your system or if you want to understand how you can, all you can about attacker and their motives. Depending on what kind of a mindset you apply to your threat model, the outcomes will be different. Use the data flow diagrams to find potential threats against your system. Apply those threat modeling frameworks, and then identify system weaknesses. Here are some common threat modeling frameworks. So STRIDE is a threat modeling framework developed by Microsoft in 1999. The STRIDE threat model is focused on potential impacts of different threats to a system. STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, escalation of privileges. By considering these potential impacts or goals and considering how they can be achieved, it is possible to identify attack vectors for the system under test. Based on this information, it is possible to assess the risk and impact of each potential threat and develop countermeasures to mitigate against it. Some other popular threat modeling frameworks include the MITRE ATT&CK framework and OWASP Top 10. And these are really used for cloud application security threat modeling frameworks. So if you're using if you're creating a threat model for an embedded system, I don't think you would be using OWASP. However, on the previous slide here, there's also some other examples of some threat modeling frameworks that could be potentially useful for your scenario. All right, so now we're going to go to the stage of brainstorming mitigation strategies. So this phase is where the fate of all threats is decided. Each threat modeling framework should map to security controls within your environment, which offer different functions and types to choose from. Once the mitigation candidates are created, assigning a criticality or a weight to each one determining which mitigations need to be implemented right away would be very useful. Some of the high-level goals here are to measure each threat against a prioritization framework, or we use a security bug bar at Microsoft. Track each threat as a task or work item in a backlog. Generate security control recommendations that are mapped to threat modeling frameworks that are actionable. And select one or more security control types and functions to address each threat. Now, going back to the data flow diagram elements that we talked about earlier, this is a really nice way to map and act the framework that we use, in this case STRIDE, back to the DFD, so that when you're actually thinking about the threats and applying them to your threat model, you'll have a good understanding and idea of where some of these STRIDE elements could land. Now, do mappings like this exist for other frameworks? Potentially. I only really use STRIDE a lot in my day-to-day, so this is the one that I would recommend the most to look at when you're generating, your mitigation candidates. Now, last but not least, we want to continuously iterate and verify. This phase is the last step of the threat modeling process, which often happens before the system is deployed. It involves ensuring requirements are met, assumptions are validated, and security controls are in place. Some of the high-level goals here are to confirm all previous and new security requirements are satisfied for the system, configure cloud providers' operating systems and components to meet security requirements, ensure all issues are addressed with the right security controls, take systems through manual and automated verification before deployment. All right, now that we have a high-level overview and an understanding on the 5 phases of threat modeling, let's apply that new knowledge that we have to threat model the Death Star. So yes, you can threat model anything, and in this demonstration, we're going to threat model the Death Star, and we're going to see how Stride can help us identify some of those weaknesses and how we can mitigate against them. So step 1, analyze the existing system. So according to the US government, and no really, the US government actually did this calculation. The first Death Star would have cost $852 quadrillion to construct. The Death Star took 20 years to build because of its sheer size and complexity. The Death Star is a very complex piece of machinery which contains very intricate services which rely on each other to achieve total destruction. It induces fear also throughout the galaxy, and the Death Star's main purpose is to function as a mobile platform for its main weapon, the super laser. The Death Star structure is basically an enormous housing for the super laser and the reactor that powers it. At a high level, the Death Star is made of 4 major components: the battle station, the super laser, the propulsion system, and the hypermatter reactor that powers it all. So let's kind of go over these components at a very high level, because it's really important for us as security engineers or engineers in general to understand how things work. That's how we can then apply frameworks to figure out how we can break them. So the battle station. It's a huge trench split at the surface of the station into 2 hemispheres. The trench is used to house many of the Death Star's main systems, which include the landing base, the drive thrusters, the sensor arrays, the tractor beam systems, and the thermal exhaust port, which are an outlet for disputing the excess heat produced by the large energy reactors based on the broad starship and space stations, or in certain ground-based structures. The super laser has a large massive lens built around a huge synthetic focusing crystal. The lens is known as the eye and surrounds by 8 trebuchet lasers. The propulsion system is the Death Star's propulsion system made of a network of ion engines that is used to convert and transform reactor power into thrust. The hypermatter reactor is the greatest challenge in designing the Death Star, and it was not creating the cannon big enough to fire a beam to destroy a planet, nor was it creating a battle station the size of a small moon, but the greatest challenge was also powering a cannon that was big enough to fire a beam that can easily destroy a moving planet and move the battle station. All right, so we've gathered our requirements. Now let's look into the data flow diagram for something like this. So as you can see here, I've constructed by hand a data flow diagram. I just used the Visio tool, and in my day-to-day, I actually do like to use Visio a lot when actually generating data flow diagrams. There are threat modeling tools out there that could help you design data flow diagrams and even apply some frameworks. However, I'm pretty old school, so I like to do it by hand because I like to gather more data and information. And, genuinely speaking, I don't trust tools. And I feel like sometimes we all get into the mindset of just trusting whatever output the tool gives you. And I think you should use tool outputs as just kind of a secondary thing. Maybe something to use as evidence to prove your initial hypothesis. But if you rely solely on tools, which a lot of, I feel like security folks do in a lot of security roles, I feel like that's just going to lead to eventually ChatGPT taking over your job. So let's try to think about how we can apply our mindsets to, making some of these security artifacts and security topics more relevant and not overtaken by AI. Even though AI is cool, we can still use it. All right, so here we can see the commanding computer station is what a user generally interacts with to send any kind of commands to then go throughout the Death Star to do any kind of a function. For example, we can toggle the tractor beam system to pull in a ship to us. We can command the hypermatter reactor to eliminate a planet. We can activate the deflector shield so we can be in a defensive stance whenever we're being attacked. We can activate the drive thrusters in the propulsion system, and all that data comes through the commanding station's computer. Now, here is something that is pretty interesting. This is what I like to refer to as a threat map, otherwise known in some other languages as attack trees. So an attack tree's main purpose is to have an attacker's objective and then different ways on how an attacker can actually achieve that objective. That's in classical sense what an attack tree is. So this, in this case, this is something known as a threat tree or threat map, which is just high-level goal nodes of attack tree scenarios being applied to our threat modeling framework. So we can see from the data flow diagram we constructed before, we have now overlaid a threat map so that we can have a better understanding on where some of the vulnerabilities really lie. And here's where you can use your security mindset to really be creative and understand, some of the potential vulnerabilities that are out there and how to break them. And this is pretty standard as well for any type of service. It could be for, cloud services, it could be for embedded services. Everyone's going to do their research to see how they can exploit what exploitations are like out there for C libraries or C++ libraries. How can we break into Azure? What are some of the endpoints that are not protected that we can find? Is there open source repository or code that's out there that's not protected or potentially has some access keys? There's lots of things that attackers can and will do to try to, understand and break into your system. But in our case, so we can see historically also through the Star Wars movies that some of the things that we can do to disrupt some Death Star operations include disabling the ion cannon systems, exploiting vulnerabilities by destroying the reactor, disabling the tractor beam, tampering with sensors to mislead battle station readings, disable the protective shield, command and control takeover of the command station computer, mind controlling officers. Now that one's interesting because that's only really in the realm of the Jedi, and jamming communications throughout the ship. All right, now let's actually go through and apply some frameworks to showcase really how to think about some of these threats and how to apply some mitigation candidates to it. So in this first case, let's talk about a vulnerability. So a vulnerability is any weakness known or unknown in a system, process, or other entity that could lead to security being compromised by a threat. And a threat is an action, an event, an occurrence, or a circumstance that can harm, disrupt, destroy, or otherwise adversarially affect an information system. So in this case, a vulnerability can be the thermal exhaust port. So by this action, it's an exploitation, and an exploit means to take advantage of a vulnerability. So in this example, Luke Skywalker is exploiting this thermal exhaust vent that from information that we received from rebels afar, thank you, Jen Urso, by launching torpedoes into the vent, impacting the core and triggering a catastrophic explosion. So now how can we mitigate against that? Some mitigation candidates or strategies can include eliminate the 2-meter wide thermal exhaust port, or safeguard this exhaust port with extra defenses and perimeters. All right, now we're going to use the Stride threat modeling framework for the rest of these so that we can really see how this framework with how we created our threat model, how we have our attack tree can help us identify and mitigate against some of those identified threats. So here we're going to go down with the whole Stride framework. S is for spoofing. I like it. It's kind of like, a child's book. And this property is authentication. The definition of this includes, threats that involve an adversary creating and exploiting confusion about who's talking to whom. In this example, impersonating stormtroopers to hijack communication systems and to save princesses is done so by Han Solo and Luke Skywalker in Episode 4. And, we like to impersonate stormtroopers a lot throughout this Star Wars universe, but for this example, let's use that one. A mitigation against this could be to, put in some more authentication principles, for users or for machine identities by enabling more robust and multiple identity mechanisms, such as multi-factor authentication, could make it so we then authorize the stormtrooper or the machine that's talking to us so we know that we're talking to who they say they are. So tampering. This property is also integrity. The definition of tampering involves an adversary modifying data, usually as it flows across a network, in memory, on disk, or in databases. However, in our example, Obi-Wan Kenobi is tampering with the tractor beam system to allow the Millennium Falcon to fly into the sunset. So also in the original trilogy, Obi-Wan Kenobi dispersed from the droids when they were landed on the Death Star because their ship was trapped into the Death Star's tractor beam, so no one could really escape from this scenario. So this is Obi-Wan going and tampering with that system to make it so that the Millennium Falcon could actually fly away. So a mitigation against this could be to add validation, such as credentials, codes, safeguards, cameras, guards, and having limited access to a device like this to turn off the whole tractor beam system. So repudiation. This threat is repudiation. The property is non-repudiation. In the definition, repudiation threats involve an adversary denying that something happened or claiming to have not performed an action. In this example, Han Solo saying, "There is a very dangerous reactor meltdown," an attempt to stage a divergence away from Luke Skywalker and from Han Solo trying to save the princess from the prison division. In this mitigation, we can think about ensuring proper, observability solutions are in place to track down adversarial behaviors and logging some of those behaviors, as well as, coming and checking in on those every once in a while. And, we see that there is an immediate reaction of stormtroopers going to check out this false alarm. All right, information disclosure. Now we're on I in the STRIDE framework. Information disclosure is a property of confidentiality. In this example, the definition is exposing information to someone that's not authorized to see it. In this example, Jyn Erso relying critical Death Star vulnerability information to the Rebel Alliance really set the stage for all the Star Wars movies. So in this mitigation, we could think of a thorough understanding of your asset inventory. We like to, in cloud computing, we like to have like secrets management and inventory so we can have a better understanding on what kind of secrets there are within the project, if there are rotation strategies involved with those secrets, and making sure that public exposure, highly important information is not available for everybody. All right, D is for denial of service. This is the property of availability, and it's to deny or degrade service to users. In an example, Chewie jamming transmission channels for a TIE fighter. So, this happens a lot where they jam signals in Star Wars. However, we can think of some mitigations against this, right? Ensuring that communication channels are encrypted and only verified users can access those channels. Also, practicing redundancy, such as backup channels being available, could also go around some of these jamming scenarios that we see so much throughout Star Wars. And last but not least, E stands for escalation of privileges, which is the property of authorization. So elevation of privileges, elevation of privilege threats involve an adversary being able to do something or obtain the rights to do things, which they have not been authorized to. R2-D2 hacking into the Death Star system to open doors and extract information is a really great example. R2-D2 is such a little hacker. In every single Star Wars episode, I'm sure you can see some type of droid extracting information somehow. So that is something we see pretty regularly throughout the Star Wars movies. And the mitigation against this would be to put checks in place to verify that appropriate access levels are there when each request is coming down the pipeline, so that we can ensure that only, the privileges remain least privileged throughout the system. And last but not least, we want to continuously iterate and verify our threat models. A lot of the times I see threat models being created one time and then never updated. We should really think about these more as, DevSecOps practices to always continuously iterate and verify and update to make sure that we are all on the same plane and understanding all of the risks together as a team to be, to drive requirements and to understand some of the risk and implications that happens if some of that risk gets, exploited in any way. Here's some learning materials. I can drop that into the chat for anyone who's interested in learning about, the security development lifecycle that we do here at Microsoft. It's actually quite an extensive process that all product teams at Microsoft have to follow. And one step in that security development lifecycle is generating a threat model. So we do it a lot in Microsoft. We do this practice, and it's pretty successful for the most part when creating software. I am also going to throw in some Microsoft Learn security fundamental training. It's pretty quick, but it will give you an understanding if you're pretty new into this topic, as well as some information on some of the frameworks that have been covered over today. And thank you guys so much, and I'll be asking questions during the questions section.
Hello, Audrey. Thank you very much for your time, for your presentation.
Thank you.
It was very nice. So I will welcome now Gabriel and Elkhan. Hello, guys.
Hi, guys.
Welcome back.
Hello.
Welcome back. I'm sorry, but my light is not good. I don't know if you can see me. But anyway,
yeah, you need to come out of the shadow, Gustavo.
Yeah. So, guys, let's see a few questions that there are just a few questions here. I don't know if you are watching us and you have more questions, please send us. We have here a few questions that I will start with Gabriel. Gabriel, what is the difference between GitOps and infrastructure as a code?
Okay. So when you're doing infrastructure as a code, you actually, at the end, the last mile happened manually, the same that you are doing in other infrastructure that's not a code-based. When you actually deploy the code, it happened with a deploy button or with a script that initiate by the Git environment, but the SCM environment. GitOps is where the Git do the operation, but the initiator is actually the environment themselves. So if we look, for example, on the Flux architecture or the Argo CD, the only entity that can initiate deployment is the Kubernetes cluster itself, and not the side of the CI/CD on the source control side. So GitOps is actually better enabler for infrastructure as code than just doing infrastructure as code with the native tool that's running it. Hope that answered the question. I don't see any chat or something like that. Maybe I missed something.
Yeah, it's not on this one. I believe it's on the when you log into the Geekle kind of platform, then you can see some questions and chat.
Oh, got it.
Yeah. May I add a response to that, Gustavo, to that question?
Sure.
Yeah, sure.
Yeah, I will just add what Gabriel, kind of mentioned. So
yeah.
I think with GitOps, you're more thinking about operations, right? Like not just, you declared your code as infrastructure and it's sitting somewhere where you can deploy it, or manage it in a way that you want, right? It's up to you. But with GitOps, it's more of a kind of, I would say, holistic process, right? You look at it as a whole from the beginning to the end in terms of, initiation of that code, versioning that, deploying, reverting it back, and managing it. So think about from operations perspective as a GitOps, while infrastructure as a code is more of a how you want to declare your code, infrastructure resources, so to speak.
Okay. Very nice. Thank you very much. Would you like to add anything else to that, Audrey?
No, I think that they actually answered it pretty well.
All right. Thank you very much, guys. So the next question: what is the best way of modeling your GitOps environments?
Again, what I feel is like if you are on cloud native realm, you're lucky because you can just use one of the tools that do everything for you. In my opinion, for anything related to GitOps, the first thing is asking yourself the question, am I pushing code to production or am I pulling code from production? And this mindset actually helps to define the way you are deploying things. And think of it this way. I know a lot of organizations. Most of the organizations that I know, before they deploying to production, they have like personal touch on this deployment. This is the VP R&D that click the deployment, the team leaders that has the permission to click the deploy button on GitHub. In GitOps world, this is wrong because this is mean you are always pushing and your life cycle is managed with hooks, is managed with something that can break the structure, can break the versioning, can break the control that you have from the automated tools that you implemented. So asking the question of how do I make my environment to pull the changes instead of pushing them is help to start with the designing the points, the entities that control the GitOps lifecycle.
Okay, Gabriel. Thank you very much.
Thank you.
Would you like to add anything else, guys? Nope.
Nope.
All right, let's continue. The next one. Elkhan, what is the difference between configuration management and IAC?
Okay, so basically IAC is, again, it's about declaring your resources and configurations as a code, meaning that at that point you want to make everything declarative, right? So you want every detail to represent in your code so that you can have a proper understanding and plus visibility into what are the resources and what are the appropriate properties that you put in the configuration. With configuration management, it's a CM, it's a different. So with configuration management, you talk about some process and tool how you manage the change of the configuration, which can happen, which should be different in my opinion, depending where you are deploying. Are you using a dev environment, staging, or production, or any intermediate environment where you are deploying your resources? And as an example, just to give you in terms of configuration management, right? If you take from the perspective of the storage account, there are like premium tiers and other tiers when we speak about the cloud, and there is no need to deploy premium tier service into your development environment because you are not going to use that, right? Because mainly it is used for the extended support and as well as replications and other wonderful features that premium service may provide. So it's just a waste of, I believe, resource if you do that for the development purposes where you don't use that. So configuration management, again, it's all about how you want to manage the different configuration of your resources based on the different environments where you want to deploy. But with infrastructure as a code, it's all about how you declare them and make sure that they are visible and they are understandable as a code.
All right. Thank you very much, Elkhan. I have one question here for Audrey. How do you analyze? Oops, no. How do you analyze a threat model?
Yeah, so when you're actually creating your data flow diagrams, having a big understanding and having all of the services in the system mapped out on a data flow diagram, then you could apply some of those threat modeling frameworks that we talked about in the presentation. I use Stride. So when you look at your data flow diagram and then you apply one of those threat modeling frameworks to that data flow diagram, then you can really start to think about misconfigurations or potential, unprotected endpoints, or let's just say like not using TLS. is something I've seen a few times too. And you don't really start to understand that bigger picture until you see all of the evidence in front of you, until you really have a comprehensive map on what you're actively already doing. Then you can't understand what is missing or what you need to do to mitigate against it. So I think that, just trying to get as much information as possible, diving deep into some of those services that you're using and seeing if there's any types of like security baselines, for example. I know Azure Services has a lot of these security baselines out there per service that you can really dive deep into understanding, some of the best things or worst things that can happen to the service. And then you can jump through, your resource groups, or you can actually look at your resources, go look at the code base, see like what types of tools your developers are using, or even try to help enforce some of those tool usages, or like go into the subscription and say like, oh, okay, you misconfigured this, which I've seen a lot, it happens a lot. Development's hard, especially with a lot of the cloud services that we have today in Azure. Like a lot of them you just turn on and you don't think about it, or you deploy it and you don't go look at it. So we just need to be vigilant and double check some of that, some of the things that we're currently doing in development.
Yeah. Thanks a lot. Another one for you as well, Audrey. Can you talk about how incorporate? Let's see here. Can you talk about how incorporate risk, likelihood of threats in communications of risk to stakeholders? What happens when an executive doesn't understand the diagram?
Yes. So actually, I work with this a lot. So I do threat models, with customers. And a lot of the time I'll walk with the customer and, create threat models with them. However, I don't really like to do that unless there is a security stakeholder from the customer's, side of the house. Or for example, if you're a developer, then meeting up with your security team to have that kind of stakeholder presence. Because it will happen. Like people won't understand the diagram because potentially they might not be super integrated into the project. But when you start to, compute and give them risk scores and calculations and mitigations and saying like, this is a potential bad thing that could happen. Because, unfortunately in security, we work all around risk and it's not super quantifiable. It's just, this could happen or that could happen, or this could make your security posture better, right? So at least understanding, when you're talking to an executive that doesn't understand the diagram, just taking a step back and just saying, at a high level, that's another reason why we like to, put weights for each of the risks and mitigations that we find to showcase like, okay, here's your total list of risk. Here's your weight of how critical this would be to your system. Like I see this happening all the time, like TLS, HTTPS, like, those are pretty no-brainers, right, for a lot of us. But they do get missed. And like, just saying like, hey, this is an easy win. It's a really easy code change. You could do that and then your risk will just like substantially drop. Or, I'm sure that you can partner and really communicate back those findings really well with honestly anybody that you're showing this threat model to, which I would hope would be a lot of your engineering teams and, project leads, TPMs. But yes, they do sometimes go to the C-level suites. And that's when it does start to become a different language.
Yeah.
And Gustavo, I want to share another thing which is funny, but it's actually very true in our industry. That's like in terms of attention that we get into the security and this threat and making sure the servers are secure are actually in a back burner, meaning that they are usually not the first priority. But if security incident happen and there is, let's say, a breach or something, then you would see that it escalates very on top of everything. And at that point, even that executive that doesn't understand the diagram, believe it or not, he would understand that very well. So what I'm trying to say is that security is a team sport. It's not something that's usually executives come first, but explaining them, as Audrey said, the potentials, the probability, and plus, hey, this is something that's going on and we can get this hit very bad if we don't act at this moment. Raising the awareness, I believe that's the biggest issue that probably the developers and security analysts, maybe they don't have enough voice to raise that or put that in front of the first queue, so to speak, of priorities. So that thing, I believe, at that point, one of the ways that I worked with my team members in security is that to make sure that we bring some samples from stuff that already happened. It can be breaches that already happened. It can be other kind of things. So just raising the awareness, I believe, is very important, especially when we deal with these diagrams or potential things that already happened, so that from executive, so to speak, from executives, we can get the enough support and sponsorship to make sure that that critical work is done and not put on the back burner.
Very nicely said. I agree with absolutely everything you said.
And just to give, as far as I remember, on Uber, that happened on Uber like a couple months ago, maybe 6 months ago, they were not hiring any security engineers, anybody else. So after a breach, there was like 50 openings for security analysts and threat model design, everything. So that again shows that again focus was not there of the business, but once it's happened, it's a reputation. It's late, but unfortunately, that's how it is done. Has been done so far in the industry.
Yeah, I've seen a lot of these examples that companies that they don't make an assessment of the risks, and then something happens and they spend like a lot of money. So they lose data, they lose money. So it's a lot of people now these days they are having another look on the risk assessment for sure.
Yeah, but in addition to money, it's also reputation, right, of the service. If it's a hacked and insecure service, just think about that. The customer base that the private company is losing is going to be huge. So it's going to be very hard to bring them back, no matter what.
Yeah, for sure. Thank you very much, guys. Very nice question. Elkhan, which problems are best solved by infrastructure as a code?
Well, okay. That's a good question. So I would say the best problem, I wouldn't say best problem, but I would say very very important problem that it solves is the compliance and visibility into what's happening in your environment. It solves the issue of control over your environment and understanding what's going on. But in terms of problem, the biggest problem is that it solves, in a simple language, it's a consistency. It solves the issue of consistently having the same environment and configurations across different environments that you want to deploy, and being sure that what you intended to have there, the services and their configurations are set right. So consistency, I would say, the biggest thing. Plus, of course, compliance.
Very nice. Guys, would you like to add anything? Nope. Yes.
No, just thank you so much for inviting us to DevSecOps Global Summit 23, and it was great. It was awesome. Like, super happy to be here, and really appreciate the opportunity.
Yeah, thank you
Yes,
all,
thank
guys.
you.
Oh, I'm sorry.
Sure,
Go ahead,
sure.
Lisa. Go ahead.
Yes, thank you. Thank you, everyone. This is our last block of our first day. So thank you for your talks, for your knowledge, for your expertise that you sharing today. Thank you, Gustavo, for your help. As always, you are amazing moderator, and I will hope to see you tomorrow. So thank you, Gabriel. Thank you, Elkhan. Thank you,
Thank
Audrey.
you.
It was nice to see you today. Unfortunately, my colleague Mira cannot continue this project, but I'm happy that I have possibility also to be a part of this amazing event, and hope to see everyone tomorrow. We will continue with our senior day. So feel free to write your feedback after that day. We will send you feedback form. Your minds, your impressions are important for us. And let's stay in touch for our future DevOps Global Summit. Thank you, guys.
Thank you very much for having us.
Thank you very much.
Thank you.
Thank you.
Enjoy the rest
Bye-bye.
of your day. Bye.
Ciao.
Bye-bye.